Okay, so we got to do some editor control stuff, but I just got back from the shop, printed off these parts, and I need to get situated for doing C code now. So I'm going to do the after shop summary at some other time because we are on a time crunch here. Actually, I probably shouldn't open the whispers on the public screen. Let me move this up here, see what people are whispering to me here. Something, something, something. It's not much more difficult than people think because. So I gotta do push-ups. I gotta do 50 push-ups. I'm gonna do 50 push-ups every hour until I get. Yeah. So yeah, one of my friends was just talking to me about Win32 code. Yeah, Win32 code is not that bad. It's really only that bad if you're not used to C code, then I can see how Win32 code would be kind of bad. Also, did I name these things wrong? So this thing is supposed to be not a 13.5. This is supposed to be a 3.5, right? So all these function names are wrong. So let's change that really quick. So this is supposed to be 3.5, not 13.5. So let's fix that while we're here. And then also let's open this in Explorer and also change some of the file names as well. So we didn't change these at the shop, so that's fine. But these names here need to be changed. So instead of this 13.5, that was incorrect. So let's just quickly change all of these to 13 by 3.5. So 13 by 3.5, not 13.5. And then we're going to go do our push-ups. So let's get this going. Let's kind of just change these names. I can't believe I was that stupid earlier, but I was being stupid. So we also need to change the in the root folder where we keep all of our pictures, right, we have scrap sheet, and the scrap sheet name is also wrong. It's not 13 by 13.5, it's 13 by 3.5. So let's just change that name. And then let's also commit our changes before we end up in more trouble because of, merge conflicts and whatnot. So let's go here. Let's do a git bash here. Let's just push this up. Then we're going to do our push-ups and get to our C code and all that stuff. So git status. Git add dot, right? We changed the file name, so it thinks we deleted a whole bunch of stuff. Git status. I think it'll be smart enough to detect a rename, yep. And then git push GitHub and then master, so just push that up to GitHub. And then once that's pushed up to GitHub, we'll be good to go for there. We will do the, that's weird. Oh, yeah, because do we not add those? Git status. Git commit, duh. Rename. And Control C. Let's try that again with the correct closing quote. Okay, now git push GitHub master. Push that up. We're going to do our push-ups. We're going to do our 50 push-ups, 50 crunches, 50 squats, all that stuff. We already did our trampoline jump, so I guess we're good there. Okay. Yeah, so we're good. We're good there. Let's close this. Let's close this, and let's close this editor, and let's move our editors for the C code. They're on our other monitor. We can now kind of just move those back down here, and we're good, right? So that's not too bad. So put that over there. Put that over there. We're ready to do some C code, but I need to do push-ups. So let's go to our Just got my push-ups done. Oh yeah, so I can show you what I'm at now. I'm sorry, I just let me stop that. So that took me like what, 7 minutes? So yeah, Fragfix, are you hosting me, or did I just lose my viewership because I was off doing push-ups? Well, anyways, let's get going. Let's do this. Okay, so we need to get zooming controls, and we also need to get the actual editor functions working. So we have 2 viewports that we very much care about. Actually, we have more than that, but we care about, for the on-screen viewports, we have VP0 right here. So VP0, and if we want to make sure that, you know, VP0 is correct, we can say, you know, VP0 and type means, and look up the definition really quick. Viewport 0, destination / screen viewport. So that is correct. And VP0 is actually going to be situated within a canvas viewport, also known as a, you could call it canvas viewport, or you could call it, what is the other thing I call it? Let's go look that up really quick. So we have a VPC means, what does that mean? Viewport canvas or Windows / OpenGL. So it's like a client area. So VPC is viewport canvas or a client rectangle, right? So VPC here is, let's put that in the middle, VPC. And that is, you know, canvas / client. So this is the canvas / client rectangle. And, you know, if we want good camera controls, we have to manage these selection rectangles properly. Otherwise, we're just going to be up a paddle without a stream, up a creek without a stream, something like that. So let's close some of this stuff and say, hey, I got this kind of like thing here. We can close this. Let's just start closing stuff that we don't need for now. There's a lot of stuff that I'm like, maybe I need it. Let's just start off with a clean slate here and just start finding stuff based on, right, like if we have to reopen a file that we already closed, I think that's fine. But I think we need to find our way around the code base anyways. And keeping stuff open for too long can just fatigue your memory as far as knowing what goes where. So let's look at this. Let's go find where we can control this. So I know that in our PAINT5D system, we probably have some functions, and we probably have some functions that are explicitly for the camera controls and whatnot. So let's go find the input handler, or the handlers. So let's go find where they are. And I'm thinking that maybe we want to break some of this code into separate files. So I think we're going to do that because this is getting out of control. So let's go find where the handler code is, because I have no clue where it is. There's tons of stuff in here. So let's say it's handle something or other. And if we look for this, we can find, oh, keyboard handler section. How wonderful. And so this is PAINT5D keyboard input. And then what do we got here? So we got some debug stuff. PAINT5D system data, blah, blah, blah. So yeah, here's our camera control tile value. So this is nice, right? So what I'm thinking is for certain functions, we're just going to break them into, I think we want to just break some stuff into some separate files or something. I'm not sure what we want to do yet. But let's go look at what kind of controls we have here and figure it out from here. So do we already have controls for the window controls? I believe for the zooming in, zooming out, moving the viewport and all that stuff, we should. So let's look at this. We have A, B. Now why the heck is it? Oh, offset back, right? That's what that stands for. Camera control. So we're in camera control. So left, right, up, down, zoom, etc. And right now we have, let's go look at our key bindings. So let's open up our key bindings. And keybind dot data. We can, and it looks like I kind of got screwed because it looks like, is there anyone in here still, or did everybody leave by the time I got back from push-ups? Users in chat. Well, there's some people that I don't recognize, but that's fine, whatever. If anyone wants a technical demo, I can give a technical demo of what's going on here. Like, if anyone's new and hasn't seen my stuff before, I can totally get into that for you. So let's go look in here and find what our keyboard bindings are. We're gonna try not to change these for a very long time. So let's go look at this and see what we can find. So left, so let's go figure out where that is. Okay, so we're going to do this hackish kind of thing and just reference these. We don't have any autocomplete, so we're just gonna reference this, right? So this one is J, right? And left, right, up, down, and zoom out, zoom in. So this is all the same stuff. So let's just take this and insert this right here, right? So we'll take it and we'll go Control V, paste that in there. That's not really what I wanted to do. Let's just keep it like that. I don't care. That's fine. So now that we know what these keys are, we might want to also put those in our notes, right? So we got this notes file. We should kind of put all the very important information that we want to look at as we're doing this task into our to-do file for our notes for how we're going to manage this. And we have the camera controls. We got move camera and we got zoom camera. So that looks like all the stuff we kind of need for this. Now, we also need to figure out where VPC is, where that is being controlled. And so if VPC is probably not in key bindings, actually, let's make sure it's not. So keybind.data, if we go Control F and look for VPC and don't match case, we're going to find it's not in here. And we're going to just close this, and we're going to look into the Tau Depot, which stores variables that are stored on texture memory. And why are my headphones unplugged? Is that why I keep on not hearing those little sounds from my computer? Hold on, let me plug in my headphones here. So just gotta, hold on, plugging in headphones. Here. Okay. So over here, you have some nice diagrams of how we're laying out the pixels that store different variables. And within here, we should find something for viewport C, right here, VPC. So we're going to look for VPC here and see if there's anything else, or if it's just, P5D, VPC. Okay, cool. So now, this variable right here, is it referenced anywhere else in any other files? Or if it's already referenced in other files, then we want to, then that might be the code we're interested in. If not, we're going to have to edit it. Okay, so find all. And VPC needs to be set when, okay, so right here we see Tau Depot data, we have some other thing in here, PAINT5D functions, and updates. So let's go look at this. So, okay, this thing right here. Okay, let's close this. So store viewport, call, cast, something. Yeah, so viewport C is being stored here. And so the question is, where is all this coming from? Okay, we got this code here. Put rec inc all. Okay, so we're putting the viewport C. So there's a lot of things we're putting here. Do I actually use this, or am I just like, is this just some type of thing that I added that I never did anything with? So let's look at that for a second. So it seems like it's here, and then it's also here. Okay, cool. And right here, where is this? Is it when we're adjusting the screen, or initialize or update viewport rectangles. Excellent. So the client width. Okay, cool, cool, cool. And calculate the canvas viewport that covers context. Okay, client width -1. So VPC, that's excellent. Calculate destination viewport square inside canvas viewport. Okay, so this viewport looks like it is client width -1. Okay, so x0. Okay, so we're taking this. Now I don't know. Okay, so this makes sense. Sure, why not? Now when does this get set, right? And why is it this, right? Like, why is it client width and client height? So if it's client width, okay, we're in setting. I see. We're in setting. So we're in setting. This is an inset, right? So we're recmin. Yes, this is some type of inset to get a square viewport. And I'm going to take a guess that this square viewport right now, we got some asserts here. Okay, cool. There's some asserts we're missing, though. So I'm fairly certain that VP0, the destination viewport, should be like square. And I don't see any asserts for that. VP1 does not necessarily have to be square. We may change that, but VP0 should definitely be square. So let's just add something here. Assert destination. Assert VP0 is square. Right, so let's make a little note here, and then we'll kind of go from there. But this looks like the code we want to be editing. So let's go in here and just say, right here, just say assert, VP0 x1 minus VP0 x0, right? These two minus each other plus 1. And just make sure that that bound is equal to the same thing on the y, right? So we're just going to take this viewport size on the x, and well, actually, we just want to... Yeah, sure, that's fine. So assert that this equals same thing, but on the y-axis, right? The x and y widths are the same. So if we take the y1 minus the y0 plus 1, we're going to assume that's going to be equal to the x, right? And so we might want to add this in here and just say, at vid IID, and the video ID is 151. So at vid ID is 0151, and the time is 25 minutes, and how about 5 seconds? Sure, why not? 5 seconds. Extra assert because we are paranoid. All right, so we're going to add this assert because we're paranoid. And then the other concern I have is if we are manipulating this with user controls, does this create a problem for us? So let's say, at let's just call it at possible problem. I don't really have a good name for what I want to call this thing here. But yeah, this is a possible problem here, right? That if we're gonna set the this is the sampler viewport. It's basically our camera controls. VP1 is basically what gets edited when we're zooming in, zooming out, and etc. So this could be a possible problem. So let's mark this as a possible problem. And also, do you want to reload it? Sure. Let's go into our hashtag documentation and just make note of what possible problem is all about, right? So if we see something that is tagged as possible problem, that means that, you know, it might be a problem, but not necessarily. It might be a problem, but not necessarily. More understanding of code would let you know, for sure. Okay. And then we can make @vid ID. When did we document this? 151, and the time is 0027 and 23. And is my bitrate okay? My bitrate is kind of crappy right now, but oh well. Okay, so now that we have this, let's just start getting some feedback on this. Or actually, let's search for where this function is called. So initialize or update viewport rectangles, right? So if we look for this function, can we figure out where that's coming from? And is it being used for testing? Is it being used for when we update the window? PAINT5D init. So when it initially gets initialized, that's when we're setting this rectangle state. So every time we go back to the editor, we are going to reset the viewport. And you know, that's fine. I'm fine with that for now. Also, if anyone wants to see my demos, because I see somebody just kind of popped in here. Oops, sorry, that did not work. My shortcuts sometimes do weird things. Hold on. There you go. If you want to see my demos, they're right there for you. Let's see who's in chat. Users in chat. That's weird. It seems like there's some lag, because now it says 2 viewers when no one shows up in chat, but whatever. Okay, so we got this going. The next thing is to get these rectangles to show up within our shader code. So let's go open up our shader code for a second. And so it's going to be in, is it in PAINT5D? Yeah, it's in PAINT5D default shaders. And it's not actually this stuff, though. It's P5D 10GL. I should probably have not broken it up like the way I did, but oh well. But in here is the fragment shader for how we kind of like rendered a screen. So what do we got here? So we want to eventually get rid of these hard-coded variables. Let's not worry about that right now. We just want to get camera controls. We'll worry about this later. And there's a lot of crazy stuff going on here. So, canvas user view. Okay, the canvas user view is decided how. How is that canvas user view decided? It is decided based on the fragment coordinates. There's no transformation of the canvas user view. If the canvas user view is in bounds, we do some rendering. Okay, cool. Okay, so the first thing I want to do is map into VP0 right here, right? So I want to map stuff into VP0. Boy, this is going to get kind of complicated, isn't it? So, so we have some hard coding, don't we? We have some hard coding up here. We're just going to have to hard code some more stuff, aren't we? So let's just do, I see I have a @hardcoded. That's not a very good tag the way I wrote it. @hardcoded. Let's do @hardcoded like this. I think that is actually going to be more searchable. And let's make another one of these @hardcoded, right? So if we see something @hardcoded, we want to eventually get rid of it. But P5D VP0, right? Is it VP0 we want first or VPC? Well, VPC should already be snapped to the client area, so we're not going to worry about that right now. And we're just going to grab this, this thing here, and we're just going to steal it and call it, hey, we're just going to call it, you know, VPC, or P5D, PAINT5D VPC, and then call this U32, right? So it's a U32 version of this. And then we'll say, oh, we got U32 VPC U32, or, sorry, P5D VPC U32. And then we also have an int32 version of this, which is kind of wasteful, but right now, P5D VPC, and let's just say I32. I don't like how we did this. Let's just do U32 and I32 versions rather than make a more terse version, make them different lengths. So this stuff is good. Now we have to unhard. We're going to keep this message, right, because we got to figure out what the exact value of, like, these values here are okay, but this needs to be P5D VP0. So whatever VP0 is, and I'm wrong here. Why did I do that? We want VP0. My bad. VP0 right here. VP0. Highlight that. Yeah, that's what we're looking for. So if we go into Tau Depot and figure out what we hard-coded these for, we can look at the macros, and we can see a VP0 is hard-coded to 1, right? So that variable is stored in this. This is a index location that specifies a certain pixel on our texture that is storing this variable. Which is kind of crazy, but that's the way we're doing it. So VP0 looks like it's set for 1. VP0 is set for 1. So if we go into our shader code, we can say, hey, you right there, you're hard-coded at 0 right now. We will figure out how to unhard-code this later, but first we just want to get something working. So the first step to this is we just want to run it like it is and make sure that nothing has blown up in our face, right? So actually, well, not, God damn it. So we just want to... blah, blah, blah. I guess we're just /AAC 2020. Sometimes I'm one of those people who just keeps on pressing up forever, and then it's like, at some point you just gotta type the command, you know? Undeclared. First use P5D VPC U32. Oh, right, because this is viewport 0, because I screwed up. Okay, cool. And I'm going to get on Discord while I'm at it. And who was it that I was looking for? It was like Josh Chat. Gonna look for one of my friends on Discord. So unused variable. Yes, it's unused. God damn it. So we're going to take it a little bit further. I guess, can we take it a little bit further? I am scared to take it further, but let's take it further, because instead of making some no-ops, let's just get it working. So what we want to do is we just want to map coordinates inside of here onto the proper range for this canvas user view thing. So right now, where is canvas user view being? Canvas user view coordinates are being kind of calculated right here. So we're going to move this canvas user view coordinate stuff, and we're gonna move it down. Ostex, whatever the heck. Let's try to consolidate. Let's call this canvas user view. So we want to get the canvas user view coordinates, right? That's what this is. And I believe if we're formatting everything 1, 2, 3, 4, this needs to be indented like that because of the way we're going to pre-process this code. So let's just do that, right? So this is kind of weird. Put this over here, move that around. Okay, get canvas user view. And right in this section, get vars stored in texture, right? So what we're doing right here is we're getting variables that are stored in texture. So 1, 2, 3, 4. So let's make a note of what we're actually doing over here, right? So and just kind of organize our stuff a little bit better, because, you know, this shader code is kind of out of control. And 1, 2, 3, 4, so that looks good. Is that all aligned? That's good. We can also indent this nicely, right, because that is what we're doing here, and this actually fits. Actually, if we do this, though, we might want to indent like that, add another thing there. And then over here, kind of change our indentation slightly over here, because we're running past our column limit. So we got 2 parentheses and 2 parentheses, right? Okay, cool. So that's all indented correctly. We just have this way out here because we want it to be obnoxious until we unhard code some of those hard codings that we're doing. Okay, so in this section, we're getting the canvas user view location. And we want to manipulate how we get this. So right now we're using the fragment coordinate to get this user view, but we want to do it a little bit differently. We want to pass in something related to, we want to do some mapping. We want to do some mapping, so this fragment coordinate, we just want like, let's just call it, you know, int32, discrete. How about IV2, IVEC2, thick for frag integer coordinate, right? So it's a frag coord, but it's discrete coordinate, right? Let's see, anyone here? Nope. Damn it. I was doing push-ups. And okay, so yeah, so let's call this like fragment integer coordinate or something like that, and we'll just initialize it. We'll declare it here, and then we'll set it to these values here. So right now, let's just take this and say, you know, fic.x equals this formula here, right? And then we'll say, you know, so this is fic.x now, and then fic.y, and actually let's not make it all capital because it's not a macro, so let's not do that. Let's just call it fic, right? And then we'll just say fic frag integer coordinate, right? And yeah, fc.x. So the frag coord x minus 0.5, make it an int32. That's how we get that. And then we have this crazy formula over here for the other thing. So let's just steal all of this, right? Let's steal that, and let's paste it over here. And then let's adjust the formatting, right? So it's just, you know, make it an int32. Is this wrapped correctly? Yeah, that's wrapped correctly. Cool. And then we're just going to hijack that, right? So we just have another intermediary variable, right? So canvas user view.ix equals the integer coordinate x, and canvas user view y equals the fragment integer coordinate y. So we haven't really changed anything yet. We do want to just get this code compiling first before we take it too far. So we're going to add more no-ops just to get this working, right? We had a no-op somewhere in here, didn't we? I thought we did somewhere in here. We had a no-op. Let's just put some no-ops in here. So this VPC U32 is not quite correct because we need to be able to get a this isn't gonna work, is it? We need to get IVEC 4, right? And I don't think we have a thing for this yet, so let's just call this get IVEC 4, right? So we're gonna get int vec 4. Or do we have something else for that? Let's look for tau depot get and see what kind of functions we have here. Did we have another thing stubbed in for what we wanted, or did we not do that yet? Does not look like we did it yet. Okay, so do we just want to call it int vec 4, or do we want to make a rectangle type, or what do we want to do here? So I think it's going to be easier if we just use an integer rectangle. Yeah, fuck. So it's 10, so I need to do more push-ups. So here's what we're going to do. We're going to just get this compiling first. And then, rather than getting an IVEC4, let's make our own type. So let's say, we got this UVEC, whatever the heck, and we're gonna steal this signature here, because we are going to need pixel index, texel fetch U32. Okay, yeah. So let's steal this. Okay. And we are going to, we're going to make a version of this that doesn't get a U32, but it gets what we need in order to have a rectangle. So, this rectangle, the rectangles should be, when we're getting a rectangle from here, it should just be a U32 kind of rectangle. So we're just going to say get rec, right? Tau depot get rectangle, and this variable must be a, so this example here is actually a bad example because we're not going to get a rectangle here. Example right here would not be this. It would be like offset dex, right? AD. Yeah, that would be a better example for over here. And this could be, this example could actually be this thing, right? Because that's what we're going to use this for. But this thing is better off. This is better off as example as offset dex like that. Okay, so we got this get rec, and it's not going to return. This is going to return a rectangle type, but let's make sure that we have rectangle type is correctly defined, or what's going on there. So whole word for a second. Doesn't look like we have anything here. Let's just jibble some stuff in there. And let's go look at our macros for what we have for different types, right? So we got like UVEC4s, etceteras, and we do not have any type of macro for types. So we're going to create a struct for that. And that struct is going to exist in our common code, in our fragment shader common code, I think. So rectangle is always going to be unsigned 32-bit. So yeah, that looks good. Yeah, let's just do that. Let's throw that in there. This is going to get crazy. This stuff is getting crazy, but let's just do it. So define a rec. And this is when running as GLSL code. So we're going to say... does it need to be in poly OGL? No, it's going to be in, you know, AAC 2020, fragcom, and rec. Actually, struct, right? So the fragment shader common code, and we're going to make a rectangle type. And then over here, if we have a rectangle type, it's going to be in AAC 2020, poly OGL, and a rec, right? So if we want this to work both on the GPU side and the CPU side, polyfill on the CPU side, different thing on the GLSL side. So let's go open this up and look for where we can find this. So in our library, we're going to find polyogl, and we have polyogl functions, and inside here, we're just going to paste this up in the bottom, right? These are functions, my bad. We want in our lib, we want polyogl structs, so polyogl data is what we actually want to look at. And all these different data types do not paste into GLSL code, so all this stuff, none of it should depend on anything else. float vec4, float vec2. So right here, we're just going to say, you know, struct AAC 2020. Let's just steal this. Let's steal this for a second. Right? And then we're going to call this rect. And then we're going to duplicate this. And then we just want a... do we just want to make this integer just to make it easier to work with? Actually, I think we want to make it integer, right? Because we can cast it... The function we're using to fetch from the pixels, we can just cast to integer, right? Because everything else, it's really much easier to use the code if everything's casted to integer. And when we're fetching a rectangle, the rectangle is stored as an unsigned integer texture, but it's but when we use it, the use case is always going to be a signed implementation. So let's do that, right? So let's say x, y, so, or x and y's, right? So x's and y's. So x bounds and then y bounds. And then we might also want to make a commentary, right? We've been making little commentaries for every single thing we have. So it might be nice to just say what this is about, why it's here, right? So we might want to say something like, you know, and also it'd be nice to... Actually, let's not do that. At vid IID, the video ID is 151. And the time is... Also, let me check my Twitch. The time is 0047 or 48. And let's just say 10 seconds, because it's going to take that amount of time to type this out. And so what are we doing here? So we decided that even the rectangle is stored as uint32 values, it makes more sense for functions returning rectangles to return signed. Right, so a little bit redundant, signed I32, but you get the point, right? Yeah, so it makes sense that, you know, we're never going to have implementation where we really want to use an unsigned rectangle in our shader code. It's just gonna be easier on our life if we just make this signed. So this is signed, right? These are signed. So a rectangle type is, by default, we're just going to make it signed. Even though a rectangle should never be negative, it's just going to be easier to detect when we do integer overflows and underflows, right? So, never negative, but use signed for ease of use, as well as underflow, right? So this is never negative, but it's going to be easier for us to work with if we, right? It's not, none of these values are ever going to be negative, but how about at never negative? Let's make at never negative. So it's negative or negative, but we may make it a signed integer just so that we can see. Underflow will be much more obvious if we use a negative, if we can allow it to go negative even though it should never be negative. So in our hashtag documentation, we'll just make a note of never negative, because I'm going to guess that we don't have... Oh, we have an at never negative. Excellent, excellent. So it means the number value can never be negative, however it might be 0. So 51 time, and the time right now is 0051 and then 00 updated. Okay, so we're updating this. Should not. It means the number should not be negative. However, it might be 0. Should not rather than cannot, because sometimes I use signed integers to easily detect underflow, right? So we have a never negative here, but let's just bring this to the top, right? We want to do chronological order. Actually, I don't know. Let's just keep it here for now. I'm not sure how I feel about moving it around. Whatever. It doesn't need to be perfect. Okay, so, yeah, we had a never negative in here. And, yeah, so this is never negative. And, we might also want to make a note of, you know, at may not, should not be negative. So at should not be negative, right? So let's make a should not be negative, because never negative maybe isn't explicit enough. So let's just make a note of that, right? Let's make a note of this. Right. And at means same thing as at never negative, but emphasizes the idea that it can be negative, but for proper / correct code, it should not be negative, right? So that's kind of what I'm saying there. At vid IID, and 0151, and the time is 0053 and 5350. Okay, cool. So now that we have that, let's keep on rolling, right? So yeah, that should not be negative. And also we need our fragment shader common code. So we are editing way too many files right now. But fragcom functions, or actually fragcom data is what we want to edit here. And there's nothing in here. Fragment shader common code is actually, let's go fragcom and look at the function file. Or fragcom. In the function file, there's probably nothing, right? Or there's unit test code, but the actual fragcom stuff is in the fragment shader. Fragcom fragment right here. Okay, so this is what we really want. This is what we're really interested in. And in fragcom common code, we just want to, the rectangle type is something that we're going to, is a commonly defined type. So, so we're just going to keep everything in fragcom that is common fragment shader code. We're just going to put it in here. So, so let's just make a note here. Common data types used in shaders. So let's just make a section called common data types used in shaders. Right? And then see if we can kind of get this kind of in here. So in polyOGL, right, we're going to steal this, right? We're going to steal this struct. And the struct definition should be pretty much the same thing, right? We should be able to just copy-paste. And let's indent again and say rectangle. So this is an integer rectangle. And let's reduce our line weight, right? So for this indenting in here, we just want to reduce our line weight, right? So bam, paste that in there, and then make sure that everything is indented correctly. So let's go all the way to the edge and then go 1, 2, 3, 4. So that is all nicely lined up. And so yeah, here we got our common integer rectangle. But however, this namespace is wrong, right? So this shouldn't be polyogl. This should be fragcom, right? Fragment shader common, and it's a rectangle, right? So if we look at that, and then we go over here, right? We have fragcom rectangle, and it is in the GLSL code section, okay? So now we have everything of the same exact name. And now let's go look for where we define rectangle, right? So we got this rectangle code, and we need to properly... I think I got a glass splinter. Fuck. Yeah, just a very, very tiny piece of glass. I'll just put it over here on this piece of wood and hope I don't encounter it later. Okay. So in here we have to figure this out, right? So I believe we can kind of get we can steal all this code, and it's going to help us. So this texel fetch global location here, this integer texel coordinate, is kind of the key to this stuff here. So what we're going to do is we are going to steal all of this stuff. We're going to steal it all, and we're going to shove it in here. Bam! Shove it in there. Because it's basically the code we need. But we need some modifications. So we got the pixel index, and then we have the global coordinate, right? So this pixel index, right, tau sub var, this is going to be the top left pixel of 2x2 cluster, right? So let's just do a little hashtag comment here. So hashtag top left pixel of 2x2 cluster. And let's document what that is really quick. All right, so what do I mean by that? So let's take video integer ID, what is it? 058, and then actually we're almost on 59, so let's just do that. So every variable on tau depot texture is stored in a 2x2 cluster of 4 pixels. When trying to get one XY coordinate representing this cluster, we get the chord of the top left pixel, because graphical origin. Okay, so that's what we're talking about here. So this pixel index is going to be the pixel index of that top left corner, right? So we can see it in here. So the g.x, g.y, and this is the global coordinate we're looking at. And that's fine for this. However, we need to modify this, right? So this is the texel coordinate. And we want to do multiple texel fetches. So we want to do something like, we want to take this and we want to do, instead of calling this glow, how do we get glow here? So instead of IVEC2, so this IVEC2 for global, we're going to change that around Actually, glow for that is fine. But then we're going to make a, GX, glow.x. Actually, no, let's not. I don't know. I don't know the best way to do this. Well, we want to keep it as simple as possible. We don't want to do any weird overloading stuff that only GLS will understands, right? Yeah, we don't. So let's say, you know, in32, because it's IVEC2, in32, GX, global pixel location, X chord, and then in32, let's not worry about it being completely inefficient. The first thing we worry about is that the code actually works, right? So let's not worry about this. So this G for global, we're going to get rid of this global XY global thing here, this G here. And we're going to get rid of this G macro. Right here. And then we're just going to call this, you know, this GY in GX right here. So GY is just literally just going to be GY, right? GY, right? This GY right here literally is just going to be GY, right? This GX right here is just literally just going to be GX rather than this weird macro thing. So we got GY here, we got GX here. So we just kind of did a little bit of refactoring. Make M32. Yeah, so that's cool. And then this integer textual coordinate, we're just going to call this multiple times. And just say, instead of U32 variable, we're going to say, we're just going to say, instead of U32 variable, we're going to say, rec, rectangle, okay, in32 rectangle, and rec dot x, so I believe I do x0 and I do, in most of my code I do the x's first and the y's, right? So if we look at where we're setting these viewport rectangles, we should be setting them in terms of x's, then y's, zeros, ones, zeros, ones. So we need to keep that convention, otherwise we're going to end up in a lot of trouble. So over here, we call this wrapper function, right? X's, then y's, 0, 1, 0, 1. That is the format. And if we look in here, we can go down to here and see where we're actually calling these. So x, x, y, y, 0, 1, 0, 1. So if we put it this way, we need to make sure that we get it in the exact same way. So, so we just have to wrap this. And since we're really going to be doing this a lot, I'm just going to say, you know, we're going to say define get U32 as this. And then what we want to do is this needs to be get U32, right? And then we have, we got tau, and we got global, and we got this level of detail, which is always 0, right? Okay. And then let's just remove this, and then let's I would rather make a let's make an XY version of this, right? Let's make another version of this so that we don't have to, so we can just say this. We can say gx plus 0, gy plus 0, right? Right, and we can paste this, and we can say x's and then y's, right? So 0, 1, 0, 1, right? X's and then y's. And then over here, we're just going to say, okay, on the x, we want to go over 1 to get this next thing here, the next pixel that's storing this next variable. And then in scanline order, we're just going to, we're packing all these in scanline order, I believe. So the next thing should be over here, down here, and this next one should be diagonal, right? So if we do all that, gx and gy, and these are integers, right? So these are integers right here. God, we are editing way too much code here. So this is, you know, so let's make a little diagram here really quick. So we have a little diagram of what we are doing, what we're storing here. Okay. Okay. So we have the location, data, so we have the location and the data stored at the location, right? So this is top left, and this is, you know, top right, and this is, you know, bottom left, and this is bottom right, right? And we're storing things, x's first, so x0, then x1, then we're storing y0 and y1, right? So x's and then y's, right? So if we go through here, let's just call this get, right? So let's just call this get because we're running out of room, so let's just call it get, whatever. And then down here we're going to undef get, right? So let's just call it get, right? And tau is the memory region we're going to use for this get, and we could call it just get tau. And let's just make this a little bit more dense, right? So let's just plug it all in there. Let's make it really dense, really crazy dense here. And so, you know, this is top left. These are the different locations, right? Top left, top right, and this should be the bottom, left, and right. So the top left, right, because 0, 0, and then to move over to the right, we got to go 1 on the x. To get to the bottom left, we got to go 1 down on the y, and to get the bottom right, we go diagonal, right? So these are the two which we got to be really careful about, because I'm good at mixing up my x's and y's. We see they are different, and the right is over on the x, but for the left, we don't move on the x, we just move down to get to the bottom. So now that we have this, we can also, you know, maybe fit these in here as well without running out of space. I don't know for sure. So 1, 2, 3, 4. So we are just barely kind of like in there. It's kind of like we are crazy dense here. Can we do this? 1, 2, 3. No. That's 1, 2, 3. Yeah, that is too. That's cutting it too close. So let's do this. Let's right, that's kind of ugly, but it'll do, right? So just right, it's better just to be more verbose here so we can see how everything kind of lines up there. Okay, so rect.x0, right? This rectangle is right here, right? And we're just setting the x0, x1, y0, y1, etc., right? And then after we have used this, now we just want to return that's fine, right? We just did more fetches, right? So get tau. Also, this textile fetch, we got a u32xy that we're gonna make, right? So I'm seeing here that 1, 2, 3, 4. We could. Let's just find this, right? So it's u32xy because of how we're doing it. So let's go find this Texel fetch really quick. Not in here? Hold on. Yeah, remove the match whole word only. So here's where we're defining this kind of function here. And we just want to break this apart, right? So Texel fetch, so we're just going to make for now, let's just make a wrapper function. Let's not make our lives too hard. So we're going to, this function here, right? Where did this come up with? Where did this come up with? Why is this justified like it is? This is the beginning of a section. So this should go like right here. U32XY. And all we're going to do is change these two globals to GX and GY. And then GX and GY, instead of IVEC2, it's going to be int32 and int32, right? And this is just going to be a wrapper. So right, it's just going to be a wrapper for U32 sampler, and then make IVEC2, right? Make IVEC2 with a GX and a GY. And then we're going to use level dat always 0. So we can pass that on. And now we have 3 parameters, right? So it's just a wrapper function, right? I can say this function date is, you know, we can make note of the date. So the date is, you know, 2021-02-22. Time, vid IID 0151, and the time is 1:14, and let's do 32 because 1:14. 32, right? So we're just making a note of when we added this, right? So we're just saying this function, right? And then we have added time, and we have the video integer ID at whence that happened, right? So instead of calling it this func, let's just call it func. Added, right? It's not the best way to do this, but let's just, right? We just want to keep this. We just want to keep it like this so that we can kind of seal it off, like we've been doing with the other code, like do that. So we're returning this and sampler IVEC2, make an IVEC2 with the GX and the GY, and now we have a overloaded version of this function. An XY. Hold on. So Texel fetch U32 is up here, right? So no forward declaration needed, and we're going to use it to call this version, which is down here, right? So that's good there. And these are integers by default. That's fine. The rectangle gets passed down. So we got this tau depot get rec function, right? So that's cool. And this pixel index is the top left, and we do an integer xy. However, Oh, it's the pixel index, not the component index, so that's fine. This even says pixel index. We already know that's working. So yeah, if this is the pixel index, then we take that pixel index and do a index to xy calculation, which we already know was working. We cut and pasted that. So gy and then gx, just because the way this formula, this is a non-modulus formula, so that's why we have to get the y first rather than the x, because the non-modulus formula for index to xy just works that way. Okay, so that looks good there. That looks good. And then the global, do we even need this global? Yeah, we don't even need global now, right? So we can comment that out. We can say not needed for this one, right? It's not needed for this, right? So we can just comment this out. Except we don't, 1, 2, 3, 4. We don't quite have enough room, though, do we, if we do that? Let's just remove it. Okay, so we know we're using this function over here, so let's go find that for a second. So this tau depot get rec, right? Oh, there's no get rec, huh? We just made this get rec. What did we call it? Did we not call it this? Like, what do we do here? So let's go look in the main code here where we kind of refactoring things. And, oh, we call it get ivec4, but we decided that we wanted to make a rectangle, right? Yeah. So let's change this around, right? So we decided instead of calling it get ivec4, we're going to call it get rectangle, and we're going to get, you know, an actual rectangle struct, right? And then because we're going to do that, this is totally wrong, right? We kind of screwed up here. We're wrong about this, right? So what we really want is, we really just want to call it, you know, it's really just P5D VP0, right? So let's just say it's a rectangle type. It's a rectangle type P5D VP0, and that equals calling this, right? So aka rec VP0 or P5D well, rec VP0 is a substring of this, so let's just call it this, right? If we, you know, if we want to look for this and think and can't find it, right, we'll use that. Okay, so with this rectangle, right now we're just going to say we just want to get this working for now. So, you know, if P5D VP0 dot x0 greater than or equal to 0, greater than 0, greater than or equal to 0, no op, right? We're just going to make a no op really quick to get this working, get this compiling, because we have added way too much code to be, like, if this compiles right off the bat, I would be surprised. But let's just give it a run, and once we give it a run, once this compiles, we got to do more push-ups, because it's, like, it's almost 11. God damn it. P5D OGL main 1323. So 1323, where are you? This is wrong. Oh, because this is a make. So this actually needs to be like this. I thought we cut and pasted it correctly, but no, this is that, that's that. This is the next parenthesis here. Okay, so now I think we're good with that. So the cool thing is, since we're compiling it as C99 code and GLSL code, we can have some little type safety checks on the C99 code before we even run it as shader code, right? So that's kind of nice. So now let's go over here and expression. Okay, so one of our asserts failed. So in PAINT5D functions, So let's go look at our PAINT5D functions and see what that's all about. Yeah. So the destination viewport is not square. Okay. So PAINT5D. So because that's the case, on 3401, let's figure out what it is and figure out if we're okay with that. So if, right, if, you know, not equal to, right, and then just say error, I expect dest vp0 to be square. Okay, so make a little note, and then why don't we just print off what they are, right? So just print these off. So vp0 %d \n. I just print off like all these viewport values, right? So we got x's and then y's, zeros and ones, right? So let's just do that, right? Let's take all these values and let's just shove them in here. Make sure we know what these values are actually supposed to be. And then also, what I would also like to do is say, so the width, right? What is the width? Well, width is this. So the rectangle width and the rectangle height, right? Rectangle width, rectangle height, and y's minus each other. And then, you know, printf rec width %d \n, and then, you know, rec width. Duplicate that, and the rectangle height right here. So width and height right here. And then let's just do a, you know, a printf \n. Give it a little bit of get a little padding, right? Hey, how's it going, anime dude? I'm about to do some push-ups. It'll probably take me like 10 minutes. Hold on. Hold on. Whoop. Whoop. About 5 minutes. Should take me about 10 minutes. Yeah, so I'm about to do some push-ups because I got to get all of my push-ups done. And also, okay, so back down here. Let's just make this a little bit better. Okay, so here's what we're going to do. We're going to recompile this. We're going to see what that error message looks like. We're going to see if that viewport is not completely square or what's going to... I'm trying to get 6 so I don't have to go to school. Hold on. Are you doing remote school or in-person school? And why trying to miss school? Why are you trying to miss school, my friend? Like, what's going on there? I mean, getting sick these days, right? I mean, don't like accidentally kill yourself because you get sick and end up, you know, right? I mean, you know, COVID doesn't have a COVID has a low kill rate, but it's not a non-zero kill rate, and you're probably young, I'm guessing, so you don't have to worry too much about it. But in person, I hate school. Yeah. Oh man. Dude, I'm pretty awkward. So I mean, I don't know if it's awkwardness. I mean, if anyone's a programmer, you're probably slightly awkward. Like, if you like coding, like, that's usually the case. Not to generalize, but it seems to be the case. So, as a programmer, I'm a pretty weird person. Um, I will say to you, um, just sitting under the fan, like literally under a fan. Um, you know what? I don't know how athletic you are, but I'm a weird person who I like programming, but then I also do a whole bunch of athletic things, and I will tell you that people in school are kind of stupid. They're like reasons for like the reasons for like why people like people is kind of like very stupid, especially like in school. And so like I did a lot of gymnastics in like middle school, high school, and that actually kind of made me popular just because I could do like basically like, you know, crazy flips and shit. And like it's like a totally it's kind of like a stupid reason, but right, like everyone will forgive me for how weird I am because I can like do a front flip. Like it's like all right, whatever. Um but yeah, I mean school can suck because um like especially like for me, I don't know how old you are. I don't know what school you're talking about, but like when I was in high school and middle school, like everyone is not completely socialized yet, right? So everyone's being assholes to each other, and they just only a uh, oh, got ya. I got ya. Okay, yeah. So um, are you living out in a village or in the middle of nowhere? Like, what's up with that? Like, there has to be somebody else who likes computers and stuff. Like, don't you have don't don't you have like a nerd table at lunch or like you're at a small school or what's up with that? I am gonna have to do my push-ups soon, but I gotta do my push-ups, but I will get back to you. I just need to do push-ups really quick. It's gonna take. I'm actually gonna set a timer for like 10 minutes because last time it took me about 10 minutes, or it actually took me 7. But I will get back to you. But I'm gonna start a countdown timer right now, and you know I will address your reply once I get back to this. So. Or actually, it's more like, it's not really that, it's more like, how do I describe this, right? Like, right? Yeah, I mean, social stuff is kind of like a fiat currency, you know? You get together with a whole bunch of people. If you're all losers, but you're all friends with each other, now you're no longer losers, as far as I'm concerned, you know? That's kind of how it works. But dude, I mean, like, you gotta think about, like, what you want out of life. And, like, if I want to be, like, you know, sometimes with, like, a normal person, with, like, a non-nerd person, we'll say, I'm pretty certain I can consider you a nerd, because I've seen the projects you've been working on. Sometimes a lot of non-nerd people aren't really that interesting. But not always, right? Like, for me to want to associate with somebody, they have to have something they're, like, very passionate about, that they put a lot of time and energy into. And I'm not, right? They have to have some type of very deep skill. You know, preferably, like, some type of thing in math, science, programming. But it doesn't have to be that necessarily, right? Like, somebody has to have put enough time and effort into something to be very knowledgeable in some type of subject, right? Like quality people, right? Like, that's what I consider a quality person. Like, somebody who I can have an interesting conversation about things, rather than, you know, I don't want to talk about sports. I don't want to talk about the weather. I don't want to make small talk with people. You know, and so a lot of times with people, I tend not to associate with people unless I have, like, an interesting project to be working on with them. But not everyone's like that, right? Yeah, I'm pretty old. But anyways, like, I don't know. Shit. Yeah. Yeah, I didn't even know that. Yeah, I would, like, you know, if you're having social problems, don't try to, if you don't have the what do you call it? If you don't have the extroversion to try to make friends with everybody, focus on just trying to, like, find, like, a handful of people that you like, and a handful of people that, you know, also like having you around, right? Like, and also, like, I don't know, I mean, your teachers are probably helpful. Other... Anyways, I'm gonna get back to the code. But yeah, man, I mean, just, you know, like, we're not all meant to be super socialite kind of people, right? Like, some of us are just meant to be smart, weird people, right? And, me, like, I'm just normal enough to, like, what do you call it? I act normal so that I can, like, you know, do do things like, I don't know. I act normal and learn how to act normal so that I can, like, you know, so I can get a job, or so, like, I can go on a date, or, like, right? I only act normal so that I can do other things that I wouldn't otherwise be able to do, because it's like, right, if you're too weird, you know, sometimes that limits your possibilities. So sometimes you have to pretend to be normal in some cases, right? What is it called? When in Rome, do as the Romans do. As in, but yeah, I mean, like, I'm working on a company, and I have to sometimes be careful about how I say things, right? Because, like, a lot of times I want to say my company, but I want to do a worker-owned co-op, so really it's our company. Even though I'm putting in most of the effort, right? I'm putting in most of the effort right now, so I do think of it as my company a lot. And so I do have to, like, sometimes get out of that mindset of saying my company and say our company, right? Our company, our products, rather than my company, my products. Right? Because people want credit. People want credit for their contributions, right? So, so you don't want people who take more credit. You don't want somebody who tries to take all the credit for things when that credit may be shared between multiple people, right? So, where the heck are we? Okay, so let's just define as AAC 2020 PAINT5D ERR. Halt, actually. And then at the bottom of this section, init or update. Really, we don't have an error function in this whole... Okay. Okay. And let's try to give that a run. But, I mean, making a game is really hard work. So, I mean, like, if people are taking credit for, like, if you... Say you programmed all the game and they did the art, right? Yeah. Do you talk about it? Do you talk to them about it? So, for example, let's say, I said, no. Yeah, but so in regards to that, we were once in a group in, like, science class in middle school, And there were 3 of us, and he didn't like our ideas. Like, 2 of us had decided on this idea. Like, me and another guy in the group had decided on this idea, and he didn't like it. He hated it. So he took our paper. He took our paper and he crumbled it up into a little ball and he put it in his fist. And I'm like, okay, Pesco, you gotta give that back. Like, just give back the paper, man. And it's like, okay, Pesco, I'm gonna give you to the count of 10. And I better have that paper back. And so I gave him to the count of 10 very slowly. He didn't give it back, and I punched him in the throat. So he gave it back after that, and then I got suspended. And so then in middle school, in high school, there was like a rumor circulating that I beat him up in middle school or something. And he came up to me to talk about it, and he's like, "Hey, are you going around telling people that, like, you beat me up, right?" And I'm like, "No, I'm not shit talking you. I probably mentioned somewhere that, you know, I punched you in the throat in middle school for that, you know, science thing, but I never said I beat you up, but people probably misunderstood that." And you know how, like, rumors start, right? Like, getting punched in the throat could turn into beat up very easily. And, you know, he had the conversation with me, and then we were cool after that, right? So, you know, sometimes, like, things can get distorted. So, you know, if someone's just make sure that when you have a falling out with somebody, that it's because they really are an asshole, right? Like, try to assume the best out of people, right? Before you kind of write people off, right? And I don't know enough about your situation, right? I don't know enough about your situation to say what's going on there. But right, like, try to always extend that olive branch, right? Even, and I'm not saying that there aren't asshole people out there, right? And you wanna stick up for yourself, man. Okay, let's see, 410, 409. So that is very close to square. Okay, that's close enough to square where I'm okay with that. Sure. You know, if it's off by one, I'll allow it, I think. Or do we want to fix that? Do we want to make it a power of 2? You know what? If it's close enough, if it's only off by 1 pixel, I don't think that's too bad. So in our assert statement for this viewport editing stuff, we're just gonna say, you know, let's look for rec width for a second. Yeah, an off by 1 could just be because that's an easy error to make. But yeah, I'm just going to say if it's off by 1, that's fine. So we're going to go into the assert for that. Where's my assert for this? Okay. So we're going to throw rectangle width and rectangle height on the outside of here. Oh. These are already calculated here, huh? Okay, let's call this, is this rectangle width the same thing as these rectangle widths? I don't think it is. We're going to change this to... this is VP0, so we're going to say VP0 width. VP, right? And then, right, so this is put down here. So let's do this. And I am going to look at what you typed there. I just got to focus on this for a second. Yeah, width, height. And we're only going to make it an air. If VP0 width minus VP0 height, we're just going to be lazy about it. So we're just going to be like a VP0 height minus VP0 width. So I don't even want to put an absolute value in here. Oops. I'm just going to do this, right? So if the width minus height is greater than 1, or the height minus width is greater than 1, we're going to throw that error, right? Change that to expect des to be square. Allow off by 1, because we can't really control sometimes moving on, because weird client areas could mean width of client is odd number of pixels and height of client is even. Okay, and I'm going to make a note of the time that I added this, and then I'm going to check your commentary. It's at 0151, and the time is 1 hour, 56 minutes, and let's say 23 seconds to keep up with that conspiracy. And then I'm actually gonna read what you typed. But I just I want to finish my thoughts before I kind of like jump back in the chat, you know. Can't evolve your Pokemon. Don't they have those like special candies or whatever? They have like candies or something like that. Like I thought they had that kind of stuff. Like I thought you had like there's some type of free evolution kind of pass thing. God damn it, my bitrate sucks right now. Sorry if you can't hear me very well. Okay, so let's give that a run. And I think we also need an OR symbol in here. Did we not? Yeah, okay, we did that. That's fine. We're going to give this a run, and then, unfortunately, we're going to have to do more push-ups because we'll wait till 11:30, and we're going to cut it close. Okay, so now the next part after this compiles is, we're going to hope this is, yeah, syntax error, like I expected this. It could be in a lot of places. X1 is not a member of struct AAC 2020 fragcom rec. X1, okay, so let's go look at why that would be the case. Sure looks like it to me. There you are, right there. Struct. X1. What the hell is it talking about? It's like right effing there. Match case. Okay. WTFs. I'm gonna search for this because I don't know what's going on there. It's not a member of struct. You're freaking kidding me here. Explain, God, I cannot type. Any YouTube videos of what you're talking about there? Not a member of Struct. Let's go look this. It should be. I have no clue. Let's just look at struct GLSL. Like, what's the proper... possibly maybe that struct needs to be at the top of the file. That's cool. What the fuck am I doing wrong here? It's saying that these aren't members of the struct, but it's like right there. Let's just try, this is in the fragment shader common code. No, let's keep it as in32. That's bad. Let's take this error. That might actually help me. Interesting. Macro is nested too deeply. Did I hit a limit? Let's error GLSL, right? So here's the error. Ambient is not a member of struct, whatever. Let's put this in our notes. I have no clue what's going on. But let's put this in our notes really quick. So I have a notes file for this. C1009 was the error. Not a member of struct. And the error message was... C1009. C1009, not a member of struct. I have no clue what's up with that. Okay, so I have no clue. I'm going to answer that question. I'm going to try to answer this on Stack Overflow once I figure it out. Okay, this sucks. Oh, you know what? Maybe the common code is not in this shader. Yes, the common code is not in this shader, I believe. So let's go look at that for a second. So file, open. And if we look at the PAINT5D default shaders, and we look in here, but we're not including, yeah, we're not including it. No wonder. Okay, so we want to include ... and we want to do fragcom.fra.string. Okay, so the reason is that that struct is just not being included at all, right? So, in my shader string. So, okay, that's what it is. So I'm going to make a note of that. So in my shortcuts really quick, I can make a note of this and say, you know, C1009 now, C1009 now, your struct isn't actually in the shader you are looking at. Trust me. Right, so let's make a note of this, right? So, at video ID, 151, and the time is, right? So, and then C1009, 009 URL, right? C1009 URL. And this is the URL where I kind of looked up that question. And right, make a note of the timestamp, like the video and the timestamp here. And then we can also, let's change this timestamp really quick. What time is it? 8 minutes and, let's say 13 seconds. So let's go look over why that is the case. So right here, we forgot to add the common fragcom common to our shader string for the PAINT5D system. And that's why we're looking at this type here, and we're like, it's saying that these members don't exist inside this type. And we can see that message right here. And the actual reason for this is because the struct is an incomplete type. That's what's happening. That's why that's not working. Okay, so now that once that we've kind of solved that mystery, the next thing is to hope that things don't blow up in our face when we try to recompile, right? Because now we just added a whole new shader string to that PAINT5D system, and now I am scared, right? I'm scared that we're going to have broken something. So, fingers crossed, I guess. Okay. And we're going to have to see what's up with that, so... let's close this for now, and let's put our chat back up in the upper corner. And what do we got for problems this time? Implicit cast from uint to int. Okay. So now we got to figure out where we did this uint to int thing, right? So we got to look over all of our fragcom code that we added. We didn't add any other functions, right? We just added this in the fragment shader common, right? We didn't add any other function, I believe. So it's probably not, the offending code is probably not in there. The offending code is probably in our fragment shader code. And we got to figure out where the heck that is. So it could be in a lot of places. But we just got to look over this get rectangle thing. I'm going to guess that we didn't cast when we assigned the members, right? Like we made this. Yeah, so this rectangle right here, these get functions are going to return, they're going to return, let me just close the program. They are going to return a unsigned integer. These getters, right? They're getting a U32 value. And so actually, let's rename this as get U32, right? Get U32. Because I think that's going to make it easier to understand what's going on. And let's just comment out this, right? And okay, so we're going to make a little helper function here. 1, 2, 3, 4. Little help, 1, 2, 3, 4. A little macro. Usually I don't get this crazy. But instead of get U32, we're going to say get I32. And that's a wrapper. And it's going to do get U32, and then it's going to cast to a make U32. Make N32. So we're going to get a unsigned, cast it to signed. And then we can undef over here. Right, so undef this. We are getting a little bit crazy with our macros here, but... right, so then we can just change this, right? And then we can keep this as, you know... we're still running out of room, though, so... Yeah, we added 3 more characters, so 1, 2, 3, 4. So, right, top left, top right, bottom left, bottom right. So top left yields x0, right? And also, so this is x0, this is x1, these are y's. Right, so all the stuff should kind of light up. So bam, 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 and bam. Does it all make sense? Yeah, that all looks good. That all looks lined-uppy. Very technical term. So yeah, let's give that another roll. Let's give that another roll and see if we can get this working. And also, while I'm here, let's go look that up. Yeah, I noticed some of the newer Pokemon have this kind of like very angular-ish kind of style to them. Like the different generations have like almost a different art style. Yeah, I went to school for art, so um, that's kind of the thing that kind of stands out to me. Um, I'm not saying I'm an expert at art or anything. Okay. Come on, get on the screen. Multiple monitors, man. Get over there. Okay. What do we got here? Pass 4 arguments, but takes just 1. Did we just screw that up? Oh, I see. 1, 2, 3, 4, right? We didn't do that correctly. That's, okay. A, B, C, D. Um... I don't know what I want to do here. I'm out of space here. I don't want to make it a 3-letter macro because I've been doing that kind of for my other stuff. But I'm running out of room here. I do like this. This is pretty clear. Well, we could do this. No, that's not gonna work. Let's call it temp. This is ugly, but you know what? Define temp make I32, right? And then right here, we're just gonna undef temp over here, right? So undef temp, right? And then we can save that. Okay, so get U32. The temp is make int32, right? So to get the I32, right? We wrap the U32 with the I32 constructor. And then, yeah, that's ugly, but whatever to get it working. Okay, so we're gonna get this compiling, and then once we have the shader properly compiling, we're gonna do our push-ups because we need. Oh shit! No, we gotta do them now. We gotta do them now. Let's hope it compiles, but if it doesn't compile, it's too late. We gotta do our push-ups before midnight. Hey, look, there we go. Let's do P for pattern. Alright, cool. Cool, our shader's compiling again. Very cool. Okay, cool. So, yeah, we gotta do 10 more push-ups, or not 10 more push-ups, but I gotta do our 50 more. So I know we already got to 100. Okay. Let's get to it. Let's figure out what went wrong with our code. Let's rerun this fresh, figure out what's wrong with our shader code now, and then try to fix whatever's going on here. So, I don't know if it's still the same thing. Oh, wait, no, we fixed it, right? Yeah, we fixed it before we left, right? P for pattern, can go up here. Yeah, so we actually fixed it, never mind. Okay, cool, very cool. So now that we have this code that is, you know, fixed, we want to go to the next level of figuring this crap out. So let's go into this, where we're calling this from, right? We got this viewport rectangle, and the next thing I want to do is just very simply, right now we're just like doing this thing here, and that's all good and good and whatnot. But we're gonna say we're gonna comment this out for now. We're gonna temporarily comment this out, and we're gonna say like you know, if so hold on. We got like a fragment integer coordinate, right? So if fragment integer coord dot x is greater than or equal to what do we call VP0? VP0, where are you? What do we call you? P5D VP0, right? This thing here. Right, so less than or equal to, because it's inclusive bounds. And let's do and like this, and then we're gonna do like a 1 equals 1. And then we're gonna duplicate all this code, and we're gonna make the y-axis for this. And then we're going to we're just gonna say, you know, if this is the case, if we're inside of here, we're just gonna say like uv4 pix.x equals, you know, and we're just gonna say we can actually just steal this stuff right here, right? So this was for the out of bounds. So actually, we'll do else. So this is inbounds. And let's steal, we'll just steal the code for this, right? So we'll steal this. And we're just going to make it like yellow, red, green. Right, so out of bounds is just going to be yellow. And then inbounds, we can just make green or something, right? And this is temporarily until we get things working. Right? Okay. Yeah, let's give that a roll. And just see if we can, I want to see if I can manipulate the viewport. So we have like a notes file here somewhere, our to-do. All right, I want to use the keyboard to, U32 pix is unused, okay. So let's go look at that, right? So we have this U32 pix. So we're just going to say, you know, if U32 picks. So we're just gonna make another no-op right here. Just to get it compiling, right? Because our code is unfinished, and that's why we're getting these warnings. Okay. So let's go over here. Syntax error, great. Let's see what the syntax is. Implicit cast from int to uint. Okay, well, let's go look at what we got. I'm surprised here. Is fic... Let's go look at what fic is. int32. Is the P5D whatever? That should be a integer as well. Oh, U32. It's my no-op. Of all the things to screw me over, it's my no-op. So it's the thing I would at least expected, because it's the thing I didn't have scrutiny over, right? Okay, so now we got that. Let's Also, we gotta write it in a way. We gotta write it like that, otherwise it's not gonna... It needs to compile both as C99 code and as GLSL code, so we gotta be careful about how we do that. Oh, also, we got all our push-ups done, right? Just made it. What is it? Work expands to fill the... Okay, cool. So now the question is, with this little area here, can we edit it, right? So we have some controls: camera left, camera right, camera up and down, and zoom. So JLIK. So if we do, really, we use those keys. JLIK. Okay, whatever. J. Okay, L. How about I? K. I get nothing. Okay, how about like zooming in, zooming out? Because right now, R and V, right? So R and V, we're getting nothing. Getting nothing there. Okay, so now the question is why? Is this not, Okay, so first of all, there could be a few problems. Possibly maybe we just stubbed these in and we never actually coded it. Maybe we keep on resetting what that area is. That area looks horrible. But we wanna figure out one thing at a time here. So in the PAINT5D kind of like functions where we are handling the stuff right here. Let's just search for the input and move camera XY, right? So move camera XY. And this is not the actual call here, is it? Oh, this is the test code. Let's search up here. So move camera XY. And what are we doing here? Is this correct? Or is that not correct? Move camera XY. Also, let's turn off that backlighting. we keep that light on when we're trying to like do patent stuff. So we got move camera, X, Y, and we have these different keys. So the first thing I might want to do is I might want to log this, right? So in PAINT5D, let's go into the silent system and make sure that logging is turned on for PAINT5D, because it may not be. And PAINT5D right here, logging is on, okay. And we're just going to log we're going to log the key right here. We're going to log it here as well. We're going to log it here. And also we need to change these after we kind of stub them in. But the first step is, hey, perhaps this is never getting called for whatever reason, right? So you want to eliminate that possibility first, and then we'll work from there, right? So this, that, and that. Okay, cool. So let's give it a run, make sure that we get those echoing statements in the code. So it's like what, J, L, I, and K, right? Info any. Oh yeah, also we have to, we need a void pointer in here. So we'll just say 0 for now. Comma 0. Comma 0. Oh, hold on. Comma 0. God damn it. Okay. Okay, let's go over here. And we want to... Did I just close my terminal? Was I just an idiot there? No, I wasn't an idiot. It was right over here. God damn it. Okay. Let's give this a run and see if... let's give this a run and see if this looks correct or what's going on here. Okay. Let's just move this over here for a second. And okay, so here's our stuff. And we have like a J key. So here's the left key. So it's being called, right? It's the logging function for the left. JL is the right? And then up and then down. What the heck? Let's go back here for a second. So J, okay. L, okay. And then down was, K was down, right? Did I press, like, something beneath K that did that? Up. Okay, so those are being called, but I don't see it represented in the code. Like, that looks weird. So the next question is, well, are these values correct? Do the camera values, is the camera actually being moved, right? So that could be a problem. So we got these move camera controls. Is the camera position actually being... Move camera, and then we have a movement amount. And the move camera is tau depot. Oh, okay. Is the camera supposed to be VP1? Because I'm seeing VP0 here. Oh, hold on. My bad. I'm bad here. Language. Okay. So, right, so the camera is what's kind of moving over the data. So it's working, but that's not the actual, viewport area thing. So now the question is, well, why is that area so small? So let's go look at where we initialize VP0. So VP0 for a second. VP0. Why is VP0 so small? Because that is kind of like, why are you so small? What's going on here? Why are these VP0 let's go X's and Y's. Or actually, let's give each one a unique color because we can afford to. VP0 is that screen viewport. And is this thing we asserted was square, or our asserts? Yeah, so we're asserting this as square here. Okay, cool. But why is it so, like, ridiculously small? So the first thing we're going to do is do a temporary hack here. And the zeros are going to be 0. And this is going to equal client width. Or actually, we'll set it to this viewport canvas, right? We'll make sure viewport canvas is completely correct. So this is a temporary hack for now. And we just want to confirm what we're seeing for a second, right? So we want to see that green. We want to see that green light up the... We want to see that dark green that was in the middle. We want to see it light up the entire screen if we stretch it to be the entire canvas viewport. And if it's not, then we have some type of problem. Expect to be square, so it's not going to be square if we do this. Let's put the temp hack down here. Temp hack. Okay, let's just put it down there after the assert. And we just want to see that nice green color be the entire, fill the entire screen of our shader. And if that's the case, then we'll kind of work from there, right? But we gotta make sure that, you know, right? That's not good, right? So does it think the client area is that small? Let's try to move this around. So what does it think the client area is, right? So let's put a breakpoint here. And this camera stuff here is we're going to make a function called log VPC. It's just going to be a macro. I'm going to shove it in here. And we'll put it directly above where we're... And then we want to put this in some type of... Technically, it's an info message. So let's just say, you know, void AAC 2020 PAINT5D right, this is the log VPC. And we can use the tau depot functions. So over here, let's go open up tau depot functions. And this is what we need here. Right. So instead of VP1, it's going to be VPC. And, you know, U32, right? X, then Y0101. And then we just want to printf right, we're going to take these, copy paste them, and you know, printf and x0, x1, y0, y1, right? And we want to see if that's actually changing, right? So we're using those getters. And we just want to know, hey, I actually don't want to know if they're changing. We just want to know that is viewport C something? The canvas viewport, is it a sensible value, right? So undef U32 here. And then up here, do you find U32? So I32, U32. I32 and U32. Yeah, so let's give that a shot. Also, let me check my whispers. And have I been sent something, or is this... Oh, no, I sent them something. Okay, so what I just want to know is for that J, K, L, and O, I believe. Let's press J. Oh, wait, we gotta go over here first. Okay, J. 418, 437, 420. Okay. K. L. So we got like 420, 421, 384, 385. It seems to me, it sure as heck looks like these values are where the data is stored, but not what the values are supposed to be, right? Like, if we look at 420, that suspiciously looks like... Oh, actually, no, that is where the data is stored. We're looking at the viewport, VPC, 0 to 1000 something or other, 472, right? This stuff here. Okay, that's good. Now, if we change it, make it smaller for a second, and then we mess with this stuff, do we start to see a different VPC value? No, we don't, do we? So that's a problem. So we want that viewport canvas thing to change when we when we change the window. But the other problem is that viewport 0 looks very small, doesn't it? So let's go log that as well. I know we're taking up like a lot of space here, but let's just so VP0, if we look at our notes really quick. Let's close this. Look at our notes. VP0 is here. It's the screen viewport. So instead of VPC here, we want to change this to VP0, right? And then we're just going to steal this, and instead of VPC, VP0, right? Right, and then this is VP0, right? So this is just the same version of the function, cut and paste, basically. And let's go look for where this is, and let's make another logging function for this. So viewport 0, this is the 8th thing. Oop, 8th. And then let's figure out where we're calling this from, and hold on, before we do that, we're going backwards. Why are we going backwards? VPC, VPC, VP0, VP0. And we're just going to duplicate this and say, hey, VP0, right? We want the canvas, and then we want the that sub-rectangle on the canvas, right? We want to make sure that those are logging correctly, the correct values, because I don't think they are. Okay. And this value should be changing after we kind of move things around, right? So Let's get a bit crazy and also put the log over here. And why am I indented like this? Why did I do this? Oh, because that log. But we want to also log this after the fact and see if there is a change in the camera, right? This is really a lot of logging. So this is going to be viewport 0, right? Viewport 0, this is going to be the 8th thing. And then over here we have this macro VPC, right, for this. And this is macro VP0 right here, right? So if we log VP0, we can see here's where that macro is for VP0. We can see it called in these places, and then we can also see the macro name we're using for this, right? So VP0, right, the VP0 address here. Okay, yeah. So let's give that a run. This is getting ugly as hell, but we'll figure it out. We're figuring it out. So we are very close to getting editor controls for Josh, so I'm excited about that. Okay, let's go over here, and let's just press J for a second and figure out where our okay, so we have VP0. VP0 seems to be kind of snapped to, doesn't seem to be changed. In fact, it's set to VP0 and, oh, actually, no, this wouldn't change it. When we're moving stuff, that's actually a different canvas, right? That's not on screen. The camera controls are not on screen, so of course VP0 isn't going to change. So let's make some notes here. Let's try to help ourselves because we're being stupid, right? So let's, so first of all, we're going to put in VP1 as well. So VP1 is going to be the 9th logging function. And now we're just getting way out of control, but oh well. And down where we're logging this stuff, what we really want is VP1 before and after, right? Because that's the off-screen viewport that the camera manipulates. So of course nothing else was changing. So we want these kind of 3 calls right here, VPC, VP0, and 1. Right? And then we're expecting VP1 to have changed after these calls, right? So VP1, we're expecting the change. So, bam, 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 right? Boop. Okay, that all looks colored similarly. And then our macros, VPC, VP0, and VP1. This is going to be the 9th macro. VP1. So let's go look up where this is coming from. Let's go backwards. And we got all this viewport logging. Let's just steal this and paste this. And this is going to be VP1, right? So VP1 right here. And this thing needs to be VP1 now. So anywhere we see VP0, it's going to be changed to VP1, right? So VP1, 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 VP1. This VP0, VP1. Viewport 1 is camera rect. Camera/data. So, we're being stupid. VP1 is the camera/data. Right? And then over here, let's change this. VP0. What is VP0? Screen/viewport. Right? That's what it is. Right? Okay. And then over here, this last thing, VPC, canvas/client is what this is. Okay. So with these more informative messages, when we're looking at things and we're being like, oh my god, it's not working because we're idiots. I'm an idiot. I can, so J and L, I and K is what's used to move this. Okay, so now if we're looking at this and we do like J, what do we see here? So we want to look at the camera/data. So we got 0 and 255, right? So it's kind of like full screened. It's already zoomed in. It's already full size, and because it's full size, the camera, you can't move around the camera, so that's why it's not moving right now. So in order to get this working, we actually have to change the zoom before we can move in and out. So if we see the zoom, R and V is the zoom, right? So I have no clue why. So if we could do R and V for a second, which one's zoom out or zoom in, right? Zoom in is V. Okay, so we want to zoom down into the data. And if we zoom down into the data, then if we type J and K, we should get like something different. Yeah, now the rectangle can actually move. Okay, here's the Y's changing. Here's the X's changing, right? Okay, so that all looks good to me. But what doesn't look good is the fact that this rectangle, this green thing, that is the VP0, looks to be VP0 and VPC. Am I not echoing the correct thing? Because this rectangle right here looks totally different than the rectangle here. Is my echo working? The screen rectangle, the canvas client, the screen rectangle here, that doesn't look correct at all. VP0. This renderer doesn't look correct at all. So according to this, it should be like, kind of like full screened, and it's not. So let's see this. X, and then Y. This says VP0 here. This is VPC. And the other one right here is VP1, right? VP1, yeah. Okay. Let's go look for where VP0 is being set. Maybe when we set VP0, we were being stupid. X's. So it's not so much that, we got a problem with that it's being full screen, but it's being full screen, but our shader doesn't even reflect that, right? So there's the possibility that our shader code is wrong. So let's go look at our shader code. So 1 equals 1, and X is greater than or equal to the lower bound. X is less than or equal to the upper bound. The Y greater than or equal to this bound, and the Y is less than or equal to this bound right here. The fragment coordinate has already been inverted correctly. But it is suggesting that... the bounds seem like very small. They seem like very small bounds. So it might be helpful just to know, well, what are those values, right? Like, or why is this not correct, right? So how did we get this? Let's review how we got that value, because that might... So this is get rectangle. So first of all, VP0, right? Is VP0 actually 0? I don't think it is. Let's go look at the data. Yeah, VP0 is not 0. It's 1. It's hard-coded as 1. So we're getting the wrong thing. Right? So why the hell did we do... Yeah, VP0 is 1 in the data, right? VP0 right here. Okay. So that is obviously a huge mistake. So the question is, you know, if we fix that, will we actually see, like a full screen green now, right? Which is still bad, but at least we know we're getting the proper variable, right? So right now we're getting this, right? Which is not what we really expected, because we wanted to inset this, right? And that's not insetted at all. And it's not changing at all, either. So it's almost like, as we resize... yeah. What about if we go down here? Yeah, so this rectangle is not set correctly, right? However that's being set, not set correctly. So the next question is, well, is it coming from here, right? Is that the problem? Oh, wait, hold on. We hacked this. Of course it's not, we were hacking that to, make them the same size because we were debugging. Oh, so my fault. Temp hack. Get rid of the temp hack, duh. Okay, so let's go look at that and see what we got now. See if we have we want like we want a green rectangle that's kind of centered in the screen, right? For the time being. We'll kind of mess with things later, but for now, that's kind of what we want. We'll design around that. Yeah, so that's fine. Okay, that's fine, right? That's actually what I wanted. And then we have to make sure that when the screen resizes, we want to change that, right? So, first of all, initializer update. Okay. Let's go find where this is coming from. And see where it's being called from. So find all for a second, and we just want it to update when we are... So it looks like it's only coming from one place, and that's probably in the initializer code, right? Initialize, yeah. So we want to make sure that initializer update default brush state. This viewport rectangle needs to be changed when we move the... when we kind of jiggle the canvas. But we don't want it to happen... Let's go over here for a second. So we don't want to do it with callbacks, though. So we just want to, like, every frame check to see if it's been changed, and then call the appropriate update to avoid kind of like memory coherency issues. So in our lib folder, we have a main function stuff. So in our main functions, let's see what these function names are. After window, open task, before, sync with GPU. So yeah, let's just open up the main function file. And graphics update tick. Okay, it could go in there. That would be an okay place to put this. Handle input. Okay, so we have some loop tick functions for the window code. And if the window is open, we want to do these loop ticks. So this is a good place. Do we have a PAINT5D loop tick? So let's go look for, let's put a little thing here. Look for a loop tick. Okay, no such thing. And this is init or update. Okay. So, since it's a new function, we're going to put it right above the unit test section and say, you know, loop tick. We're going to make a loop tick function for this, I guess. And we only care about this if that system is in focus. Otherwise, we're just going to ignore it. So what we want is a AAC 2020 PAINT5D loop tick. Okay. And it takes a U32 called U32. And this is the private version, right? And it returns a U32. And the public version of this is going to have the exact same name, except this is going to be uppercase. Okay. And define U32, and then undef U32. And the public version is going to say, you know what? If so this current editor it's in 32. Let's do a not equal. So just to avoid accidental assignments, be paranoid about this. And do nothing not in focus. Right, so make a do nothing. Else, we'll call this private function, right? And just say, at vid IID 0151, and the time is 3 hours, 17 minutes, and 32 seconds. Okay, so we use a loop tick function rather than a callback to avoid memory coherency issues when multi-threading. For example, if game logic is supposed to be on a different thread than window logic, using a callback function in our Win32 invoking a callback, a resize window callback function from our Win32 code will cause us to unwittingly invoke game logic from the window thread. Okay. So I will explain what the hell I mean by this. I just want to okay. So right here, what I mean is that... Let me make this a little bit nicer. And let's change the timestamp, since we kind of like... 3:19 and 42. Done writing summary. Okay, so what we're talking about right here is that a lot of times when you use a callback, you have to remember that that callback function, wherever that callback function is being invoked from, is going to be the thread in which that code is now running. So if I set up a callback system in my Win32 code, and then I wire up game logic to those callbacks, then my game logic is going to end up running on my window thread. And if I'm trying to keep my window thread logic and my game logic, if I'm trying to keep the window and game logic separately, that window callback function wire up stuff is going to screw me up. And I've made that accident before. So to avoid that, we don't want to use callbacks. And that is why callbacks are evil. Let's do callbacks are evil. And let's put that in our notes section over here, right? Let's just make a notes section for @callbacks are evil. Callbacks. One. Evil reason. So evil reason number one. Callbacks add lots of extra code. One, we'll need a function pointer type def for the callback function. Okay. Also, we'll need a wire up callback function. Or technically I would write that as wire up callback. Right, so you need all this stuff, right? So callbacks are evil. @vid IID 0151. Time 3 hours 23 minutes. And let's just call it 23 seconds to be, because I don't know, I like all the 23s, right? So right here at this time, let's explain it one more time. Callbacks are evil. Reason 1. Callbacks can make it so you accidentally execute code on the wrong thread, right? So if you want to take your window code, keep your window thread separate from your game logic thread, but then your window thread has, like, wire up callbacks to call other code, like a window resize code, right? And the window resize callback edits some GLSL shader code, right? Then, because it wants to change the GLSL viewport, then boom, you have window code that's now messing with your game logic code. So that's evil reason number 1. You could accidentally execute things on the wrong thread and get memory coherency issues when multi-threading. Evil reason number 2, callbacks make it hard to read your code. You have one more layer of indirection minimum. Evil reason number 3, callbacks make the code hard to debug, because now you just have like a random memory address in the debugger and good luck. Evil reason number 4, callbacks add a lot of extra code, right? So, right, you'll need a function pointer type def, and you'll also need a wire up callback function, right? You'll need that. There's other stuff you need as well, I believe, but it just adds a lot more code. So callbacks are evil. So, anyways. So we added this loop tick function, and we want to, let's put a breakpoint here. And we have like an update, or we have an update viewport rectangles right here, right? So we're going to say, we don't want to do it like right here. We want to, it depends on, we only want to update the viewport rectangles if the size of the viewport has kind of changed. And let's see, does the update rectangles, does it have a guard? I don't think it does. So here's what we're going to do. int30, AAC 20, okay, this client width and client height. We're gonna go to the bottom of the function, and we're going to say something like AAC 2020, a private variable, PAINT5D, I'm going to say client width, we're going to make these variables. Client width, client height, right? Bam, bam. Okay. And these variables we're going to use to know when that region is dirty, right? So we're going to go open up the data. We're kind of like on the... We got everything mix matched here, but whatever. So PAINT5D data, right? So we got nice diagrams and stuff. But then down here somewhere we actually have kind of like the actual data, right? PAINT5D data section. Debug variables, unit test data, this is like a public notice, isn't it? So we can keep this. I think that's actually kind of useful. I don't know what's up with, okay. So this is going to be, should be a U32, I think, right? Whatever this is, that's what we're going to keep it as. So if we look at the client width, it's an int32. All right, well, I mean, if that's what we used for client width, that's fine. That also worries me that int32 here. Are these the wrong... Because that can screw us up, can it? Let's not worry about that just yet. This client width, client height. Last known, what's it say, call that? Last known, size of viewport to PAINT5D. We can use this to know if PAINT5D's viewport rectangles VP Alright, so that's what this is about. Client area cache. It's kind of like a, I don't know if we really want to call it that, but sure, why not? Okay, so these things here, and then what we can do is in the loop tick function, right? So this right here, this update function for the rectangle. So initialize or update is what it's called, right? Which was for a reason, because we wanted to use it on initialization, but we also wanted to use it for updating, right? So right here we can see, oh, here it is. And we want to get the client area. Alright, so this thing here. We want to steal this. And down here, we want to get the client width and get the client height, right? And if client width is not equal to AAC 2020, AAC 2020 PAINT5D client width, right, the cache, or client height is not equal to, guess what, the height then we'll update this. Only updates if window was resized. Right, so let's throw this in here as well. Okay. And then let's say always update every frame. And I actually don't know what goes in here yet. Don't know what goes here, but I have a hunch something will go here eventually. Right? 0151. Time is 3 hours, 35 minutes, and let's just say 13 seconds, because that's where we're going to be. And this right here, all right, so the first draft of this, 3532. All right, so the first draft of this right here was at this timestamp. And right, so we're going to get the client width, get the client height, and then we're going to compare it to these things. And then we're going to update the viewport rectangles based on that. And yeah. Yeah, that's fine. I think that's good. I think that's good. I think that's where we want to be for this. Also, this loop tick function is not being called from anywhere yet. So we just want to make sure this still compiles. And once it still compiles, we'll stub in the call sites for this, right? So yeah. So right now, U32, we have like macros for our different types that we got to stub in here. Hold on, I'm a little hungry. Okay. We got U32s, and, you know, if U32, no op, right? We need a no op here. That's for sure. We need to just return 0x00, and then this is also not a void function. So we need to return 0x00 here, and then we need to do the same kind of no op thing, right? So really it was, you know, Alright, so we're reserving that for future use if U32 is actually some type of valid value. And also, U32, are you defined here? Yep. And what was our error here? Unknown type name, U32. So that is actually in the data section, right? So this data section, we don't have that defined, right? Got this PAINT5D data. Define U32. Right? There you go. And then we want to go down to the bottom of this section, which I'm surprised doesn't have more types, but undef U32, right? Okay. And so now, we just want to make sure it compiles, right? We gotta... Hold up. So client width is supposed to be an int32, isn't it? Yeah, it's supposed to be int32. My bad. So this needs to be int32 right here, right? We're not going to do any weird casting. Whatever it is in the actual original code is what we're going to stick to, and I'm pretty sure it's int32 everywhere, right? So client width, go all the way up, int32, right? Int32, all the way. So we're not gonna mess with that. If that's what it is in the code, we're just gonna that's what we're gonna keep it as. So over here, that means we need an int32 over here, right? So we need to define int32. Okay, and then down at the end of this loop tick function, we want to undef int32, and let's start to do checksums here. Just because I feel like it. Okay. So, let's do this and see if we can get this compiling. This thing. Okay, so over here we screwed this up. So because we said U32 and then we changed our mind. This actually needs to be an int32. So, define int32. Actually, do we have a U32 anywhere in this section anymore? No, we don't. So let's just get rid of that. So let's say define int32, which is this. And let's just make a checksum. Right, so 1 and 2. And then down at the end, U08 and I32 are the things. So we're going to change this to I32. We're going to go space, space. And 01 and 02. Okay, let's give that a run. Too few arguments to function. AAC 2020 PAINT5D. Oh, god damn it. Loop tick. Okay, yeah. So, that is because we wrapped it incorrectly. So let's go look for that. So if we go for a look for loop tick and we don't worry about the case, we can find it here. And it just needs to take, we'll just pass on the U32 value. And that also means that we don't have to reserve for future use because we're using it somewhere, so we don't need that no op. We're just passing it down. That's fine. Okay. So now, let's just try to get this. Let's try to get this rolling because I'm getting pissed off here. Okay, cool. So we're compiling. That's cool. And we're compiling and whatnot, and oh, that looks nice, right? But it doesn't change when we, right? So we got that working, but we actually have to get it to change when we, resize the viewport. So let's get on a roll here. Okay, so to get that happening, we have our main function file here, right? And we have, like, all these different loop tick functions, right? So all the loop tick functions are kind of, like, isolated in the same place. Like, loop tick. Right? And they're all being... I don't know why I called it window tick. And I also don't know why this one is being called out of order. So while the window is open, so right now single-threaded has all this stuff, and multi-threaded does not. So if we try multi-threaded, we're just gonna completely go boom. So let's go look at the order of things for a second in our system. So if we look at our main kind of C11 file where we're ordering everything, where's TauSync? TauSync is over here, PAINT5D comes after. So let's go duplicate this and say, hey, TauSync, PAINT5D has a loop tick function now as well. And do we have some control F help for this, or no deal, no dice? I don't know if this is really graphics update tick. Like, I see we're thinking of it as a graphics update, huh? Maybe. Graphics update tick was not a useful abstraction. Got ya. I understand. So there is intentionally nothing in here. And we're actually making an error to call this. Right? We made it an error to call this because yeah, we made it an error to call this. That's fine. And why don't we make some control F help here, right? Just steal. I don't know if this is the best way, but I want to keep the other stuff. I want to keep that uncluttered, so why not just go here and say, hey, AAC 2020, right? And keep like a control F help section, right? I don't know. This is hackish, but I don't know if that's the best idea. No, let's not do that. Let's put it. It's a little ugly, but it's ugly. Also, this is ugly. Let's steal this for a second. Steal that. Let's paste that again. And just say that right here. We're going to call this CTRLF help. Alright, it's control F help. Do not remove this comment. So it's control F help because we want to be able to find the call sites for these functions, which is very hard to find when we add all this indirection of these F macros down here. Right? So these functions are indirectly called by the F macros one, 2, 3, 4, 5, 6, 7. right? So these functions are basically called by the f macros namespace, right? So we go f macros, right? They're actually called from here, right? AAC 2020 direct call wrapped is wrapped. We'll just say direct call is wrapped, right? So there, we summarized it, right? And 0349 50 49 42, god damn it, just call it 50. Yep, because we're already off here. The video ID is what? 0151, right? And the time is this. Okay, cool. Yeah. So right here, right, you might be looking for AAC 2020 loop tick function, but it's going to be wrapped as f macros loop tick, right? So that can be very difficult to find it in the code, adding that indirection. So we're just going to hackishly add this so that when you're grepping through the code or searching through the code, however you do it, that you can find the correct function, right? Because then the wrapped version, the f macros version, is right down here, and they're all called in the order that they are declared. They're all in the libchan order, right? Their relative order right here is based on their libchan order. Okay, so now that we have this, we should crash because this macro doesn't exist, right? So let's give that a run and make sure that we get the syntax error that we're expecting. Okay, exactly what I was expecting. So let's go look at f macros. F macros. We're going to have to open up both of these files. We'll go look at the top file first. Let's go look for loop tick. So loop tick doesn't look like it's been auto-generated. It's just kind of a cut-paste kind of deal here. And I see with this, we've been kind of putting checksums. Whatever. Copy this. Paste it, right? And then everywhere we see tau sync, we're going to change that to PAINT5D, right? PAINT5D. Right? It's just a wrapper function. I'm going to get rid of all that orange, right? Make absolutely sure that that is kind of... I want to say copacetic, but I don't actually know what that word means. But I feel like it's the right word. Okay, so let's go look over here. So here's our library chain. We can see that PAINT5D is 41. So this needs to be a 41 and a 41 to check the number of the system. And right, so f macros loop tick routes to PAINT5D loop tick, right? And then if this system is not included, it's a discarded argument, and this macro ends up being absolutely zero code. So that's kind of like how that works. Okay, so now we want to run this and see if the viewport can kind of change as we're kind of like as we move around the Okay, so let's give that a shot. Okay, so let's press a 1 over here. Cool, cool, cool. Yeah, nice, nice, nice. So there's other things we can do. Now I don't know why this math seems kind of off for how we have decided to, like, I'm not sure how I decided to do this. Ooh, crap. I'm not sure why I decided to have that little inset border. Let's not worry about that though, right? Because we're good. But let's close this. In f macros bottom, we have a loop tick function that we need to undeclare. So down here, this should be PAINT5D loop tick. Okay, so that's undeclared. We can close the f macros. And now we have... our shader code is a bit closer to what it needs to be, right? So my suggestion to myself is to kind of close all this crap. Just close it. Keep this one open. That's my to-do notes. Close. Close. Really what we want to focus on is this fragment shader, right? Close this. And right now we have a lot of hacks, right? A lot of hacks where things are hard-coded in. We've made notes of that. But we now have kind of like that viewport working correctly, right? So now what we want to do is do some sampling. I think we need to do some remapping, don't we? And I don't want to deal with discrete mapping again. But it would be good to get that working. So we are potentially zooming in and out. So that creates problems for us. Okay. Let's get it working. Let's not worry about this too much. But, you know, if we're in bounds, right? If we're in bounds, then we want to use this canvas. The canvas user view needs to be mapped within these bounds, right? And to do that, we need a mapping function. Put a breakpoint here. And we have a mapping function, and it's not the best mapping function because mapping has been proven to be very hard. So let's go in our lib. So fragcom. Frag. Right. We have some mapping functions in here. We put a mapping function in here. It was very hard to figure out mapping. And the best we did was this mapping big to little. And our test functions for this, for the behavior of this, bets are off when it is... when we're mapping from a larger range to a bigger range, okay. So all bets are off if we map in the wrong direction. But what we want to do here is we want to take the coordinate. We want to take a coordinate on the we want to map a coordinate that is on the VP0. So let's go over here. I want to map a coordinate on VP0 to VP1, right? So we want to scan through VP0 and then map it to the off-screen viewport to sample the correct thing, right? So what we're going to say is, you know, what why not steal this and just name it all the same thing, right? So, you know, big SX, big SY, right? Let's just steal this, right? Let's just, bam, just steal it all, right? Throw that in there, steal it, remove the kind of like the kind of like comments, right? Right. And we might as well keep this as well. Just steal it all, right? Steal it all. And okay, yeah, so we're stealing all that. And we might as well kind of lower here. Okay. So this is a ridiculous amount of stuff. And it's IVEC2. So this canvas user view, where are you coming from, canvas user view? Oh, canvas user view is just kind of thrown in there, right? And so all this blending logic and craziness needs to actually come okay, well, one thing at a time. It's a very simple formulas actually right here, right? So canvas user view. Cov, right? And right. Canvas user view IX, canvas user IY, and that's up here. And things are out of order right now. Let's not worry about things being out of order for now. Let's just get it working. And all these values, we need to figure out what they are, right? So, you know, int32 big SX equals fic dot x minus, let's go look at this diagram over here. Right, so we just zeroed out, right? And the SY, the source, right? So the source to destination, we're scanning over this. So scan rectangle. Okay, we're scanning over here, and right, we got this coordinate that's within inside the VP0 thing, right? Cool, cool. So we zeroed out with the lower bounds, right? And so now this is in the range, and the bounds here, lower bounds and upper bounds is the way we did it, right? These bound names are wrong, right? I believe we decided to... Oh no, left and right. Top and bottom. No, these bound names are wrong. We need to change that in the commentary, right? So this is bound... So really what it is bound min and bound max, right? And this is bound min, and this is bound max. That's kind of what we're doing here. Okay. That's how we decided to group it for this. Usually we don't do it that way, but we just found it made more sense this way, right? In terms of visualizing what's going on. So these bounds here... we really can just say they're really just these values here. It's these values here, right? Or not these values, but yeah, these values. So, so let's copy this and just say this is what they are, right? Just copy that over so that we can take this stuff here, paste it down here. And then, remember, it's minimums. We did minimums and then maximums in this, which is not the way we usually do it. So x, y, x, y. So x, y, x, y, and then zeros and ones. So we got the zeros and ones here, and then we got x, y, x, y, right? So a little bit different than we usually do it, but we can see kind of why we did it that way. So we're mapping from here, and then we also need to map to... we need, guess what else we need? Let's paste this. So VP1 is the off-screen viewport, right? So, oh, we changed the thing there, okay. So VP1 is off-screen. So VP1 is, data, texture, and let's copy this. Let's make it bigger. Why not? Let's remove one of these in the middle. And then I don't know. Now I'm just getting too designy. Right? And this is 512 by 512. Or actually... this is, so... yeah, so, yeah, so a point in here would be, if we have a point in here, like a point that we're actually pointing to, then that would be right, so this is actually the canvas user view is what's going on here. That's what this is. I guess we'll widen this a bit up, so we're thinking we could just put a little equal sign in here. Just call it canvas user view like that. Makes it easier. Alright, this is what's happening over here. Okay, so this is kind of how the mapping's working. And that means we also need to get this P5D VP1, and I'm guessing we're not getting that right now, right? Yeah, it's nowhere. Let's go figure that out, right? So VP... So here, we're getting kind of rectangles here. VP0. We can get rid of this no-op, and we're just going to copy this and paste it. Make sure our hard-coded values are correct, though. So, right? So this is going to be VP1. So let's just... let's highlight VP0 really quick and make sure that everywhere it says VP0, we're going to change it to VP1. And then also, we got to change this thing here. Okay? So, VP1, 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 and VP1 is here, right? So VP1, we need to change that, right? So let's go look in Tau Depot for a second, data. And if we look at the variables, viewport 1 is actually given the value 2. So no wonder that's confusing as heck, hard coding these values, right? Because they're just linear, and just coincidentally, these numbers kind of like make it confusing, right? But yeah, so viewport 1 is actually hard-coded as the number 2, right? So 1 is 0 and 2 is 1, right? So 1... Sorry. Port 0 is 1. Port 1 is 2. Port 0 is 1. Port 1 is 2. So 0, 1, 1, 2. 0, 1, 1, 2, right? 0, 1, 1, 2. Okay, got it. 0, 1, 1, 2. 0, 1, 1, 2. Okay, so I know I'm just kind of being paranoid about that, but, right, we screwed that up earlier. So, This hard codingness stuff is very error prone. So now that we have kind of like this PAINT5D VP1 stuff, and we're looking at, hey, there you are, right? So there's the bounds being specified. Nice, nice, nice. And canvas user view.ix.iy will just be set to this. And things are still out of order, so we're not actually going to see any changes, but we're getting there. We're getting there. So we just gotta shuffle some code around, right? But the first thing is, you know, make sure it still compiles, and then we'll work on that. So, okay. Ooh. Okay, so still compiles, so that's cool. And oh god, and we can like resize this, which is awesome. Okay. So now the thing is so here's where we're doing the canvas user view stuff. If we're inbounds. And yeah, we don't really care about this anymore. We don't care about this bounds check because we're doing different bounds check. Well, we still kind of have to care about it, right? But canvas user view should always be mapped within bounds, right? Because we have this SX, SY is always within these bounds, right? Because we have this bounds check here. So cov IX, cov IY should always be within bounds for this code. So we can, you know, assert and we have some bounds checking over here, right? Also, the assert needs to be, you know, on the other side. Okay. So we got these asserts. Let's just make sure that doesn't blow up in our face, because sometimes when we write asserts wrongly, it will blow up in our face, of the shader code, that is. So let's, before we add any more code, let's make sure that works. Okay, cool. And now, let's look for where we're using canvas user view IX and IY, and shove that code into this section, right? So this U32 pixel is probably calculated from so this operation is nonsense, just a placeholder piece of logic for now. I believe it. Let's just trash it. Okay. So we can get rid of this, right? Because that's no longer valid. And this is where we're using it. So we use it. And that gives us the U32 pixel, right? So U32 pixel, where are you being declared? Oh, you're right there. So, oh boy, that's crazy, right? Um, so what we're really looking at here is the core rendering algorithm. 1, 2, 3, 4. So let's, yeah, this is the core rendering algorithm, right? So let's mark it as such. 1, 2, 3, 4. And then let's steal it and move it to where it needs to be. And boy, am I nervous, because that's a lot of code we're moving. We only care about this core rendering algorithm if we're, you know, in here. So, bam, put that over there. And 1, 2, 3, 4. 1, 2, 3, 4. And then we can also, looks like we have enough space to indent one more time. Holy crap. Stick with me here. Okay. Careful now. Careful now. Holy crap. Crappity crap. So U32 pixel, right? So this is a whole bunch of work to get this U32 pixel. And if we get the U32 pixel, we want to do this thing here, right? Copy this. Inside viewport bounds, unpack pixel. Okay. So, alright, so we got those two very similar blocks of code right next to each other. Makes it a little bit easier to look at. So, alright, we're just going to unpack the pixel. We can get rid of this no op here. And this is, I'm nervous. Because that was a lot of stuff, right? That was a lot of stuff. Cov.ix undeclared. Okay, let's go look at where we did that. Oh, right. Let's make a declare variables section, right? This technically is variable declaration. It's just crazy, right? And then we also have, you know, the easy things, right? So int32 cov.ix, and then int32 cov.iy, right? So canvas user view integer y. Canvas user view integer x. So are they int32s though? Or am I just being crazy here? Oh, boy, we have a lot of places where we're using this. Maybe I shouldn't have done that. Yeah, I mean, the way we're comparing it suggests that, yes, indeed, it is an integer. Okay. Well, that's good enough for me. Okay, well, we got it compiling. That's the first step. Now the second step is what the render looks like, so I'm scared. We might got something here. So let's go P for pattern. Load something in there. Well, we're off. So I'd say our mapping is completely off. Right? So this mapping, look how some of this stuff is like inbounds and the other stuff is like so let's go look at how we're mapping stuff, because we obviously are mapping wrong. And so when we map the SX, we take this coordinate, so we know it's rendering, it's trying to render in here. I'm gonna guess this mapping is off. But why is it off, right? Let's go look at this. Mins and maxes, right? Mins and maxes, my friend. We tested this pretty well, so we know that it works, or at least we think it does. Possibly... Let's just hard code in. Let's do a hack here, right? So let's hack this for a second. Also, this is no longer needed, right? So let's just say this right here. I'm gonna make a temporary hack and make sure that we can get it to render how it previously was rendering, right? So, at temp hack. And we're just gonna set these values to the maximum range that everything should be, right? So, the minimums and the maximum should be like 255, right? Just give that a run. Yeah, because it's 0 to 255, right, for what we're rendering, and yeah, I don't know, man. We'll just give it some shots here, and then let's go over here, P for pattern. So we still have what I would call an issue. So my guess is that that this range mapping function has been pretty well tested. Oh, hold on. Oh, I see. We don't need to zero this out, right? Because it's range mapping. This thing should already exist within here, right? Yeah. So we don't need to zero this out. We don't need to zero this out at all. We don't need that. Right? So, we just need... Right? Fic.x is already within this range. So I'm just being stupid. Right? Scan point. Yeah, what the hell? Okay, so let's do that. So no wonder. And then we'll clean some more stuff up after we get this working a little bit better. But okay, let's go over here. That looks much better. That looks kind of much more like what I would expect. And we'll notice that that's not stretched at all, right? And I believe that's because we have not we didn't edit the mapping. So let's edit the mapping now. So we kind of like hacked this. We made a temporary hack because something wasn't working. So if we comment that out, we should have something better. Okay, so we're still kind of effed here. So our mapping logic... Why is our mapping logic off? Now, let's try to resize the viewport and see if anything kind of... Yeah, pops. So yeah, our mapping function is not the best. Because we're going from a... Well, we're going from a big area right here, aren't we? We're going from a big area, this big black area, to this area down here. So that actually should be... Okay, well, let's look at that for a second. VP1 is over here. So we are going big to little, right? It's a littler area. Or is it? 256 by 256. Because it actually seemed to work when we made the viewport big enough, right? When we made the viewport big enough, all of a sudden it actually started to render correctly. Kind of looked like that, didn't it? So let's give that another look here. We know that the viewport is right. That we're mapping to a something that's 256 by 256. Right. This is 256 by 256. This looks like it might be bigger than 256 by 256. But once we get big enough, it seems to do this like snapping thing. Right, so we need a different mapping function. So we're just gonna throw something in really quick, right? So we know the best way to kind of get this working in terms of mapping is that let's steal this. Let's steal this. and we want to map fic, right? Fic fragment integer chord, and we want to map that to, let's not be abstract here. Let's actually say it like it is, right? We want to map fic to, fic to canvas user view, right? So we can say fic fragment integer coordinate, and cov, we want to change the canvas user view. Okay. And we'll just change these formulas around, right? So let's, so what we're gonna do here is we're gonna steal all this code for a second. And we are going to change one simple aspect of it that should make things work a lot better. Alright, we got this, not convert to float. We're going to define this thing called define yes convert to float. And it's going to be make float 32, right? Okay. And with this make float 32, we're going to turn this into a float, we turn this into a float, we turn that into a float, right? So anywhere we see this not, we're going to be like, nope, we're actually going to convert this to float. And then once we get this dp, what are you dp? Dis.x, dis.y, that's an integer. So now we need to say, we need to convert that back to int 32, right? Because dp dis.x, right, that's an ivec2, int vec2. So once we do all this crazy math, where this is a float, then we want to cast it back, right? So make int 32 over here. And also, we're missing one thing. So, this is all float stuff. So this D0 is lit whatever, it's an I32. So we also want to, yes, convert that to a float, so yes, convert to float, plus yes, convert to float. Before we even try to use this function, though, let's make sure that things still compile, right? Because we're getting kind of crazy. I just threw in another function there. And we need to change some names and things as well. Okay. And P for pattern, and then Y to go through the layers, right? So things are still not very good right now. Okay, let's close this. And one of the things I realized is that I didn't put this not convert to float in all the places where it needs to be, right? So not convert to float is just resolves to nothing. So that it actually needed to be here as well, right? And then it also needed to be over here, right? So I didn't actually put it in all the correct places where it needed to be. Okay. And then also over here, we didn't actually need a cast here, but we needed it when we refactored it. So We're going to say no cast over here. And then we're going to say, you know, undef no cast. Okay. And we're just changing this around so that way next time we want to refactor the formula that actually has been well tested, we can do it a little bit easier. Okay, pattern. Okay, so the renderer is still working. We have some issues, but we're getting closer here. So now let's close this and start working more on this. So let's go analyze this code for a second. So let's actually give them these names, right? Let's actually do this. Let's not beat around the bush. Hold on. Let's do this in multiple steps here. And we are going to give it kind of these... Well, actually, hold up here. We already got these. What's the point in unwrapping them, right? We're just making more work for ourselves, right? So, let's undo for a second. Let's comment this junk out. Let's comment this junk out. Right, we know what it was previously. Let's comment this out. Let's delete this. And this range is also fic, right? So let's comment that out. Let's comment all this stuff out in the signature. And we just want to rename this to fic is a int ivec2, right? It's invec and it's called fic. And over here, this is going to be an invec to p this thing, right? Name it how it is, right? This thing is invec2 as well, right? Are they invects? Oh, they're recs. My bad. We'll fix that. So this is a rec. So we got these things here. Also, rec is not actually declared in this general use case area, is it? Yeah, it's not actually used in here. We'll fix that. So over here in this kind of big section of, we're kind of like, we got our macros here. We just want, right, this is GLSL, so define rec as struct AAC 2020 fragcom rec. So that is 22. Okay. And fragcom rect, are you down there? Yeah, there you are. Yep. And then, if we are this code over here, which is also 22, 19, 20, 21, 22. This right here is going to be poly OGL, right? The OpenGL polyfills. Oh, oops. Oh, wrong name. Alright, so poly OGL. Right, so if it's C99 code, that's what it is. So rectangle. Cool. So now that we have this rectangle type, let's go look at this crap we're refactoring, right? So, fic is now going to be reassigned to this. So let's kind of, let's focus on one thing at a time. So fic. Let's refactor fic. Do we just want to keep the macros like this? Yeah, sure, why not? So this is going to be source index, and we have a x block and a y block, right? Yeah, so this is the x block. So this is going to be fic.x, and then we can keep this commentary here, right? And it looks like if we do that, then we just have to do fic.y, and then we can comment that out, right? So si, cool. And then, yeah, fic is done. Okay, so let's go look at this now, right? So, bam, all these guys need to be changed now. Let's use orange here. Make it more obnoxious. Okay, so over here, we got, this right here should be, so they're all P5D VP0s, right? Dot X, right? And this is, you know, X0, and this is X1. Okay. And then over here is the y-axis, so the same deal. Same deal, but the y-axis, right? So these are y's. And we can still keep these notes, right? So, let's kind of keep those y's and x's kind of nicely aligned. Like that. I like that. And let's do that over here as well. So x's aligned so we can see all those x's, and then we can see all the x's here. So we know we haven't screwed up. We got the x's, and we got 0, 1, 0, 1. Excellent. And then over here we have the y's, and we got 0, 1 here. We got 0, 1 there, right? So that is correctly refactored. So now we need to look at this section right here. So all these guys need to be refactored. So this is P5D VP1, right? So we gotta go P5D VP1 dot blank that out so we can replace it later. And also this should be the X0, X1s, right? Because these are X values. Yeah, the minimum and maximums on the X. Okay. And then let's go over here. And we know it's going to be this P5D VP0 stuff. And then blank that out to get ready to replace it. And right here, it's going to be Y0, Y1, right? So zeros and ones, and these are all Ys, right? And these are 0, 1, 0, 1. Source and destination. I feel like I've screwed this one up because these are all the same. Yes, we have screwed that up. Cool. Okay. So let's cross-check this. Let's make sure that everything looks correct because we did make a little mistake when we were refactoring. So let's make sure that let's look at well, first of all, let's look at these. Make sure that they're different, right? Make sure that these all look like they're in roughly the same place. Purple, cyan, orange. Purple, cyan, orange. So we got symmetry or analogousness between those two blocks. And the next question is, okay, well that's there, but do we have X's and Y's in the correct spot? X's and Y's look in the correct spot, but the thing we made a mistake on here was the VP0 and VP1. So purple, green, orange here for the Y, cyan here for the X. This is the X block, this is the Y block. Okay, yeah, so I'm pretty certain that that is correct. DST dot Y, DST dot X, DST is defined over here. Okay, yeah. So, so this is bounds of input fic, right? So this is the bounds of the input, right? bounds of output bounds of sample chord, which is bounds of input, bounds of fetch, right? Right? So fic, fragment, integer chord, right? Fragment, integer chord, and bounds of the input, bounds of the fetch, right? So we, designed to scan over the on-screen viewport, P5D VP0, and map to the off-screen data, P5D VP1, P5D VP0 equals canvas viewport on-screen sub area of client. P5D VP1 equals off-screen data to sample, right? So let's make a note of here. At vid IID 0151. Time is 4 hours, 51 minutes, and about 23 seconds to keep up with the conspiracies here, right? So we have a pretty good explanation of what this is all about. Let's back up 1, 2, 3, 4. And doot. And then back up 1, 2, 3, 4. Make sure that looks good. That looks good. That looks good. Yeah. So yeah, that's what we're doing here. We've got a nice little explanation, and we're not using this function yet, right? We just want to write it and make sure everything still compiles, and then everything still compiles. Then we're gonna throw it in, right? So I don't know how this formula will work. I just have a hunch that it's closer to what we need to get working. Has no member x0. Oh, wait. Oh, because this is not... This also needs to be a rectangle. What am I doing there? So our refactor wasn't quite exactly what it needed to be. Okay, now let's give that a shot. Define rect, struct, rec redefined. Oh, you know what? Because we defined rect up here, right? So the 20-second thing is the rect, right? In terms of our 3-letter macros. And down here, we forgot to undefine that. And in fact, we forgot to undefine a lot of things. So air, 21, 22, and 23 are all things 20, 21, and 22. Oh, so true and rec come after air. Okay, so we'll just go boom, boom. This is true. I don't know if that's actually what it means, but rec, that's how I'm reading it. 21 and 22, right? Okay, so now right? Write a little bit of code, try to get it running, write a little code, try to get it running, right? Very small steps, because otherwise you can end up in some trouble. So now, P for pattern. Now, we aren't expecting any changes yet because we're not using that new mapping function. But what we're hoping is that that math is correct, right? We're getting weird results because we're not doing any floating point calculations, so everything's getting like truncated, and we're getting just drastically wrong looking results, right? So with this, what we're going to try here is we're going to try to just comment this out really quick, right? We're just going to try to comment this one out. Oop, hold on. Comment this out. And then we're going to try to say, I'm going to say cov equals, and then this, it's like this function name, right? But we're going to map the fic, right, to the cov, right? And we're actually just going to give it these things, right? Fic. And these guys, right? Right, so if we go look at this, let's go look at that for a second. Right? Correct parameter orders. And let's go look at our diagram. So VP0, we're going to map from here on screen, and we're going to map to over here, right? So, right, that makes sense, right? So now that we got that, let's give that a shot and see if it looks better, because we don't get weird truncations, because we're doing some, we're making all that math that was integer is now, all the math that was integer is now, oops, bad. Actually, no. All the math that was integer is now being converted to float and then casted back to integer just when we're done. And so I'm actually expecting this to just be, bam, it's going to work, right? Now, we don't have pixel perfectness depending on what units we choose. So depending on what resizing we're using, things may look better or worse. But I think that, yeah, like I said, yeah, bam. Right, and now if we resize this, yeah, ooh, nice, ooh, ooh, okay, badass. Alright, so the idea is we could full screen this baby. Okay, so now we're full screen, and we had like a zoom. I don't remember what zoom was, though. So over here, we got this, and, zooming out was, zooming in is V. Okay, so zooming in is V. Let's give that a shot. Bam, okay, cool. And then we have like J, K, and L. So we can go over here, we can go, nice. And then if we want to zoom up, we can go, right, do. Right, and then it centers, right? It centers once we've zoomed in once we've zoomed out as far as we can go, it doesn't want to zoom out anymore. That's fine. That's kind of how we designed it. And right? Nice. Fuck yeah. Okay, cool. So we have what I'd say is that is pretty dope. To say it like a teenager, or maybe not a teenager anymore, but getting kind of old here. Nice. So let's go see if we can find Master Z, see if Master Z is up. Alright, I messaged Master Z, see if Master Z is awake. And do we have anything incriminating on the screen? No, we do not. Let's see, so Master Z. Is Master Z awake? We will wait and see if Master Z is awake. Because we want to show Master Z. Because nobody else is going to be awake. And we want to show off what we've been working on. So anyways, we're getting something here now. So let's go get Bash here for a second and say, zoom in and out, right? That is, Josh should be able to set tiles within the design by clicking inside the editor. That's the next thing we need to work on. Camera controls are working. Did we? Yeah, we committed. There we go. And then we want to do a git push to... Okay. So now the next thing is, like, right, we figured this out. At vid IID. So what's the video ID? So 0151. Time is 050042. Task 1 finished. Or 2do1 finished, right? 2do1 was finished. We can also look at this. Let's get ./AAC2020.sh. Let's give it one more run for the camera, right? Because we just finished this task right here. So let's document it for this timestamp right here that we're seeing. Let us document that, right? So if we do P for pattern, and then we go through the different layers, we can see this. And if we full screen this, we can see this. And then if we zoom in, so if we zoom down in there, we can get on in there, right? And then we can kind of move over, right? And we can move down, right? Nice. And does the speed kind of increase as we zoom in further? Yeah, it does, because we get down to like pixel level. Oh god, no, we blew up. Oh god. But we're pretty good there. We're pretty good there. I mean, it looks like we screwed something up, but we'll figure that out later. I mean, we're getting good though. We're getting somewhere. So, what do we want to do now? So we got that down. Josh should be able to set tiles within design by clicking inside the editor. So in order to figure that out, we have to be able to use we have to be able to reuse some functions to figure out, like, well, where's the mouse? And we want to just be able to reuse the same kind of logic, right? So what we need to do for that, to get that working, is we want to make some type of reusable function that tells us where the canvas user view is, right? Because the canvas user view is where the mouse is. We want to use the same code right now, right here, that we're using for the fragment coordinate. We also want to, instead of input a fragment coordinate, input the mouse coordinate, right? And if we do that, then we can detect where Josh is clicking, right? So the first thing is let's kind of nuke some of this code. Bam! Out of there. Okay. So now, after that, we have rendering code right here, right? Core rendering algorithm. And we have inbounds, blah, 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 temp hack, scanning rectangle. Get rid of this junk, right? So we can start getting rid of some of the junk because we got stuff working. And this thing right here. If we're inbounds, We're going to do some mapping. And it's going to be canvas user view equals the fragment integer coordinate mapping to the canvas user view. Okay, so really, you know what? This function is all we need, right? We just got to reuse this function. But instead of inputting a fragment coordinate, come visit Twitch and I show you thingy. Okay. Alright, so, yeah, we can just use this function to, we just gotta input, like, the mouse coordinates, and we're good to go. Let's close this. Let's open up, PAINT5D functions, and, I don't know, let's just look at mouse, see if we can find mouse input. So no mouse input, huh? So input. Let's look for input for a second. Input. God damn it, we're going backwards. Go back up here. Oop. Home. Am I using the insert key right now accidentally? No, I'm not. Okay, so now we're going to look for input because delta of inputs, blah, 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 blah. Why does this look like bounds check inputs? Maybe I should have said user inputs because we have a lot of, we're using input everywhere. So, no. We know we have user inputs or something like that. PAINT5D, zoom, move. Let's look for the keyword move. Move camera, right? Move camera XY. And then here we go. So in this function, this is where we're calling this. This is like keyboard input function, right? PAINT5D key in, right? So keyboard handler, right? Do we have a mouse handler? I don't think we do have a mouse handler. Let's look for mouse. We don't have mouse anywhere, do we? No, we do not. Okay, so what we're gonna do is I honestly almost want to like just break this into another function or another what do you call it? I kind of want to break it into another file of its own rather than so mouse input handler, right? Mowin, right? Mousin? Yeah, sure, why not? And the mouse input handler is, right, it's not going to be aware of the keyboard, which means we can't do, like, mouse keyboard combinations. But I don't care because we'll worry about that when we actually really need something like that. We'll worry about it. For now, we're just going to write it in the simplest way, which is we have a mouse handler and we have a keyboard handler, right? So in the mouse handler, we might as well kind of say I32, and then let's just steal this, right? So steal this for a second. And it's mowin, right? So mowin, right? Mouse input. And int32 mouse x, mouse x, mouse y, do we really want to do it like this? we need to know if we're clicking or not, right? So are we clicking or are we not, right? Do we really want anything other than that? So I only really care about a click, right? I don't really care about mouse down, mouse up. Alright. Mouse. Okay, so we got all these kind of things here. So we're trying not to get too fancy, right? We just really want to know mouse X, mouse Y. We want to know if we're if it's a click or if it is a drag, right? Click, is it a click? Is it a drag? Or if, oh hey, sorry, I just sorry, I was like not, you know, I told you to come over here and then I was like I told chat. Okay, so, are you still here? And also, I really need to get some I really need to figure out how to get this to do a sound notification. Do I have any of you in chat? Sorry. I need to make chat make sounds. I see you there now. So, yeah, I can show you what's up, though, with the, let me move this over. Okay, so I actually am looking at my chat now. You know, I'm just gonna open up, I'm gonna just put the stream manager on one monitor, put Discord on the other monitor, so I can see, both things, so when you reply, I'll actually be able to see here. So, we want to know, is it a click, is it a drag event? Right, and we also want to know, and this is kind of ugly the way we're going to write it, but it's like we just want to get, we really only care about click, we care about drag, right, if it's a drag state. Is that how we want to do it, though? I don't know. Okay, well, let's think about what's most important. Let's just make a struct above it. Actually, no, let's not do it. So PAINT5D. Let's go into PAINT5D for a second. Into the data file. Once again, we have things on the wrong side. in the data file, we should have like structs and things and all that good stuff. This is really like a, so do we really want a, do we really want some type of state thing, right? So, do we want a state object for the mouse? Because eventually we're going to add click, we need dragging, we need a whole bunch of state stuff, so... So I think I would like to keep mouse X, mouse Y kind of separate. So we always kind of know... But if we're gonna put the click and drag, we might as well put mouse X and mouse Y in there, right? So what I'm thinking about is, you know, a mouse event type or a mouse state. But if we have a mouse state, other editors are going to use that, right? That's kind of like common data, right? Oh, but I can hear you. I'm here. My PC is rendering, so it occasionally freezes, but I can hear you. Yeah. So, are you ready to see stuff? Because I have stuff. I have stuff to show you, and I can show you. But you're saying your PC is kind of temporarily freezing. Yes. Okay. Well, let's try to compile this. And I was in the middle of some stuff, so I might have to remove some syntax errors. But let's get this rolling. So the editor is underway. I got the camera controls working. So the camera controls are working, so that's cool. Cool deals here. So we'll go over here, right? And now let's go P for pattern, and there. So now we have it nice and centered, right? And then we can also full screen that, right? And then, can you see this? I think you can see this. And then we want to zoom in, right? So we're going to use the R key to zoom in. Or actually, no, the V key. V key zooms in, my bad. So zooming in there, and then we can go kind of move around here, right? Woo! We can zoom into our tile editor, right? So we can zoom in, we can zoom out, and the way the camera control works is it's not allowed to go outside of the bounds, right? So this is as far as we can zoom out because we're not allowed to zoom out any further than the tile set that we're working on, just because. That's the way I decided I wanted it to be. So when we zoom in, we're looking at the 1 pixel level here, right? We're just looking at 4x4 pixels, and the camera controls kind of move a little bit faster because it's kind of like snapped to every single pixel, right? So it kind of moves at a different speed as we kind of zoom out, which is kind of like, maybe I should fix that, maybe I should change that. But for now, that's kind of how it works, right? So right now, I'm taking the function that maps, so there's a function that scans across this rectangle here, and it maps every single fragment within this rectangle to the data, right? So it maps this rectangle to a data rectangle, and that's how I'm kind of like sampling things. So now I need something that, I want to take the same function that is mapping a fragment coordinate to the data, and I want to repurpose that function that takes a fragment chord and converts it to the data I want to reuse it, and instead of using a fragment coordinate as the input, I want to take a mouse coordinate as the input, so that way I can figure out where I'm clicking on here, right? And once I know where I'm clicking on here, I can start to edit this pattern and draw on it. This is gonna get badass, and it's gonna get badass really quick. So I am effing excited. Like I say, you can say whatever words you want to say. It's just I'm trying to be, I'm trying not to get myself labeled as a mature stream. So I don't actually have any problems with swear words. So I do want to say that because if I'm self-censoring my speech, I don't want to make it sound like I'm someone I'm not. So I feel like by avoiding swear words, it makes it sound like I'm a different kind of person than I am, when really I'm just trying not to get myself in trouble. So it's like high school all over again. But now my teacher is Twitch. So yeah, so right now I'm kind of contemplating how the mouse input function is going to work. And I'm thinking, you know what? There should be some type of general mouse state object. Yeah, there should be some type of general mouse container, I think. Right, because, and there's going to be multiple, different, a whole bunch of systems are all going to share kind of mouse state stuff. So we really need to figure that out, right? So let's go look at, we have like a mouse something or other in here. It's called like mouse box. So let's go look at that data for a second. So we got mouse X, we got click, we got mouse up. So I'm thinking, no, we're not going to do this. We already have this kind of global state here. And, well, we got to be careful about that, right? Because, in this case, we're okay, because this is just an editor. But if we want to pragmatically access things, right, if we want to pragmatically draw on the tile set and emulate the mouse moving and clicking, right, to auto-generate stuff, we can't be hard-coding these in the function, right? So this function that has that's going to take the mouse input, we might want to make it a pure function, saying that by a pure function I mean we're not going to reference these hard-coded file scope mouse variables in here. We're going to pass them in so we have a little bit more flexibility. I think that would make sense. So we're going to have to create a mouse container, like a mouse state container. And we could actually just keep all this stuff, right? Mouse down X, mouse up X, mouse currently down, mouse currently up, click X, click Y. Are these the best variable names? Is this the best way we can represent the mouse state? God if I know. So with that, we want this to be... We want the mouse struct to be a temporary container. Do you just want to put it in here and be like, make an iMouseBox struct? I don't know what I want to do. What do I want to do here? We could just put it in here, right? We could make an iMouseBox a container, and it could be like a temporary state container. Now, how do we do temporary state containers before? That, so if we look at GPU data, I know I did something with GPU data's organization. I want to look at the declaration order of certain systems, because I know I did something kind of fancy in here. Or not fancy, but if we look at GPU data... Where are you, GPU data? GPU data, GPU data. So, GPU data is a temporary container. And pixname, where is pixname? Pixname is right here. So pixname is where everything's actually supposed to be. GPU data is a temporary container that we can load the pixname variables into, right? So we want the kind of same thing with the with this mouse container, right? So iMouseBox is the actual state, right? Is the global state of the mouse, and then we want like a mouse a mouse container, right? iMouse box. Well, we got a box. So I don't know, iMouse car for iMouse car. I don't know, like a temporary container. So mouse temp, something maybe like that. I don't know, what do we want to call it? So 7 letters. 1, 2, 3, 1, 2, 3. Mouse temp. Mouse temp. Mouse. Call it mouse TMP. Mouse TMP. Nope. No, mouse temp looks the best. So the idea is to call it like it's a temporary state, right? We could call it mouse event, right? It could be a mouse event, but it's not really an event, right? We're not actually making events, right? We're not doing ActionScript. We're not doing an event-driven design. So I don't think calling it a mouse event would be proper. I think that we need to just call it mouse temp, right? And it's mouse temp. Mouse temp is the temporary container for mouse state, right? And when we want to pass around mouse state, we load it into that temporary container, right? And then we can have, if we really need a kind of like container that is always passed around, we can do that, right? I think that's how I want to roll with this. So let's do that. Let's call it mouse temp. Yeah. So that's how I'm gonna roll. That's how I'm rolling here. Okay. So, struct. And it's gonna be AAC 2020, Mao temp, right? And it's gonna be all the same kind of things that are in here, right? So we're literally gonna just rip all this out here, right? We're gonna rip all that out and say, hey, it's gonna be the same kind of stuff as what's in here, right? So, temporary container for values of same name in AAC 2020 iMailbox. Right? Temp container, so we can pragmatically call mouse input functions in future, right? Right. So if we hard code these values into the mouse handler, then we cannot eventually pragmatically call it. So we're going to roll with it like that. Okay. So then we want to just say, oh, these are U32s, and we can do this, right? Now, I think that this could be a delta X, delta Y. This could be a I don't know. This could be canvas X, canvas Y, right? These could be different things. So we're going to make these more verbose, I think. Because these can be very shorthand here because they are permanently affixed to these namespaces here. So I'm gonna change these names to like click CLK instead of CLI, just because click is a pretty standard thing there. And this is up, and this is down. Up, down, and this is is down and is up, right? So, and then these things right here, actually, we can do this. We can take these same names here, right? So we can have some linkage to the original names, right? So some homage to the original names. So just making these variables a little less terse. So, right, we can keep that kind of thing there, right? So, do you want to say is down, or do you want to say... Down and up are these are only different by one letter, which kind of annoys me. How about this? Down. Dow MD. And then up. Up. No, and this all is, right? Is mouse down, is mouse up, right? And so the idea is that we're taking all the same variable names, right? We take all the same variable names we had before, but now we just add kind of more terseness to them because now they're these member variables, right? And so that way when we're assigning them from the iMouseBox stuff, we can get that to, it'll just work, right? So, right, so if we paste this, right, right, this is, you know, iMouseBox, you know, right, it's these things, right? That's what they are. Mouse is down, mouse is up. And this is, you know, iMouseBox, MD, iMouseBox, MD, and MU. And we gotta save this somewhere. Right, so we can keep... God damn it. No. Cancel. We gotta save this. iMouTemp, right? Temporary container. It's a temporary container. Let's save it as MouTemp. 4 letters, 3 letters, make 7 letters. Data. File new. We need a function file as well. So, iMouTemp.f. There are no functions. This is a data only subsystem. Sub and what do you call it? Retain the right to change my mind on this in the future. So yeah, iMouTemp. iMouTemp dot functions, or yeah, dot functions dot underscore. Okay, cool. So we got this kind of struct thing here, and structs need a semicolon at the end of them like that. And now, main struct, or temporary mouse state container struct. That is a mouthful. But that is what it is. Okay. So now that we have this, looks good to me. What else do we want to do? Well, we need to define U32 as well, because otherwise none of this is going to work. Undef U32. Okay, cool. And get rid of that, get rid of that, get rid of that. Maybe close this off like this. Why not? But then we have that problem all over again. Let's just, bam. 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 Okay. So, that looks good to me. Now we need to actually include it, right? Because if we haven't, my organizational skills, yeah, like, you should see my life. And then you won't envy. Yeah, so it's really weird, like, so I don't know if you've seen, like, you've seen this one video by this one guy who talks about organization, but he's all like, keep your place clean, because simpletons who don't know code will just assume your code is clean because your apart office is clean. So I think that's true. I think what he's saying about that is true, but I think that, my guess is that if you spend all your time meticulously making your exterior environment clean, you don't have the effort to make your code clean. And then conversely, well, I mean, I have organized the basement a lot. There's a lot of shelving and stuff. So maybe it's just a matter of monetary finances and having all the money for the shelving, right? But I sometimes think that my code is organized because I spend all of my movement points on or all my ego points, all my what do you want to call it? Brain points. Call them brain points. Yes, exactly. Pick one. I spend all my brain points on clean code, and therefore everything else around me is a disaster. So I sometimes wonder about this person who has this very clean apartment, and all the clients are going to be like, yeah, their code must be beautiful, let's hire them. And it turns out their code is actually a complete disaster because they spend all their time cleaning their exterior environment. It's just a guess. I mean, maybe they're just ungodly at both for some reason, but I'm not. But yeah, clean office or clean code, pick one. And also, let's disclaimer here, I don't mean clean code in the sense of the book. My idea of clean code is not the same as the book. Disclaimer. The book. But it has some good points. Clean code does have some good points in it, but I hate most of it. Because that's just because I have a batshit crazy way of writing code, right? So of course I'm gonna hate most of it. Okay, so we got this thing here. Let's go into our main C file where we're kind of chaining all of our dependencies together and look for where should it go in this hierarchy, right? And we know that the input only is going to really matter for is only going to really matter for the PAINT5D system and any other editor that comes after that. However, we have decided that we're going to have this thing called GPU view. And what is this? Okay, GPU view is the shader that renders the texture memory in Tau Depot. So it would make sense to to have this state object somewhere before that. In fact, the frag, so what else do we have? Let's go further down. So we have frag bed right here, and frag bed doesn't have any complex behaviors right now, but it might be nice to eventually maybe load some more detailed shaders in here that can have mouse control or whatnot. Maybe we want to actually interact with this thing in the future. So what else do we got down here? GraQuad, which is the gradient quadrant code that FragBed is built on top of. The window code, keyboard listener stuff, the mouse stuff, CPU side uniforms. So we know that for the mouse stuff, you know, knowing stuff about these CPU side uniforms might be important. I'm honestly going for this free spot. I might say that, hey, we finally found a way, something that kind of like fits within this free spot. Like, this is where it belongs. It's just naturally kind of where it goes. I think that's a decent place for it to go. We can always change our mind later. Right, so what we're looking at here is this dependency order is just, we have a dependency tree, we have a conceptual dependency graph, and what this linear list represents is taking that dependency graph and solving it, right? So eventually, when you have a graph of dependencies, right, one thing includes another thing, and that thing includes another thing, and you have dependency injection or whatever, eventually you have to come up with a definite order of dependencies, right? So this is just the definite order of dependencies, but it doesn't mean that there's not a conceptual graph or tree of how all these dependencies are related, but this is just the solved state of that, right? And the reason for that is just because I want to know exactly how the code is actually put together. Using dependency injection, I won't actually have a firm grasp on what is actually going on at that level. So, yeah, I think that we could take the free spot. I think we're going to steal that free spot. Screw that. We're just going to throw that in there and call it a day. So we're just going to say free spot finally is going to be used after all this time. So, moutemp, right? So, mouse temporary. Mouse state temp. Right? Mouse state temp. So, the idea is that it's a mouse state container, but it's a temporary container, right? And I want to kind of drill that into there because the actual mouse state that is not temporary is file scope and iMouseBox, right? So we might want to say in iMouseBox for a second. Looking for struct version of this. See iMoutemp. Temp mouse state container. Right? So we can make a little helper note here. You know, if you are looking for, if this is what you're looking for, right? So we want to comment things in a way where we're kind of, our current self is the curator. We're like the, what do you call it? Curator? We are like the guide, right? The comments are supposed to function as a guide to help people find their way around things, right? So if you're in here and this isn't what you're looking for, if you find yourself in here and this is not exactly what you're looking for, then the chances are you're looking for this. And conversely, I don't know if I'm using the word conversely correctly, but I think I am. if looking for global state and not temp container. You want AAC 2020. You want IMAU box input mouse box, right? So now we have something like that. So we can help our future selves find the way around this crazy, crazy world of code. Okay, so now in here, yeah, we got this IMAU temp, right? Mouse temp. And now that we kind of shoved that in there, we don't have to change the libchan. Well, we do have to change libchan, but we don't have to slide things around like we usually do. So that's nice, because that can take forever. Well, it doesn't take forever. It takes about 30 minutes. It takes about 30 minutes to stub in a new subsystem when we have to shift everything around. So, so now we can just look for free, right? Free spot. And this free spot is no longer a free spot. We're getting rid of this free spot. And this is now, it's a mau temp, right? Mouse temporary. And then we want to look for the other thing that says free spot. So let's go find that next free spot section and delete this comment because it's no longer a free spot. And then in here, we're just going to replace that free spot with mau temp. And the reason I created a free spot was because I didn't want to shuffle code around anymore. Because, like, this is a very rigid way to organize code. The pro of this is that when somebody is looking at the code base and wants to figure out how it's put together, it's going to be very easy to conceptualize how everything's put together, because of how I'm being very explicit with things and very rigid. But with rigidity and lack of abstraction and clarity, with all of those good things comes bad things like not having flexible code. But I don't care. I think that the understandability of the code is most important, and if I code slower because it's not as flexible, so be it. Okay, so now we want to go to the bottom file here, and we should have a free spot in here, right? We should have like a thing that says free right here. And wherever we see this free spot, we want to just replace it with, guess what? Mau temp, which sounds kind of like mountain. Mau temp. So I do try to make everything, when I make everything 7 letters, I do try to make sure that it is kind of like has some pronunciation, even if it's like a like weird sounding thing, as long as I can pronounce it. So that is something from clean code, where clean code says, you know, you should make your variables pronounceable. And I say, you know what? Yeah, I agree with that. Try to make your variables pronounceable so people can talk about the code. Sure. But what I disagree with is making names where, like, you know, doing the Lego naming thing. Right, because eventually you need to condense your you don't want to do agglutinative naming all the time, right? Where you're like, you know, so like, you could say, you know, you could say window external visibility controller. How about that? Window external visibility controller, right? So let's talk about this for a second. You could call something a window external visibility controller. So that is a mouthful, right? And clean code would say, "Oh, this is a great name. Good job, bro." No. You know, that's not what it's called. It's called a fucking blind. Oh, sorry, I'm not supposed to swear. It's called a blind. Okay? You know, Now, how about, I don't know, I don't know. How about a cushioned... How about a... extra fluffy cushioned chair. How about that? Extra fluffy cushioned chair. That's a great name, isn't it? No, that's called a lazy boy. Okay? You know, how about a multi-barrel rotating mini cannon. How about that? No, that is called a Gatling gun. Okay? You know, large iron, ball launcher. That is called a, trebuchet. Okay, how about a gun-powered large iron ball launcher. No. That is called a cannon. Okay? So at some point when you are making code, you need to start making up words. Right? Because you cannot think about this at the next layer of abstraction until you condense it into a smaller word, right? So you cannot think of at the next level of abstraction until you condense the word into a terse word. Terse/short word. Example, you won't invent a Gauss cannon until you stop calling your cannon a... Right? Same applies to your code. You can't get to the next level of abstract thinking until you stop your Lego naming. Okay. So this is at vid IID 0151. And the time is, 5 hours, 52 minutes, and how about 13 seconds? Date is 2021, 0223. Okay, yeah. So we're going to take this rant here. Documentation. Where's our documentation folder? Doc. We're just going to name this folder. How about rant? Because why not? Okay, cool. So, that's good. That's good, man. So let's also just throw this into, why don't we just put this on our blog, right? Because we rant and we think we're so smart. But actually, no, I stole that from, somebody else's talk. So, but let's go put that on our blog. So, www.blogspot.com. Sign in. Don't show my password. Don't show my password. Don't do it. I might as well. New post. Lego naming. Prevents higher level thinking. And we'll just paste that in there. And let's paste that in there. Let's go into the web view, for example. And let's just do a pre and pre. And just throw that in there, right? Bam! And then look at the HTML view. And then... Are we still in the pre? Or... It's a canon. Powdered large iron ball launcher. Box. I'm just gonna be offensive. Yeah, there we go. Clean code. Canon. Terse invented concept in your code. All right. Let's change the color. That's not the color. Oh, oh, wrong deal. If you agree, check out my data, So I just like to do it this way because I don't want to force people to click this. Sometimes people want to highlight things and copy them. Okay, yeah. Make up new words, right? Yeah. So anyways, yeah, let's just take that, publish that. And I think the best way to get views, I think, might be to be inflammatory, right? So, right, you say something kind of offensive, right? Right? You can't say, hey, this thing is everything, you know, if you agree with the status quo, right, nobody notices, right? They just, like, they're looking over articles and search results, and they just see, oh, status quo, right? And it's the thing that stands out, that is against the status quo, that actually piques people's interest, right? Like, water boils at, what, 100 degrees Celsius or Fahrenheit? I don't remember. Right? But if you said something batshit crazy, people's gonna be like, wait a minute, and you might be wrong with your assertion, right? But, you're gonna pique people's interest. So, okay, so this in here, the top file. And then the bottom file, we want to also look for. Oh, did we already do that? Did we already do that already? We're good. However, we want to go open up the F macros as well, and we also want to open up silence. We'll get this in here, one step at a time here. So this is a data-only class. It's not really going to have any initializer code. But we still want to keep a consistent pattern in our code. So, and it's going to be in the init none. We don't have any initialization for this. And its position in this array is where? It's, where are you? We got too many things open. Close some stuff. Put this over here. Okay. libchan. Close you. Close you. We're done with libchan. We want to look at this and say it's right before fragbed. Gracquad, native key, ikey, CPU info, and pick save. It's in between here. Okay. So, mautemp. Right? Because if we look at this, let's clear both of these for a second and do token highlighting. So we got we got CPU info, we got mautemp, and we got pick save, right? In that order. And if we do CPU info, mautemp, and pick save, right? They are in that relative order, right? So that's good. That's how I want to roll here. And now that we've inserted that, we're going to take all this source code here that's going to auto-generate stuff for us. We're going to copy that, and we're going to rebuild this list of wrapper functions, right? So this is getting out of hand. Eventually, we might want to make some type of build system that automatically does this for us, but for now, we're not. So, bam! Run our little script to kind of generate all that code for us, and then we have to, our script, it's either a script or our source data has extra spaces in it somewhere. I don't know why it does this, but it does this. I don't want to look at my AutoHotkey code because I hate AutoHotkey code. I don't want to look at AutoHotkey code unless it's absolutely necessary. So I'm going to deal with the time waste of this. Okay. So I'm convinced that's ready. But we also want to look at F macro's bottom, right? And in F macro's bottom, we have some init none functions. Oh, we put init none and init. We laced them together so we could keep like a list of everything. And how the heck did this happen? Because, oh, here's our free spot right here. So we want this to be a init none function, right? So this free spot right here, we're gonna Grackwad mount temp is 21. What is up with this? Oh, they just don't have init or init none functions, right? Okay, I get it. Which they should just so that they're accounted for, even if they don't do anything. So then in iMouseTemp, right? This isn't actually this subsystem isn't supposed to have any functions, but we're gonna do paste init none function or something like that. Oh, there we go. Yeah, bam. And moutemp. We're gonna call it moutemp. And yeah, that's fine. That's what we're gonna call it. And let's change this a little bit. Right, so okay. So that's in there. Also, we want to look at the silence system. So let's go open up silence and the data. And we want to insert this correctly where it looks like. Pixelo, look at this code. I don't know why I need to look at that code. Oh, we have a little question mark. Oh, so we need to assess logging for that. Let's not worry about it. And Grackwad, and then is, oh, we got the free spot. It's right there. So, free spot has now been changed to moutemp, right? Mouse temporary container. And then the free spot right here is going to be moutemp. And, there really isn't supposed to be any logging code for that, right? But, just turn it on in case, right? In case we change our mind. Yeah, let's not worry about that. That's fine. So we got the bottom file for the macro, the top file for the macros, but we need one more thing, right? So in our library file, in our library code, we have a main code in the main functions, and then let's go look for init none. And let's not match the case, let's just look for the phrase. And yeah, we got these init none functions in this block, right? And then we have we got these wrapper functions, and then this is the second cluster of functions. And 21 was the system, right? 21, where are you? 21? Right, so this is now AAC 2020 moutemp init none. Okay, and then down here in this free spot, it is going to be f macros moutemp init none, which init nones are looking like they're getting this as 0 rather than this x macro, which is also 0. They're all getting zeros, but okay, cool. I think that's about ready. I think that we got everything stubbed in there. So now it's just a question of, hey, does this actually, you know, does it compile, right? And let's keep track of, I have a lurkers thing. So 20, 21, 02, 23. I'm looking through my old the chats for today, and I am just making notes of things that were said. I just want to I want to get back in touch with people that have kind of gone over my stream, and when I get a better connection, or get my Ethernet cord so things don't screw me over. The video for that was probably 148 or 149. I don't remember. Okay. So let's just keep going here. So we expected... Oh, did we, let's go look at how we define that. Let's close this. Let's look at this, though. Struct. U32, U32, that looks correct. Why does it think we're being stupid? This is not Golang. This is not Golang. We can't do this kind of stuff. This is not Golang. Duh. So we can't specify default values like this. This is not, in Golang you could do something like this. And people say Golang is like a more modern C, or a better C. I think it's the other way around. I think C is actually better. Just because no garbage collector. So yeah, we can't do that. Bad habit. So now we mautemp.f._. No such file directory, huh? mautemp.f is not a thing, huh? Well, then what the hell do we call it? Oh, yeah. Wrong name. Rename to mautemp. Save that. Mautemp. Not imautemp. Is this also improperly named? No, that's fine. Okay, let's give that another run. And okay, so did we screw this up? Yeah, we did. We forgot our little semicolon there. And did we don't gotta do that there, though. Okay. Let's actually kind of zoom in here. Let's make this a little bit bigger so people can see it. There we go. That's a little bit crazy, but... Okay. So everything's stubbed in, right? So things are stubbed in, and we're back here. We can do P for pattern, and we can kind of zoom in here. And then we got the R key, no, the V key can zoom in here. So we can, right, we have some zooming controls. And then I don't know what these keys were for. I guess we thought that zooming was more important than Whatever. Let's not worry too much about what the exact camera controls are. That's fine. Okay. So, now that we have kind of this stuff kind of stubbed in, we got this iMow temp, right? We're going to make this. We're going to put this back in here. And we decided that it's going to take a pointer to Mow pointer, and this is going to be called Mow pointer Mow. I don't know. So, you know, define int32, and then define Mow as struct Mow temp AAC 2020 Mow temp. And then down here we're going to say, you know, undef int32 and undef Mow, right? Okay, cool. So we got this mouse input handler thing, and we got to do some stuff in here. Now, why is it returning a an int32 here? Is that just because this returns an int32, like some type of status code? Sure, why not? Return 0. And then we got to figure out where this needs to be called. So in our function file or somewhere, we have like some type of handle input, right? Handle input. And we got all this stuff here. I'm just going to make another function for this. I'm just going to say AAC 2020 handle input mouse. Pass down that U32. And make sure there's not any other handle input. So I'm naming it that way specifically so when we look for handle input, we can also see this very easily, right? Input handler. So we're just going to call this U32, right? Handle input mouse takes a U32 called U32, right? Keep that same kind of structure, right? And that in here, we're going to create a Mow type. So we're going to take this, we're going to steal this, and we're going to put it over here, right? So AAC 2020 Mow temp. Is that legal? We'll find out, won't we? Actually, no, we're not going to do that because we need a, you know, if def or not if def, but like an include like this. So like, you know, if include Mowbox Mow temp. Okay. If Mow temp does not exist yet, then no input handler, no right? So if we're at this part of the if we're not at this part of the library chain, there should be no kind of function that takes kind of mouse input, right? So if it does exist though, then we'll define this thing, right? We'll take this and we'll throw it in here, right? And then we'll undef it down here, right? And this is kind of awkward, but that's how we're gonna roll with it. So struct AAC 2020 mouse temporary container. And we're gonna say, you know, mao equals 0 initialized, right? And then mao dot all these things. So let's go look at this, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got these things. And that's how they're spaced out, right? And what we can do here is we can just steal these and assign them to each other, and we're good to go. So we can say this equals all of this, right? And then we can just change these names. Right, so these are the names for this, right? So we can take this here, and everything's in the same order, so we can just kind of nicely go, right? And we could actually do this, right? So we know that these are these names up here at the beginning, right? So we can just paste this, right? Keep that part, right? Because the mapping should be exactly like that, right? So mao x, click, up, down. Maybe we don't want to call it mao. We want to call it like click up. Maybe want to call it loc for location. I think would make more sense, right? Because this is mouse x, mouse y, so location, right? Location mx, location mouse x. Or you could say pixel mx, right? So we want to know what pixel we're over, right? So maybe calling it pixmx would make more sense, right? Because this mao thing here, I don't like that. Mouse pixel mx or mouse x is much better, I think. So let's do that. Okay, then after that, we just got to clean up these equal signs and say, there, we got all this, we got it all in a container, right? We got this temporary container going. And then we can call this thing, right? So this mouse input, right? So let's just call, I don't want any more f macros, so, you know, if AAC 2020 include PAINT5D, right? If we have that, let's kind of make it let's keep the same kind of hashtaggy line, because it's also kind of one of these macro-y things. But let's also kind of like make it like lessen the line weight, right? And then in here we're gonna say, hey, you know what? Mouse input function. We want to just take the address of mao, right? So the address of mao, we want to shove that in there and call it, right? And then we want to also go like that, and there we go. So we have this kind of less dense kind of line here. So mouse input, right? I just don't feel like making those F macros. I think it's annoying. If we get a whole bunch of mouse input things, then we'll worry about that. I'm still here. I can't use my mouse/type because of occasional 99% CPU usage. You need to hijack people's computers with some type of render farm software. Yeah. Like the person who, you know, there's like a person who, they were like a janitor in some type of school, and they put rendering farm software on all the computers in the school, and they made it. It wasn't render farm software. It was Bitcoin miner software, but one of those idle miners, right? So you got these computers in the school that are on when everyone's gone, and they put like Bitcoin miner software in. And I think they made out like abandoned, if I recall. So, man, you got to take advantage of your situation. I am not a janitor in a school, so it's like, I could have not done that. But if I was there, I would have done it. Screw it. Fire me. I'm already rich. Ha! I really do plan on getting a Threadripper. Yeah, I don't know what a Threadripper is, but I assume that it's, what I'm talking about, right? So, yeah, mouse input. Okay, so we got this kind of function stubbed in here. We're going to do a no-op with the mouse input right now. Or actually, no. If mao dot cx for so is mouse down. If the mouse is down, then that's basically a click coordinate. We don't really need a click X, click Y. We have more variables than we really need. But yeah, if the mouse is down, right, we got, is mouse down, is mouse up. Well, is it a click, right? Is it the first time the mouse was down, right? What am I eating? I had some chicken wings in a bag. Can you actually see my monitor? Yeah, I can kind of see my workstation. I don't know if you can see the food in the corner, but it's a whole, I made some chicken wings and they're in a plastic bag over here. I don't know if you saw me eating that or not, but I may have been eating that. And then I have some coffee. Yeah, this bag. This thing right here. Yeah, that is a bag of chicken wings. Yes. So I don't know if I like how I'm doing this stuff over here, but let's just get this working, right? So, if the mouse is down, we want to do our click X, click Y. It would make more sense not to use the click X, click Y. Are we even using this? Let's see what we're actually using in here, and see if we want to, like, get rid of some of this nonsense. Because I'm going to guess that a lot of this is not used. Find in files, find all. Let's see what we got here. Click X. So this is where we are kind of figuring out. Well, you know what? I didn't go to sleep yet. It's still Monday as far as I'm concerned. Yeah. Yeah, it is still, for the record, still Monday as far as I am concerned. Yes. Well, I haven't gone to sleep yet. It's still Monday. If it comes Friday and I'm still up, still Monday. Yeah, same here, right? Monday is always all-nighter day. So we got a whole bunch of code here for mouse move and blah 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 and this stupid. Click X. D2. What is D2? Distance squared less than what? Threshold squared. What the hell does this have to do with clicking? Minimum click distance. Oh, I see. We're detecting a click by, if the mouse goes up and the mouse goes down, the click isn't based on time. The click is based on, if we, like, hold down and we go up, but we haven't moved, that's a click. So, okay, I see. So... Sure, why not? Else, we're gonna make another variable here, though. For clicking. AAC 2020, iMauox, and we have mouse down, mouse up, and we're gonna have a mouse click. MC for mouse click. And if we're not at that threshold, then we're not clicking. So mouse click is 0. And then over here, in this case, the mouse click is true, right? Right? And then over here, we're going to put that in here. So mao.iss for is mc equals this thing here. Right? And also we need some semicolons here. So MD, MU, and MC spells duck. Sure, why not? For mouse down, mouse up, and mouse click. And then we also want to set that in our iMouse box. So in iMouse box, we will also want to say, you know what? C, so mouse is clicking. So is the mouse down, is the mouse up, or is the mouse clicking, right? So have flags for that, because by the time we pass this object into our input handler, I don't want to have to calculate that kind of stuff, right? And also, if this object gets passed into multiple handlers, you don't want those handlers to have to calculate, okay, based on all these variables, are we clicking? Based on all these variables, are we dragging, right? Based on all these variables, are we doing this? Are we doing that, right? We want to calculate those ahead of time and store them in the object so that we don't have to recompute that for every single handler that's taking this mouse state object. So, yeah, that looks good there. And then this needs to be added. So U32 is mouse clicking, right? And then, so that is, you know, MC, mouse is clicking. Mouse clicking. iMau box, MC. Okay, cool. So the code for handling that, for calculating that looks... I don't even want to reason about it too much. I just hope that it works correctly. Because I don't want to think about it. I just want to handle the state. I don't want to worry about computing the state right now. So we're gonna assume that all this crazy logic for the mouse clicking stuff is correct, and then all-nighter day. Yeah, that is kind of a weird way to think of it, but yeah, I guess that is how I think I do it, right? So all-nighter day. Okay, yeah, so in our mouse input, we're just going to check for mouse clicking, right? Is mouse clicking? Right? And, if the mouse is clicking, then we just want to... We have the click X, click Y coordinates. Crap. If we click... No, if we click, we just gotta look at what's in the brush and load it in there and do our thing, right? Yeah. So, so we need to toggle a tile, right? We need to toggle a tile. Toggle tile at mouse position. Actually, you know what? I kind of like doing this. Let's keep that up. I kind of change my mind on the line hierarchies sometimes. No, let's not do that. Let's keep a nice line. Toggle tile at mouse position. I'm getting way too artsy here. That's what you get for going to art school. Okay, so toggle tile at mouse position, mouse click, and yeah, so this is where we want to toggle the mouse stuff. Where is that, though? I have no clue where that code is. So we're going to hope that it's in one... If we keep all of our function code in one file, it'll make it easier to do this. So even though I am very tempted, like, this PAINT5D system file is getting, like, out of control. However, P5D toggle tile. Where are we? Oh, toggle tile. What is toggle tile doing here? BX. So BX is like hard-coded here. What the hell? Oh, this is a trap value. That's what that is. Brush X. So brush X somewhere here is... Where are you? Brush X. Uh-huh. Oh, brush... Taudipo get. So brush X... We need to actually get the brush location. I see. So we're getting the brush location, and toggle tile is a state-based function, right? So yeah, we're getting the brush X, brush Y. Okay, cool. I see what's going on here. So we need to steal this code, copy that, and we're going to call this toggle tile. Yes, we are. Okay, I see. We're getting closer. We're getting closer. This is good. I'm excited. Okay, so this toggle tile function, is there a public version of this? Because I see it's private. Do we have a public version? I don't think we do. Oh, so right now we have a key for a toggle tile. Okay, so things might get a little bit weird. Let's just stick with let's stick with the mouse controls for this for now, even though... So this code right here, we want a put function, right? So instead of get, we're going to put. And this is also going to be a put. And so we're going to remove the ands around it. And those are also unused variables still. And then we're going to call the toggle tile function, right? So, right? So that's kind of a weird way to do it, but that's the way it's been set. So that means that, you know, this bx equals, bx right now equals the clickx. So mao.clickx, and then we have a by, right? So by equals this. So int32 bx by equals this clickx clicky bx by. And then we have, you know, int32 unused 1, 2, and 3. Unused 1, unused 2, unused 3. Okay, that's some crazy stuff. Will that actually work? No. Because we have to map it. We gotta map it. We have to map that click position. So we have to go into our fragment shader code, right? Because we're going to hijack the fragment shader code function here, right? We have somewhere in here, where are you being used here? So the fic thing, this fic thing, a fragment integer coord, we, to get the canvas user view coordinate right here, ivec2, we use this. Yeah, so we're going to go over here in PAINT5D and so canvas user view. So ivec2 cov canvas user view. Okay. See file paint5d.data. I think in paint5d.data, see diagram. So in paint5d data, let's make sure that is correct. So we go open up paint5d data. Yeah, we got some nice diagrams, and canvas user view is right here. This is the canvas user view. So hashtag. So the diagram is hashtag canvas user view, and it's in paint5d.data. And so if you want to know what this canvas, what I mean by canvas user view, you can go into that diagram there. So canvas user view, right? So canvas user view, we're going to use this fragment coordinate thing, and the fic thing is going to be, let's use more variables rather than less. So we're going to say, you know, ivec2 fic fragment integer coordinate, and you know, fic.x equals this mouse click coordinate, right? And then fic.y equals the mouse click y coordinate. And it's more variables than we actually need, but the idea is that by doing this, we can kind of we can conceptualize what the hell is going on a little bit easier, right? Oh, also this needs a int-vec input anyways, rather than these separate things anyways, so we're good there. Click x, click y for fic x, fic y, right? So the mouse position maps to a fragment on the screen, and then we can map that fragment on screen to an actual canvas user view coordinate. Now this canvas user view coordinate, the brush x, brush y depends on the exponent level. So we're not out of the woods yet, but we're getting closer. So we want to get so let's close some of this and start to focus in on this. So let's put paint5d.f over here. Go look for canvas user view, cov. That's not going to get us where we want. Fic. Let's go look for fic. Fic. Fragment integer coordinate. Yes. That's what we're looking at. And let's close this window code here. Let's close this. Let's close this. We already know about this. That's fine. But we want to look at the PAINT5D. Do we want to look at more PAINT5D functions? Crap. We might actually want to open up PAINT5D in 2 files, which is kind of like... Actually, yeah, that's what we want to do. Make sure that these files are synced up, and we want to... we want to convert the... we want to convert to... I don't know, we need to convert to something. I don't know what it is, though. A tile exponent to that. Tile exponent to bipsip. Bipsip, bitmap, partition, span, and pixels. There might be a conversion function somewhere in here that we can already use. So, oh, also my, yeah, I'm gonna get an Ethernet cord to fix this. So tile exponent to maximum coordinates. Tile exponent to diag pix to this. There's a lot of math here where astapix. What's astapix? Glock pix to pane pix. So we got, global pixels to the paint pixels. So, pane pix to Glock pix. Glock pix to Covey pix. Ooh, we're getting closer here. Because then we have Covey pix to Glock pix. So, Covey pix convert to. So let's look for Covey pix convert to global pixels. To global pixels. So, we take tile exponent, tile layer, and that gives us the global TX, global. So we actually want something that, we want a conversion from we want VP0 to Covey pix. We want something like VP0 we call it VP0 frag, right? So we want to take a fragment coordinate inside of VP0, right? and we want to convert it to Covey pics, right? Or Covey pics, canvas user view pics. Already wrong again. No, because Covey pics is kind of like, goddamn. No, we already have Covey pics. We want to Covey pics. We want to convert it to not global pics, right? What can we convert Glock pics to? We want to convert it to paint pics, kind of, right? Like if we really think about it. I'm going to go to the bathroom soon. So yeah, we want to convert these Covey pics, if we want to convert it to, I think paint pics, right? Because paint pics is the tile quadrant, the tile exponent, the tile layer. And then it also has the local TX and local TY, which is the brush location, right? So paint pics would be the brush pixels, right? So we really want something that converts Covey pics to paint pics. Right? And we're going to have to write some more test code for this. But yeah, so Glock pics to paint pics. If we look at that, so let's not even think about so and if we're doing paint pixels, can that always map back to the canvas user view pixels? I guess it could, technically. Let's go look at this for a second. We actually want to take the cov and convert to, we really don't want to get all that crazy. We just want to convert it to the brush, right? We want to take the canvas user view location and convert it to the brush location. I feel like we had a function for this somewhere. Let's find all for a second. Let's go find all and see what we got here. To global pixels. To cov bits. Uh-huh. So, cov bits gives me everything on a certain layer. So this thing might actually have the internals of this function. Like, I don't want to duplicate code, right? So I'm thinking that this function here, I'm thinking this function here may have the... Where are you? Unit test code notes. Oh, it's in here? It's in the fragment shader code. Canvas user view IX. The layer dex, the ladex, and the osdex gets the bits. So this function may actually have the logic for getting the location, right? So yeah, so we got all this math here. Local tile TX, local tile TY, right? This logic right here. Bam, bam, you right there. No squash tile X. Yeah, so this right here, the tile value, right? We're getting the tile value right here. And I'm going to guess that we're looping through this code, right? I'm going to guess that we're going loop, 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 loop. Yeah. And so this code right here is covey picks to... so we want something like this, but we want... want something like, want to convert canvas user view pixels to brush picks, I guess. Four, five, brush pixels, right? Right, so we want something like this. And in order for that to work, we want to... We're already in here, so we can't really do that, can we? Because this is Paint. We're inside PAINT5D, and the fragment shader code stuff comes after. So we'll have to call this AAC 2020 PAINT5D. Canvas user view pixels to brush pixels. And for this logic to work, we need to... Oh boy. We need, right, we need canvas user view. And then we need, you know, How about int vec2 brush pixels. We could say, you know, brush pixels is returned from here. Brush pix. And we need the canvas user view. And then we need the tile exponent. We just need the tile size exponent, right? So the canvas user view location, right, combined with the tile exponent should be all we need to do this, right? So tile size exponent. So we just need these two things here. And once we have that, we have this brush. They have these brush pixels, right? And once we have that, this is an int vec2, so really we don't need mouse click X, mouse click Y is not this. Let's not do it that way. Let's do it as, you know, brush X and BX as an output. And BY. Brush Y is also an output param, right? And we have this here. Why do we have two of these? Oh, because we initially were going to call it differently. So yeah, we got this kind of thing. We need the canvas user view, and then we need to... is it really a brush pixel, though? Well, it gets a BX, BY, right? So, I guess technically that's what we could call it, right? Brush pixel. Okay. And brush X, brush Y. Right, we get them here. And then we put them in here, right? Alright, so we get them from here, we put them in there. That's as simple as it gets to be. So in PAINT5D, right, we got this mouse handler function, and it's like, I don't know where I want to put this thing. Let's close this. Do you want to reload it? Yes. So this fragment shader code is kind of going to help us a bit. Let's steal this for a second and say, hey, this is how we want to do it. This is how we want to roll with it, right? So we're going to... so we map the fragment coordinate to the canvas user view, right? We reuse this to get the canvas user view location. And then we want to know what we're clicking on. So it's going to be kind of written exactly like this. But we're going to just we can just steal a lot of this code and we can get it working. Yeah. Because this txty, that's what we want to calculate. So let's just copy this and figure out where we want to put this. So this is the mouse input handler. Default design, tile, fill, whatever the heck, we don't care. Tau uniform, controller functions, no. Originally wired, not, what is this stuff? Brush state. Put using brush. Logging. Helper functions. Helper functions assert. Let's look for C2. Is there not a convert to kind of functions in here? Yeah, I thought we had some type of convert to functions. PAINT5D, okay, yeah, we'll throw this in here. It is a conversion function. Void, and I don't remember exactly what it takes, but we'll remember, we'll figure it out as we go here. So let's just steal this kind of signature here, right? Let's steal this. Canvas user view. It's an integer vec. Tile exponent is unsigned, I think. It should be. Bx and by are integers. So let's just go over here. Why don't we just mock it out over here and just say, you know, this right here, that canvas user view pixels, why not, cov ix and cov iy. Yeah, let's do that. X chord. This is right here. Cov ix, cov iy. And, you know, just make it easier to follow, right? Int 32 cov ix, int 32 cov iy, right? And then right before we call this, we can just say, you know, I know it makes things more verbose, but that way we can understand the connection between certain things a little bit better. So this x, this y, this cov thing, cov ix, cov iy. So this is the non-container version of this variable, right? So this is covey pix.x, covey pic, right? That's essentially what that is, right? This is y coordinate. Okay, cov ix, cov iy. So we got 1, 2, 3, 4, 5 parameters here. And so we're thinking, you know, this is an int 32, and also I should check my Discord because I hear it beeping. Must be another group. Is it almost 5? Yeah, so Don Ho might be programming by now. So let's go look for tile exponent. Because tile exponent should probably be like a UO8, if I recall. In our code. Yeah, tile exponent is a 8-bit integer. Hey, how's it going? Whoa, holy crap. Where'd everybody come from? Tech demo, tech demo. Let's do a tech demo. I see people, let's do a tech demo, right? Yeah, let's get a tech demo going, since I see some people. I'm in the middle of some stuff, so let me brush up this stuff and get it compiling, because I'm, like, kind of all over the place. But let me comment out some stuff and get this kind of working. So let me just comment this out for now. And then let me go find where that's being called from. That's being called from over here. And this function here is a complete disaster right now. So let's comment this out really quick, and we just want to get something working so we can do a tech demo for you, right? Because most of the time it's not going to be interesting, right? And the thing is how do you know you want to watch my code unless you can see something awesome, right? Like when I look at, like, I do not even read tutorial code unless I see the end result, right? Because you don't want to waste time on stuff unless you know it's interesting, right? So let's try to get this running. It's gonna be, we're gonna have to fix some stuff because, you know, I mean, Merc and Never just watched me write paragraphs and play random jam games. Hold on, let me zoom out here. Okay, let's give you the first set of tech demos. We'll get this working, but before we get that working, let's give you the first set of tech demos. I actually have more tech demos than that. I have tech demos upon tech demos. So, first thing I'm going to do is give you folks this, and I'm going to go to that link right now. So, I'm going to go to that link and explain what the heck I'm up to. So, let's open this up. Come on, come on, come on, come on. Internet access, work. I'm going to close Discord, get some better bandwidth, because I know my bandwidth sucks right now. What's my bitrate? My bitrate isn't too bad. Okay, so the Heroku server this is on sometimes takes some time to start up when it is the first time, right? Heroku, it's free, right? The servers hibernate. Okay, so I made this bomb game, right? And it's like Bomberman, except you have vertical explosions, horizontal explosions, and four-way explosions. It depends on what kind of bomb it is. So the bomb with a horizontal dash in it explodes horizontally. The bomb with the vertical dash in it explodes vertically, etc., right? And then there's also an instant kill bomb. The instant kill bomb is a skull, right? So all of these bombs are like proximity mines. So as you're walking by, if you touch one of these bombs, it's not going to kill you. It's just going to light up. So you can, like, walk by it, and you'll be fine. But then there's a timer that gets set, and it explodes. So let's go look into, like, our demos of, like, a GIF folder for this. So AA1 GIFs folder. Let's go open that up. And let's go look at some GIFs here. And this is a old game. I'm rewriting the engine for this, right? So we got these things called flame pistons, and the flame pistons emit sparks. They used to emit flames, right? That's why they're called flame pistons. But when a bomb interacts with a smashing force or a heat source, the bomb will instantly detonate. So you see these pillars right here. Those pillars, if they're not supported, they will fall, right? So when the floor gets blown out right here, this vine stuff, when it gets blown out, then the pillar falls, the pillar hits these bombs, chain reacts, these pillars fall, hit these bombs, chain reacts, and etc., etc. So unlike Bomberman, there's a slight delay between when one bomb explodes another bomb so that we can get this awesome chain reaction effect going, right? I coded the lighting engine. All materials have different properties. So the blue vent tiles you're seeing allow explosions to pass through them, but the vent tiles themselves do not break, right? So the idea is that it's an indestructible tile that allows the flames to pass through. And then there's other indestructible tiles that block flames, right? And so you can get a whole bunch of interesting combinations to make really crazy puzzles, right? So we have like a lot of stuff. So here's an example, right? I pass through these bombs right over here, and nothing happens to me. I hit these bombs, nothing happens to me, but after a while, they kind of explode, right? So let's find something more interesting really quick. I'm not going to go over all of this, but okay, right here, right? These bombs are proximity mines, so after a while, they explode, they chain react. So I have to touch them, and then I have to dodge them before they get me, right? So touch the bombs, wait for them to explode, and then dodge over the flames, right? So there's like a lot of stuff. So these small bombs are small four-way explosions. So if you make a checker pattern, they don't chain react, and they just create this minefield where you can't revisit a place that you were currently at within a short amount of time, right? So we got like a lot of stuff, like, right, this looks like, oh, it looks easy, but then, oh god, the floor explodes, and now you have to carefully jump, right? Or else you go into this a bottomless pit with a bottom. That's what I call this, right? It's a bottomless pit with a bottom. Or if you break one of these light fixtures, if you break a light fixture up there, the spark falls and it hits the bombs and makes them explode. So yeah, a lot of cool stuff, right? Spark hits that, boom, right? So a lot of cool stuff. I'm not going to show you all that, but you get the idea of what I'm kind of working towards, I hope. And let's go back to the chat and make sure I'm not missing anything here. So let's get into some more of the tech, right? So this is very like retro pixely game, but I don't want to make a retro pixely game. I want to make another game like this with these awesome chain reactions, but I want to make it with some really awesome auto tile tech. So this is a proof of concept, right? So this is auto tiling, but we are using shader code, right? So we can change the material to something else, right? So we can make this material, set that material if we want, right? And we can use this material if we want, so we can set these kind of tiles, right? And I believe we have an eraser tool, right? So we can start to erase stuff if we want. And the reason why I'm going so crazy with auto tiling is because if we want to make a really nice, fully destructible environment, we need to make sure that everything is drawn with auto tiles. Because otherwise, if you destroy part of the environment and you just subtract a tile out of the level data, it's just going to look like somebody went in there with like old school MS Paint and just erased some pixels in your level, and it's going to look like crap. So we don't want that. So the nice thing about this kind of tech is that since we're going to use kind of shader code to render our tiles, we can zoom in on this stuff, right? We can zoom in and just go crazy, right? So we can zoom in and go bam, bam, right? Look at all that awesome, beautiful detail. Even though we're zoomed in, right? We can't get this kind of stuff with auto tiles that are based with pixels. So if we base our auto tiles with shader code, we get this awesome stuff. But wait, there's more. I'm not just trying to make awesome fractally shaders that let you zoom into them like this. I also want the shader code to be fractal based. So with the auto tile, I know I'm saying auto tile, does everyone know what an auto tile is, right? Do you know what an auto tile is? Do I need to explain what an auto tile is, or are you all like, do you all know kind of that basics? Not particularly? All right, yeah, okay, I will explain to you. So let me find a video for you guys, or guys or gals, or whoever you people are. Let me give you, so let me just find Auto Tiles Explain. Let me see if I can find this for you. Okay, yeah, so that is the video. So I'm just going to look at this really quick. So, an auto tile...
Then you can stick around.
Let's kind of go back a little bit here. So...
The video right now, but if this is what you're looking for, then you can click over. The tiles will automatically...
Okay, so an auto tile is also known as a rule tile. It is a set of 16 subtiles. It's a set of 16 tile graphics that act as one material. And the advantage of it is you can just have your brush set to this one material, and the rule tiles or auto tiles will self-select the correct subtile graphic so that everything latches together nicely. You see this nice black border here, right? This is a different, this subtile is different from this subtile, right? But you only had to use this one brush to just set these here. You didn't have to manually select all the tiles to make the level kind of latch together properly, right? So let me, you know, if you want to look at that on your own at another time, I can throw that in there for you. Yeah, tile sets, right? So Godot is greater than Unity. Oh, I know. Unreal is greater than Unity. I see. What do you call it? Holy Wars. Game engine. Holy Wars. Excellent. I'm gonna go with Cool King Bro. Actually, MS Paint is better than Photoshop. MS Paint is actually better than Paint.net as far as I'm concerned, because at some point your software is done, right? But somebody who's been working on the same piece of software for 10 years, they never want to be done with it. And it's like, so they keep on adding more and more crap. And so, like, you know, a hammer can only be so evolved until it's the perfect hammer and you don't need any more improvement. And that's kind of like how I think of it. Maybe I'm just crazy. I know auto tiling. I've made those before. Awesome, awesome. So you know what I'm talking about. Never write live. Never. How do you pronounce that? Never write live. Never write live. Never write live. Never mess with Unreal much myself, so I can't talk much. Okay, cool. So I'm up to date here. Z, did you get who sent these people my way? Axe. Okay. Well, thank you, Axe. Okay. So anyways, back to tech demos. I just call them never. Yeah, that's probably the best way to go with that, right? So I don't even have to think about it. Like, people call me Kanji, so, you ain't taking credit? Yeah, okay, that's fine. I mean, I saw it was from somebody else, so, never, never right. Yahoo, somebody didn't say Axe. Cool King Bro, I'm using Unreal, and I really don't like it much for 2D. That's how I pronounce. That's how you pronounce it. Okay, I will review the logs, because I'm not going to remember all this stuff. Anyways, tech demo stuff. Let's go back to tech demos. Did I send this? Did I put this in chat? I don't remember if I did, so just making sure that that is in the chat for you if you want to look at that. And, okay, so this is an old game I made. We're not going to look at that. So, look at here. We got a engine I made, an action script long ago, and it's a tile engine with multiple layers, and certain layers will blend together and fuse together to get, like, really interesting details. And I want to take 2D graphics to more advanced levels. Like, some people think, okay, after 2D, to get better graphics than 2D, you have to move on to 3D, and I think that's a complete lie. I think 2D and 3D graphics are parallel evolutionary chains, right? Like, if you want to get into evolution, technically a dolphin is just as evolved as a human, right? We've all been on, right? The first cell never died, right? The first cell that created life on Earth never died, right? We are all somehow descendant from that first cell. So the dolphin is extended from that first cell, and so are humans, right? So we're both equally evolved, and so I think 2D and 3D technology are kind of like that, right? You can keep on evolving 2D, and you can keep on evolving 3D. It's not 2D and then 3D. It's 2D and 3D are parallel evolutionary chains of graphical technology. Okay, so I got a little philosophical. But anyways, so we got this one tile map I made, and we applied 3 different rendering settings. So when you're an indie artist, you want to leverage your data. You want to leverage your art assets, because you don't have as much artist brain power or brain hours when you don't have as big of a team, right? So we take this one asset, and we can render it with this sunset rendering mode, or we can render it with this starry night rendering mode, and the rendering mode makes the asset look sufficiently different enough that I don't think somebody looking at this and looking at this are going to be like, man, they're just being lazy and reusing assets, right? This is so visually different from this, even though it's a few clicks just to change the rendering settings, right? It's not that much effort, but the amount of change is so drastic that you can multiply your effort by 3, right? So you can make this once, and then you can apply these different rendering settings to it, right? So I do want to add this tech, right? So I want to use this tech, and I want to use this tech, and I want to use this physics tech, and I want to put them all into a final engine design, right? Also, I want some crazy lighting. So this lighting engine right here was in done in ActionScript. A lot of people think this game was done in Unity, but it was actually done in ActionScript. Now this lighting mode made it really hard to play the game because it's like, ooh, shiny, right? It gets people's attention, but it's way too overblown to be able to focus on the mechanics of the game. So my game designer made me tone it down. I think the next time I do this, I'm going to keep a like sparkle mode in the game engine so that you can turn it on or off when you want to have fun. Like, let's say you've already played the game and now you just want like party confetti disco mode or something like that. Like something like that, you know? Something where I can still show off the lighting engine to its full extent, because I think this really shows off the lighting engine to its full extent, but it makes the game a little bit hard to play when the lighting is so overblown and just stroby and crazy and all that stuff. This is the preloader for that game I made. This is a old prototype for creating an auto tile set editor. And I'm actually going to show you a tech demo of the current auto tile set editor, but I need to get the code compiling, so I gotta frantically patch things up so I can compile it for you. And then over here, this is not going into the engine, but it's still fun, so I'm going to show you anyways. So this is a snowflake maker. So it's based on a quad tree, but the quad trees are shaped like triangles. So, right, because the Triforce, if you think about a Triforce, it is 4 triangles, right? Because there's that inner triangle. 3 triangles on the outside and 1 in the middle, right? So it's a quad tree. So we can click anywhere and we can start subdividing the quad tree, and it'll pick a random color, and we can make like a little design, right? So we can make a little design. Clickety-click, clickety-click, clickety-click. And then also we can click and drag, right? So we can click and drag. So what I like to do is first rough out like a general pattern, and then you can just click and drag to put in some like fine details, right? And then you can kind of get some really cool looking stuff, right? And then also if you just want to be crazy, you can just click drag really fast and just right, and just get like a really nice base pattern. And then if you click drag slower, right, woo, this is fun stuff, man. So this was done in Canvas. I'm not going to go over the details of how I did this just because I want to get to the show you all the other cool stuff. But actually, if you want an explanation, I'll give you an explanation. Anyone want an explanation? Your brain can't handle it. Also, today is technically yesterday was coffee day, Monday. Coffee is one hell of a drug when you only drink it once a week. So I am I don't want to get too whatever. I'm just gonna say it because I don't think it's cancelable material. I know people who have done cocaine. I know people who have done meth. I have not, but from the colorful people that I have associated with, I'm pretty sure that because my caffeine consumption is once a week, that it's basically like an illegal drug. So just never go to bed, and you never need to stop drinking coffee. Yeah, maybe. But you build up a tolerance if you drink coffee too much. So that's why I drink it once a week. Anyways, let's close this for a second. And stuff. I used to do rigging in 3D. I went to a school called DigiPen. I was in the art program, but I really like programming. So when I found out you could write code to make rigs for things, I'm like, man, that's what I want to do. That's what I want to get paid to do. And so I made a whole bunch of cool like Mac script.
This is my retract.
Oh god, made a whole bunch of cool Mac script kind of stuff. To like make like this little tool that you take this one shape and you just use it to put it on a stretchy kind of like I guess you call it kind of stretch. I don't know. Let's not go over that. It's been a while. Other stuff. Oh, this is kind of cool. This thing. Woo! Look at that shader stuff. This is some stuff. I did this in Unreal. This is Unreal right here. So take some shader code. And it was very hard to... I mean, Unreal is probably a little bit better now, but it is really hard to get this code working in Unreal, right? Because there's some shader code I stole off of shadertoy.com, and I wanted to get it working on a cube because I thought it would be really awesome. And I really like how in Unreal, if a color value is outside of the normalized 0 to 1 range, the color will start to emit light. And I think that term is called overbright, and it is badass. So Unreal, I don't know about Unity, but Unreal gets a lot of bonus points for how it does shader logic, because this is badass. Look at all that sparkly stuff. So this, I made like a little fireworks system. This is also Unreal. I was trying to get a job at Studio Wildcard a while ago, but then when I tried to use their SDK, I'm like, I don't have enough RAM on my computer to use this SDK. And then I'm like, do I really want to spend $1,000 for the opportunity at a job? Because they really wanted to see me do stuff in their SDK before they considered hiring me, even though I already did this cool stuff for them and made them a little write-up. Like, I made the little write-up, like, here's my write-up for that potential employer. So I gave them a write-up, and I showed them, here's some screenshots, here's my workflow for how I made this stuff work, right? Here's the whole workflow, right? Here's the workflow. Oh yeah, and then I also made this little thing, this other thing in Unreal as well. Right, and I wrote the C code and all that stuff, the C++ code. Come on, load. Come on, load. Let's just wait for that. You can create black lights in a similar way. Really? Oh, so like, pixel values in the negative. Or... Yeah, right? Negative, right? It would be, instead of 0 to 1, right? Instead of outside the 0 to 1 in the positive range, you're in the negative range, and you make a black light. That's pretty cool. My Wi-Fi is dying. I might leave soon. Yeah, no problem. Yeah, like, how do I comment? How do I reply to this? Can I click? Can I just go at never... No. Yeah. I know you can see this, but, you know... I like to, yeah, no problem. Yeah, if you gotta leave, you gotta leave. Anyways, so that is my technical demos page. If you missed the URL, I can throw that in for you one more time, and then we're gonna get on to the actual code that I'm working on right now, because I actually made some really good progress today. So I just need to fix some stuff up. So I need to find. Let's move this over to this side for a second. So, what do we got here? Handle mouse input unused parameter, because I have very strict compilation settings. Let's copy this, and this is in the main function file. Is it in the main function file? Handle input mouse? It better be, because, yeah, it's in the main function file. So let's go file, open, go over here, handle input mouse, U32. We're not going to actually use this value. We're just going to say if U32 and then reserved for future use. Right, so we got to do a little no-op right here because my compilation settings are strict. We're going to return a uint32 from here. So right now we're just going to return 0x. We're just going to return 0 for now. And then we just want to get this running, right? So we're not going to worry too much. We just want to get this running because it got something cool for you. And then I'm going to explain, I'm going to elaborate more on auto tiles after I get this in here for you. So let's hope this doesn't explode on me. So let's go P for pattern, and let's go through here. Okay, cool. So we got this little pattern thing. Okay, let's go full screen here. And so I got the, it's probably not too awesome to you, but it took me a while to get the zoom controls here working. So I got the zoom, and then I got the, got this going here. And this might not look that interesting, but let me explain what you're looking at, and maybe it'll make it more interesting. So this is an auto tile set, right? I'm talking about auto tiles, and usually there are 16 tiles to an auto tile set, but my system is going to use 4 tiles, right? So it's going to take the top left corner, top right corner, bottom right corner, and bottom left corner. You're going to design tiles, only 4 tiles, and then the system is going to generate the missing 12 tiles to create a full 16 sub-tile auto tile set. And you might notice, like, oh, this looks all glowy and crazy, and what's up with that, right? So let me explain how this renders, because yeah, see you around, yeah. I'd like to learn some of this soon. Yeah, I can explain more of how this system works. So you see this here. There's a very intricate data structure for how this is getting rendered. So let's go into our assets folder. So lib assets, and show you what I'm actually rendering. Like what is being rendered versus... so this is the actual data that's being rendered. So let's go over... so this thing here is being rendered from this. So this is actually what's in texture memory, and this is what you're seeing. So this pattern here in texture memory actually stores 16 of these designs, because this is only rendered using 2 bits of every single pixel. So the pixels over in this quadrant here are rendering this design. The pixels over in this quadrant over here are rendering this design in this quadrant. The pixels over here in this quadrant are rendering this design in this quadrant. And the pixels over here in this quadrant are rendering this design. How are we getting this design? Well, this design is pretty much being rendered using the most significant bits of the red pixels. So if you look here, you can kind of see this stereoscopic kind of like old school 3D glasses kind of thing going on here. So they got this blue layer and we got this red layer, and what you're seeing here is only taking 2 bits from that red channel. So if you can kind of visualize what we're seeing in terms, if you try to focus on only the red and don't look at the blue, then you can kind of see, oh, look, there's a completely symmetrical design here, a completely symmetrical design here. All these designs are completely symmetrical here in this top left quadrant, and that's why this is completely symmetrical. But when we look over here with the red here and the red here and the red here, it's basically the same pattern cut and pasted and rotated, right? So same pattern, then rotate 90 degrees, paste it here, rotate it another 90 degrees, paste it here. That's because I was just getting tired of creating the test data, so I'm just like, screw it, just cut, paste, rotate, get it working, right? So that's kind of cool. So why this crazy? Why do I even have this crazy layout for a second? Let me explain why I have this crazy layout. Because I want something where we can have different pixel sizes or different tile sizes. So so right here, this section of memory is 128 by 128, right? Is that a lie? That's a lie. This is 256 by 256. I'm sorry. This is... Oh, another lie. Okay, this whole quadrant is... Sorry. Okay, the whole memory block here is 512 by 512. This quadrant here is 256 by 256. And one of these little sub-quadrants right here is 128 by 128. So this is the... So if you're familiar with the MIP map, I have a MIP map-like data structure. And basically, this is layer 1, this is layer 2, and this is layer 3 of the smallest tile size. So you can paint on this layer with a very small tile size. You can paint on this layer with a very small tile size, and on this layer. Right? Now, if you want to change your brush settings to use a bigger tile size, then the data for that is over here. So these tiles are twice the size, and because they're twice the size, they're twice as large, you need half as many of them to cover the entire screen, right? And then down here, these tiles are twice the size of these tiles, so you need half as many of them to cover the entire screen. And eventually you get down here and there's just 1 pixel, right? And so 1 pixel is storing 1 tile value, and that 1 tile is so big that you just need 1 of them because it's so big it covers the entire screen, right? So it's kind of hard, it's kind of confusing sometimes to think about this because the bigger memory blocks here, these bigger memory blocks store smaller tiles, and these smaller memory blocks store larger tiles. Sometimes it's hard to wrap your mind around that, but that's how it goes. So what you're looking at is a very complex tile map, right? This is basically a tile map, right? So I know a lot of people, when they do tile maps, they think of like, you know, something like this, right? Where it's like, you have a comma separated thing, right? You have a comma separated file, and you do something like this, right? You have like X's, and then maybe you have O's, right? and then you have some more X's, right? And you do something like this. And that's all good and whatnot. But I find that it's easier to where this kind of concept comes from is that I find it easier to store your tile maps in PNG files, because then you get the advantage of color coding and you get the advantage of being able to use MS Paint to make your files, right? So let's kind of make a little tile map here for a second to explain another concept. So there's a thing called fast thinking and slow thinking. Your fast thinking brain circuits can, well, think fast, and your slow thinking circuits, well, they think slower. The fast thinking circuits of your brain are emotional, usually. It's like the GPU part of your brain, right? And the slow thinking circuits of your brain are the very logical parts of your brain, and logic is actually is slower to compute than emotion. So swear words, for example, use the fast-thinking circuits of your brain. That's why some people get instantly offended when you say, like, the F word, right? But if you say some type of clever insult, like, I hope you're, accidentally incinerated in, a napalm accident or something like that, right? Then it takes people a while to say, that you wanted them to go die in a fire, right? Right. So the more logic logic is not emotional, and it takes longer to compute, and then emotion is used for fast processing. So right here, to process this, we have to be very logical. We have to use our logical circuits. But if we use some coloring, we can use our emotional circuits, and we can see, oh yeah, that's an F, right? So tile maps, if we can use a PNG file to use pixels rather than letters, we can use our fast-thinking circuits of our brain to process the data faster and figure out what the hell we're doing when we're designing a lot quicker. So I know that's crazy theoretical stuff, but I write batshit crazy code, and I try to have a reason behind why I do what I do. So hopefully that kind of explains things for everyone. And I'm going to try to get back to coding, because I see most people have dropped off, I think, by now. But you've seen the interesting stuff. I have some other little tiny tech demos, but well, let's see who's here, right? Let's see who's here. Is it just Master Z and me? It's weird how the there's some delay. Because I see 2 viewers, but then users in chat is different. So I'm just gonna put this in my lurkers. I have a lurkers list, so I can come back to this later. Because you never know, I might be like, hey, view my stream. I might personally message you. You might find me messaging you. So in that list, I'm gonna just put that in my list. And I guess I'll show one more thing, because there may be one more person who's still viewing, who's still interested. So I will show you one more awesome thing. So, and then I'm going to get back to actually writing some code. So, I'm going to go into the PAINT5D system, but I may have it open over here already. PAINT5D functions, yeah, it's already open over here. We commented some stuff out. I'm actually just going to open it one more time in the other editor, so that I can, because I don't want to lose my place in here. And we're going to look for P5D pattern, right? Okay. So one of the things I've been trying to make all of my datasets PNG files. Not only do I make all my datasets PNG files, but I always try to stick to exactly 512 by 512. And if you do that, what can make things interesting is you can start to just dump random images into your datasets and just see how they render and see if you get anything interesting. So let's try a different dataset, right? So instead of this dataset here, we're going to try something different and see what happens. So we're going to try dataset number 2 and see what that looks like when we try to render this. So let's go in here, let's recompile, let's relaunch this program and see what we get. So we're not rendering this dataset, we're rendering something different. I'm going to let you be surprised at what this is, just because of the humorous aspect of what's going on. So we're going to go over here, and we're going to press P for pattern, and you notice it's completely white. That's because I'm using an image from the internet, and the alpha channel is completely opaque, and therefore there is no contrast in the alpha channel. Without any contrast, you don't have an image, right? So chaos and nothingness are actually the same thing. So that's why the Greek word for nothingness was also the word for chaos, right? So a block of solid marble is not a statue, and if you chisel away 100% of the marble to have nothing left, that is also not a statue, right? The statue comes from having areas where there is nothing and having areas where there is something. If everything is everywhere, then there is nothing. That's kind of philosophical, but I really do believe that. So anyways, we got to get through the alpha channel because there's no contrast. So we're going to go scale up through here and look at... Okay, so here is the... this is the least significant bits of the RGB, of the green channel. And then we get more significant, and more significant. So these are the most significant 2 bits of the green channel. Then we get more noise again because we're in the blue channel, and these are the least significant bits of the blue channel. And then here's the most significant bits of the blue channel. So there's less fluctuation in the most significant channels, because when you think about slight fluctuations in color values, those slight fluctuations in color value are usually going to happen in the least significant bits, if that makes any sense. So then here are the least significant bits of the red channel, and then here are the most significant bits of the red channel. And you're probably looking at this and saying, this is complete crap, right? Well, yeah, I mean, if you just throw random data at something, you know, sometimes that doesn't actually get you anything interesting. Garbage in, garbage out. No matter how awesome your renderer is, you have to procure quality assets, right? No matter how awesome your rendering technology is, you still have to have a talented artist, a skilled artist, an artist who has put a lot of time and effort into becoming an awesome artist. You have to have somebody like that to create assets for you. There is no magic easy art button, unfortunately. I wish there was. You know, I try my best to make a magic easy art button, and I can say I can make the art easier, but I can't make it simple auto-generated. There's no way to do that as far as I'm concerned. So you might be wondering, what the heck is this data set? Like, what am I actually looking at? So let's move this over on this part of the screen, and then let's move to a frame that kind of gives it away a little bit. So I'd say this frame kind of gives it away a little bit. And so let's go through here and find... Oh, there it is. There's my data set. Okay, yep. So this is 512 by 512. And you can see right here, you can see the eyeball, the eye right here, right? So that's the data set. So, right, so yeah, you can experiment with things, and then also you could try to auto-generate. You could try this data set, right? This will get something a little bit more interesting. Yeah, there's a lot of cool things you can do. Anyways, I'm going to close this. My Win32 code has some problems. I got to fix that, but I'm going to close that. I'm going to change that back. That was just a little demo for anyone who is still around. I just want to show you something interesting. And I'm going to put this back in here. So here's my original thing here. I'm going to close this. I'm going to make sure that this is probably changed, reload it, and I'm going to get back to coding. Let's see, anyone else here? Nobody in the chat, so I'm going to get to coding. And this is a, I guess there's more I haven't described. I'm actually coding a fractal auto tile engine. And I'm working on the editor for the base tiles. So, to make a fractal auto tile engine, all we gotta do is we gotta draw auto tiles with pixels, right? You draw an auto tile set with pixels, and then all you gotta do is substitute pixels for other tiles, right? So instead of drawing an auto tile using pixels, if you instead draw an auto tile graphic with tiles, you create a fractal auto tile. It's as simple as that. And with fractal auto tiles, I need another concept called a terminal auto tile, right? So as you zoom in and zoom in and zoom in, eventually you get to the lowest level of zoom, which is going to be like an atomic level of zoom. And at that level of zoom, you can't zoom any further. So I'm actually working on the deepest depth zoom base materials. So you could think that I'm working on like the molecules that the auto tiles are created from. That would be kind of the best way to think of it. Also, have I been recording for too long? No, okay, I can still upload this to the YouTube, so I'm good. Anyways, So I'm going to comment this code back in, because I'm just going to get working here. And all the interesting, cool, technical, demo-y stuff is done. So if you want to go, now is the time to go. Because all the cool stuff is done. So I was working on this function right here. So let's go look for this. And oh, I was crafting at the signature over here. So that's good. And yeah, so this is an int32, and the tile exponent seems to be a U08 value. And then the brush X, brush Y is a pointer. And so brush X, brush Y, let's just call it a int32, I think, is what it should be. And then let's delete that. Do we just want to call it BX, BY? Or do we want to call it like, do you want to make it longer? I don't know. Let's just call it brush X, brush Y for now. And this is canvas user view X, canvas user view Y. Canvas user view is kind of like what the user sees on this. Canvas user view X and Y is a fixed viewport view of what the user would see on screen if we had not zoomed in or zoomed out or translated the data in any way. It's a kind of a weird concept. I'm not going to explain it right now. I just want to get this working. But if anyone wants any explanations, like I'm going to put the chat up here so I can see it. And if anyone wants any explanations, yeah, just ask, and I will definitely give people explanations if they want explanations. So I'm gonna put their name in there. I'm gonna go through here really quick, and I'm gonna steal all your names so that like I can like you know, when I have a new tech demo, like every maybe 2 months. I have something new and interesting to show, so it's not like I'm gonna spam you. Like maybe once a month maximum. Like if I have, as long as I'm under 1,000 followers, I will personally message people if I have something new and awesome to show, which will be no more than once a month, because it just takes me forever to do this stuff. So this is who. How did this person find me? I don't know. Okay. So anyways, I'm going to keep on coding. I'm going to scroll back down. Okay. So this is kind of, let's go here and go find this. So we just kind of stubbed it in here. It's not really much of anything yet. So PAINT5D canvas use. Let's just steal this. And let's throw that in there. Bam. Okay, so canvas user view IX, canvas user view IY. So this is everything we need for this. And then we got to figure out the math for this. So, oh, also, this is not quite correct. This is going to be called ByRef BX. And this is just the way, so there's nothing, references don't exist, right? Right? There are only values. Everything is actually a value, right? A memory address is just a value with a contract that says it's a memory address, right? An integer is just a value with a contract that says it is an integer value, right? A bit mask is just a value with a contract that says that it's a bit mask, right? Like in code, right, all you really have is values, right? So when you're talking about pass by value or pass by reference, that's just an abstraction. Really, everything is pass by value, right? So C code does not have pass by reference like C++ code has. So I do like the abstraction of pass by reference. So I do this little hackish syntax where I say, oops, that's wrong. Where I say, I want to have this int32, but I want to pass it by reference, right? So I do So I say pointer by reference, right? And then if I want to pass a pointer by reference, then I put the pointer on this side, and now I'm passing a pointer to int32 by reference, right? But I just want a int32 by reference. So this is the output parameter, and that's why we're passing it by reference, so that we can change it. And then right at the end of the function, to get this out, right, we're going to say, you know, return output, return via output param, right? We want to return via an output param right here. And also, if anyone wants a technical demo, I can give you one, but you gotta ask me. Otherwise, I mean, I can also just shove in the demos thing here for you, if anyone wants to look at that, because I see 3 viewers. I don't know who's looking, so if you want to check out technical demos, check out that page. So to return an output parameter by reference, we just have to dereference this, and then assign it to the bx value. So we don't have a bx variable, but I'm going to have a bx and by variable in this code. And the idea is that I want to figure out bx and by without worrying about its weird pointer aspects. So we're going to create a local variable bx and by that we're going to work with in the main logic of the function, and then once we figure out what bx and by are, we can return it like this, right? So we want to separate our concerns, right? I don't want to mix match math logic and pointer logic in the same variables, because it just makes things too confusing for me. So we're going to separate those concerns. Okay, so now we just want to like declare variables. So I'm not always consistent about this, but sometimes I go for that like C89 style of declaring all your variables up front. But sometimes it makes your code way too long, right? Because then you have to declare your variables in one section and then assign them elsewhere. And so I don't always like it, but it is nice that when you do it that way, you can give things nice descriptions and you don't go off your column limit, right? So brush pixel coordinate x, right? So that's brush pixel coordinate x, and this is brush pixel coordinate y, right? So it's nice because we can make these long descriptions right here. That's part of why I like doing this sometimes, not all the time. Okay, so then we want some core logic. So core function logic, and maybe we'll give this like a bolder section divider so that we can see this. So the reason I write my comments like the way I do is because I like to know the jurisdiction of a comment, right? So I know the jurisdiction of core function logic starts at the left justification, right? This is left justified, and then it ends at the right justification, right? Because sometimes when you're looking at code, when I was first programming, I would be looking at other people's code, and I would see blocks of code commented, and I wouldn't be able to just glance at the code and be like, okay, well, where does this logic end, right? It's kind of like when you have a speed limit sign, right? Like speed limit 55, right? And then it says, you know, sometimes you'll see a speed limit sign that says, you know, end limit 55, right? You'll have another sign that says that end 55 zone or something like that, around like that, right? Or end 55 begin 70, or end 70 begin 55, right? So I'm doing kind of a similar thing when I write my sections like this. Okay, so in here we need to figure out the core conversion logic here. And we have a function that does something very similar. So we're going to steal some of this madness over here. And yeah. Oh boy, just a lot of crazy stuff in here. So what can we grab onto here? So, we know we're converting the canvas user view to, different stuff. So what we really want to look for is this and see where these are referenced, to figure out what we're doing here. So, CX, CY, we're doing some stuff. Where are you? Where are you? CX and CY. CX divided by 128. Okay, cool. So, qua CX. Okay, yeah. So let's just let's steal. Let's kind of steal some of these variables. So, so this is right. This is a tile quadrant. So, This right here is tilqua.x, right? And then let's call this tile quadrant like that, just so we can kind of, have enough room to put this commentary here. And I just want to say, you know, tile quadrant.x, tile quadrant.y. So we could think of this as quadrant cx, quadrant cell x, quadrant cell y. So tile quadrant cell x, y variables. Okay, so that's what that is. And then what is that about? We should probably look at the memory model so you know what you're looking at. So let's look at PAINT5D data for a second. PAINT5D data has some nice little diagrams in it to explain what the hell is going on here. So right, this thing right here, this diagram right here probably looks a lot like an image you were seeing earlier, right? So this image right over here, let's open that up, let's put this over on this side, right? So this diagram right here is a schematic diagram of what you're seeing over here on the right. So, hold on, I need some food here, hold on. Okay. So this is called the tilqua, the tile quadrant, and it goes from 0 to 1 to 2 to 3. So it's very important that we have one number that can locate these cells. So rather than a XY value, we usually identify it by just an index value, but sometimes we don't use an index value, sometimes we use an XY value, right? And then these are layers. This is layer 0, this is layer 1, and this is layer 2. And then we have different tile size exponents. So this is the largest tile size exponent. This is one smaller. Oh, sorry, my bad. This is tile size exponent 0. These are the smallest tiles. This is tile exponent size 1. So these are twice as large as these. This is tile size exponent 2, etc., 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 right? So I'm taking this diagram and I'm trying to navigate it right now. We're just stealing code that we've already written for some shader code, and we're writing it for this function here. So we're borrowing a lot of code we've already written. So this qua cx thing, we can see that that looks good to me. I'm going to steal that, right? I'm going to steal that logic. We want an assert macro in here. Do we have an assert macro? Let's go up here for a second. Where's our... We got a whole bunch of macros in here somewhere, don't we? Or do we not? Helper functions. Is there like some big helper functions? Where's the section divider for this? Holy crap. Holy crap. Too much code. Too much code. Come on. Come on. Where are you? More stuff. Unit test code. What are we doing in unit test code? Let's go back here. I don't know how I meant to divide this code. Are we just putting macros? Looks like we're just putting all our macros. This says U08. So somewhere we've decided up here. Let's go in a backwards direction. Somewhere these U08s are being declared. Backwards direction. This is a little bit absurd. And I don't know how I feel about this. This is out of control. Where are you being defined? There's way too much code in this. This is like a huge mega section. And then it's like, what the heck? We're in unit test code? And it's still like, how did we end up in, are we in unit test code? This sure looks like unit test code. Expected and actuals. Am I writing code in the wrong section? Unit test section. I am writing code in the wrong section. That is what I'm doing. How did I make that mistake? Oh, crap. Let's go find that function. I thought I had the right place to put this code, but I think I'm in the unit test section. So, these are helper functions. Oh, unit test code, helper functions. Okay, yeah. So these are not... This is the wrong place for this. You know what? This is out of control. And so what we're going to do is we are going to... we're going to cut this out of here. Save that. It's not where we want this. This file is getting out of control. It's getting pretty big. Let's paste this down here. And let's start... we got info messages, helper functions assert, helper functions generic, min, cap, helper functions conversion. Excellent. So you know what we're gonna do? We're gonna file new. We're gonna finally break this up into its own thing here. And we're going to call this paint5d.f.conversion ._. Do you really want to do that? C2 convert to file for conversion functions because paint5d.f is getting too big. Okay, so we're gonna start dropping things into here, and we're gonna call this, you know, paint5d.f.c2 for conversion to ._, right? And we're just gonna do a little bit of refactoring really quick, because I do like everything being in one file, because then you can easily kind of like look through that file for things. But sometimes it just gets too big and you forget what everything is, right? It's like the section just gets too big and you lose track of it. So we're gonna take this helper functions conversion, quark map chord conversions. So we are going to we're going to take all these, right? Is that how we want to do it? Helper functions conversion. Yeah, so all these crazy conversion functions. Yeah, this is a lot of code. So we're going to take this, we're going to cut this out. We're going to cut it. And we're going to remember that it was right here for a second. And then we're just going to steal this and we're going to paste it right in there. And then we're gonna, right, so all this kind of code, right, we got like 700 lines of like conversion code. And then what we're going to do is, what kind of conversions are these? Helper functions conversion. So we got different kind of conversions. So let's full file path to clipboard go in here, and then we're going to say conversion functions coordinate coordinate transforming, right? So that's kind of what we're doing here. And let's keep this in here like this. And then we want to just include, right? We're going to include the file that we kind of took out of there, right? So the current folder dot paint5d convert to, right? And then we also might want to make this kind of stand out a little bit because it's a very small section where we just kind of took the code we were working on and we pasted it in there, right? So we can do that, and coordinates, yeah. So, you know, C2 equals convert to, right? So that's what C2 stands for in this kind of block of code here, right? So the C2 right here stands for convert to. Actually, let's just do this. We have enough space. We can just say, you know, C2 equals convert to, right? And yeah, so we have this. Let's give it a little bit more space. And let's just make sure things still compile, right? So we kind of shove that in there. And do things still compile, or do we have some unfinished code that's kind of screwing that up? Yeah, so is mouse clicking, is that in, where is that? Is that PAINT5D? So the mouse input, right? So if we go look at this, let's just close. Well, actually, let's keep that open because we might need that. We're gonna put a breakpoint here. And go mao, whatever the heck. Where was that? Mao in. Okay. Not a structure or union. What line? Oh, yeah. Because this needs to be... This is a pointer, right? And then this is also a pointer here. And anything else? So that looks good there. So cubby picks to brush picks, though, is what we're working on. And we got conversion. We got helper functions conversion. And what else do we got here? Maximum coordinate, diagonal pixels. So these are kind of like very small granular. We got quark map conversions. And then we're gonna make another section, canvas user view conversions. Okay. And then we had the code, we were writing that, and then we kind of cut and pasted it over here. Let's paste it over here now. This is where this actually lives, should be over in here, right? Because it's a convert to function. That's why it's in the functions.c2 section. Okay, so we got this in here. That's nice. A little bit less cluttered. We need to declare, we need to define U08. We need to define int32, and we need to, what else we got? Maybe that's it. We're gonna also create, define ass as assert. And then I know that we're probably going to have a ERR, so define ERR as AAC 2020 PAINT5D halt. So I got these nice 4 macros to start off with this. So, you know, 1, 2, 3, and 4. Okay, and then we're going to go down to the bottom of the canvas user view coordinate stuff and paste this here, and we're going to turn this into undef. So undef, and then we're going to get rid of the extra tokens. Okay, so now we have this logic that we were working on, and let's just focus on that for now. So this diagram for what we're doing, and then we're just gonna, I have all that diagram in my brain pretty well already, so we're just gonna say, I'm gonna make a little note here. So at vid IID, and we're gonna say, the video ID is 0151 151. And the time is, what is the time here? It's 8 hours, 16 minutes, and, 17 minutes now. And let's say 13 seconds, because I like lucky numbers. Started coding, right? So I started coding logic. Okay, I started coding the logic at this time. So we're going to actually look over here at this code from PAINT5D system. So this code is PAINT5D canvas user pixels to canvas user bits. So it actually does all the math we want, but it does that and then some. So also I'm going to check my whispers here. I think it's really not that bad, just very verbose. Good morning or afternoon. Okay. So with this, what are we doing now? So they've got this quadrant thing. Divide by 128. Once we know what quadrant we're in, what are we doing here? Indexed XY math. So this is the tile quadrant as an index, right? So Sure, we can just steal this as well. So copy this, and just steal that as well. We're just going to steal a lot of code, right? So, so convert 2D qua cx qua cy to a 1D index value. Hey, how's it going? Herald. Is that how you pronounce it? I'm sorry. I mean, I should probably have gone over this earlier, but it's Herald, right? I may not be pronouncing that correctly. I may have already gone over this with you, and then I forgot. Hey. Okay. I have new stuff to show, but I have to unbreak the code first. Yeah, I have some new stuff to show, but I have to unbreak the code first, so I'm gonna... Oh, awesome, Win32? Very cool. And also, if you get good at Win32, I have a bug in my Win32 code I gotta fix with my window. My window crashes after a while, so I think I'm like... I think I'm not... I think the queue of events, the event queue in my Win32 code slowly builds up over time or something when the mouse is not within the window. And I don't know why, but that's what it's doing. I'm trying to load an icon for toolbar. Oh, cool. So... Okay, tile quadrant here. Let's steal more variables here. So TQ is tile quadrant. So let's just keep on stealing from some other code, right? Yeah, because we just want to get this working, right? So tile exponent we kind of want as well. And where is tile exponent coming from? We don't actually need tile exponent though, do we? Tile quadrant, and let's just highlight TQ for a second. Tile quadrant, right? P5D OGL get. It's getting a tile value using TX and TY, I think I want. So how am I getting... So with the tile exponent, okay, so tile exponent, tile exponent is being supplied here. So, we need to use it, and where is it being used in this code? So TE, we're iterating through TE over here. Non-squashed, local TX. And where does this come into play? Well, let's steal it because it looks like it's needed. So after TQ is calculated, after this TQ is calculated, it looks like we need this. And then let's go look at where that is. So let's go look at the, let's just steal this, right? So let's just steal some stuff. Let's steal and steal and steal until we have all the variables we need, right? So we're kind of not even rewriting stuff. We're just kind of stealing this to rewrite a version for it on the... oh, I see you wrote some more stuff. I'm going to look at that really quick. I have actually not used resource files. I embed all my resources using a hex dump utility hack. Have you seen how I do that? It's a bit crazy. Yeah, I can't say that I have. So, like, when I want some type of embedded asset, and maybe I'm wrong and maybe I'm misunderstanding what you're saying here, but when I want some type of embedded asset into my code, I don't use any type of resource files. I I just take a file that I want put into my code, and I just, I mean, I mean, like, we all have different experience levels, though, right? I mean, experience isn't linear, right? It's not like XP in a video game isn't like XP in real life, though, you know? So, like, as you're learning about resource files, you're gonna know more about resource files than me, right? Um, um, so it's all about like how you want to do things, right? And so for me, I have this weird way that I like to do things, and for me, I thought that creating hex dumps and then making a little bash script build system that takes those hex dumps and includes them into array literals would be the way to go, right? And for other people, that would be batshit crazy. So yeah, like right, everybody has different pieces of knowledge, right? Like, pick anybody, no matter who it is, pick anyone out of the street somewhere, and there's something they know that you don't know, right? There's something they're more knowledgeable about that you don't know, right? Like a car mechanic, more knowledgeable about cars than me. Welder, more knowledgeable about welding than me, right? Doctor, right? Lawyer, right? Hell, right? Even your quote unquote unskilled labor knows more about. Like I have flipped a lot of burgers, and I will tell you that I have delivered a lot of subs. And first of all, there's skill to unskilled labor, but people don't realize that because they never talk to somebody and ask them about the details of their job, right? But like, right, like, I mean, obviously, it's not the most complicated thing, but there's still a level of knowledge to it, right? Like when you're making fries, right? You want to set down your pre-cooks until they're slightly transparent on the outer skin and just slightly flexible, and then you want to take up your pre-cooks, let them cool. Then once somebody's ready to order the final fries, take those pre-cooks and put them into another boiler full of oil. Wait till most of them are floating up top, right? Because that's when they've cooked once they've cooked all the way through, they lose density because most of the water has kind of evaporated out of them. And then usually fries are only good for about 5 minutes, like after you have cooked them, because they start to get, flexible and stale and all that stuff, right? So what about creating bitmaps instead of resources? Yeah, I don't know either. So I just know like the minimum amount of Win32 code to get stuff running. So I'm gonna say that like if you start to get heavy into Win32, you might end up knowing more than me on it, just because I know enough Win32 code to get stuff working. Oh, I did do a BitBlit tutorial. Let me see if I can find that. I had a BitBlit video I did. It was a while ago, so it's like I don't even remember. But let's look at my YouTube for a second. Twitch list. It's like so it's like I don't remember, but I do have some. Like I did a tutorial a long time ago on BitBlit. So if we look at my videos, I might be able to find something for you in here. So search. How about BitBLT, BitBlit? BitBlit. How about Blit? Let's look at playlists. I think I have a Win32 playlist somewhere. Facebook, product review, Node.js, too many things. Autotiles, Atomic LS2, I don't understand, building blocks, OpenSCAD, breakdancing, OpenCL, programming, quantum stuff, Dan stuff, devs to stock, fractal inspiration, JavaScript. Where are you? I know I did. Oh, hold on. Different channel. Yeah, hold on. Code told fast. It's in here. Yeah, it is in here. Let me go find this. So let's go look at our videos. Defines, WebGL references. Do I have a playlist for Win32? C11 coffee. Win32 plus C99. This might be good. I'm not an expert at this at any rate. But yeah, I have so I have a bitblit, which this bitblit might be interesting to you. Because I don't know, it covers like, the basic Windows code. So instead of using OpenGL, using the native bitblit stuff, and the native bitblit code still sets pixels pretty fast because it's still I don't know if it's GPU accelerated, but it's fast. Really, you want to do stuff with OpenGL or Vulkan or something, but if you just want to get going with some fast pixel setting and you want to get fast pixel setting going really quickly, this might be the route for you since you're already doing Win32 code. So I think I cover it all. I may not cover it all, but it's in there. It's what is it? This is the third video in there. I try to keep my videos really short, right? So I try to keep them just straight to the point. And I can probably also, if you look at it and it's actually interesting and you like want some source code, I can probably hunt down the source code for you, right? So if that's interesting, I can try and dig up the source code for you if there is no source code in the links. In the, not links, in the video description, yeah. Yeah, so if you need to see that, yeah, I can try to send you that. I'm gonna put the chat back up here, and I am going to get back to trying to figure out this stuff. So, yeah, let me close this. Yeah, so we're kind of just stealing variables right now. This is the final tile x, so this is tx, ty. So squash amount, let's steal this as well. Let's try to keep things in the order that they are used. Okay. And so tile exponent is going to be used somewhere in here. Tile exponent right here. Okay. Okay. And this is as we steal this, we will tile exponent is these. It's only used here, right? Okay. Tile exponent, tile exponent, tile exponent, also known as TE. And we got to figure out what these macros are. So these macros are some type of conversion macro. So tile exponent convert to max coordinate, right? So so I'm just gonna say hashtag define, right? These two macros, and this is gonna have to be PAINT5D, and not all these functions may exist, so I'll have to change that. And then in here, we're calculating this squash amount or whatever. Yeah, but we're just basically cutting and pasting code and stealing from this function here. So max coordinate and squash amount, right? And then tx just equals this divided by the squash amount. And then once we have tx, we want to assert that it's less than the maximum coordinate. So copy this as well. Yeah, if I don't have to think about stuff, then I won't. save those processing cycles for, yeah, so over here, we're kind of right here, we are looping through different tile size exponents and creating this composite bit packed thing over here. And over here, we don't actually want to do that. We just want a very specific tile x, tile y value. So this tile x value is actually the brush x, right? So, so this tx, ty is actually our bx, by, right? So bx equals, aka tx, and then by, aka ty. We're just gonna write it in kind of a weird way so that I can trace the origins of this code, right? Bx and by, right? AKA the tile x, tile y. But it's the brush coordinate now. So we look for tx and ty. Or, you know what? I'm going to change my mind on that. I'm changing my mind on that. In 32 tx, we're gonna do it the other way around. Note, tx is equal to bx. Tile x is right, and then note here that ty is equal to by. So tile y equals brush y. So we want to make a note of where we're stealing this from, right? So at vid IID, time is 8 hours, 36 minutes, and let's do 32 seconds. Most of this code is being stolen from and refactored to my needs for this function. Right? Because that's what's actually going on. So that function does everything I need to do and more. And so this function right here is doing what I need and more. And so we just need to take this function here and steal a lot of the logic from it and reuse it. Also, let's make a note here. So let's make a AAC 2020 to-do manager, vital, write unit test for this. Covey picks convert to brush picks. So eventually we want to get like we want to make sure that we eventually remember to put in a unit test for this. Yeah, you're welcome for the, sorry, I just saw your thank you. Sometimes the chat gets kind of paused on me. But yeah, Errol, you're welcome for that stuff. But like I said, like, my expertise is very narrow, so, unfortunately, a lot of times if you ask me stuff, I might not know the answer. And that's why, you know, just, even though I have been accepted to the expert C programmers group on Facebook, I will never consider myself an expert programmer. I will always consider myself a novice, because, I don't know, I mean, I think there are some people who are genuine geniuses that they can consider themselves experts, but I will never, I'll never consider myself an expert, no matter how long I do this stuff for. Okay, so we got this stuff here. So we changed it from BX to. We decided to not do this. So we're gonna stick with we're gonna stick as much with the original formula and do as little refactoring as possible, right? So that's why we can make a note here that TX equals BX, right? And then over here we can make a note that TY equals BY, right? That they are one and the same, right? They are the same thing. Same thing. So that means that this needs to be a T, right? So, so this is brush slash tile X. And then over here, right, is brush slash tile Y, right? TX, TY. Good. So this macro, we have a macro here, don't we? And if we're going to use a macro in this section, then we're only using it right here, right? So let's just indent this like that, and then we'll undefine it right away. So just define it very locally. Undef E2MC, and then undef E2 SA. Why is it E2? Why E2? Why the hell am I calling it E2? Shouldn't it be C2 for convert to? Oh, is it called exponent to? Exponent to whatever, that could be what it is. Okay, yeah, that's probably what it is. Exponent to this, exponent to that, and we were running out of room, so I wrote it that way. And same thing here. Okay, fine, that's fine. So does this actually exist? Does this helper function exist? That function exists, right? That's cool. But you know what doesn't exist? What probably does not exist? The squash thingy. Let's go back for a second. I'm gonna guess this doesn't exist, though. Yeah, that doesn't exist. So let's just go over here to the max coordinate function. Let's go backwards direction, go all the way to the... Let's not wrap around, let's go all the way to the top and find it. And, let's just, find this squash function. So tile exponent to squash. Literally squash. Yes, it's literally squash. And yeah, squash amount. Yeah, so it's just a little quick lookup table kind of deal, right? For this lookup table, we can do we can create a helper functions conversion, right? So we're just going to add this new helper function right here. And we're just going to recreate this. So we're going to say, you know, int32, and we're going to steal this. And it's going to be PAINT5D instead. So PAINT5D. And the squash amount is like up to 128. Hold on. What kind of thing does this take? AAC 2020 PAINT5D. What the hell? Oh, because we're not wrapping around. Is this tile exponent 8-bit integer? What is it? Okay, this is 8-bit integer. Okay, that's fine. Okay, we can be more picky about that. The squash amount, however, let's just make it int32, right? So this is going to be the tile exponent value. So tile size exponent. Right? And we're just passing that in, and we can look this up in a lookup table, right? So in PAINT5D data, we should have some type of lookup tables in some of this section, right? Yeah, we have some lookup tables. So POT stands for pixel offset table, lookup table. So let's look at these squash amounts. 1, 2, 4, right? Just multiples of 2, right? So 1, 2, 4, 8, 16, 32, is that what we need? That looks like what we need. 1, 2, 4, 8, 16... Got it, because of the squash amount. I see what we're doing here. So we can just take this and say... Zero leads to 1, right? Does 0 also lead to 1 here? Yeah, the 0th element is indeed 1. Right? 0 leads to 1, 2, 4, 8, 16. I just want to make absolutely sure. 1, 2, 4, 8, 16. Yeah, so... this squash thing is the same thing as the tile size and pebbles. Right? It's the same deal. And this lookup table, what is this in? It's a U08. So U08, I'm just gonna call it outvar, so I don't even have to think about what I named that. So outvar, and just make a note here that, you know, squash equals tile peb, right? And then we'll just return outvar. Return outvar. So I don't even have to think about that. And I guess U08 is fine, since this table itself, this table right here, is 8 bits, right? So 8 bits because it only goes up to 128. And so now we have this function here. Now this function here gives us a squash amount, and the squash amount, however, is okay, this is stolen from, let's go back to this function here. The squash amount, the SA squash amount, where are you? SA is in32 right here, though. So SA is right after TX. But it really should be declared... We use MC and SA are being used to calculate TX, right? So tile quadrant, so let's go over here. Tile quadrant we want to take the squash amount, and we want to, I think it makes sense in here. I don't know exactly what the order makes sense, but we know that this maximum coordinate goes over here as well. Right, so these things we all need these, right? TQ, SA, and MC are all TQ, SA, MC, yeah. So after we convert these, we need to do a cast to int32 over here, right? So let's not do an implicit cast, let's upcast it to int32. Rather than implicitly cast, because implicit cast always gets us in horrible trouble eventually. So right here we call this, and then we cast it. So MC and SA, right? So we got MC and SA, and then we take this not squash TX, not squash TY, and we squash it. That's not a very technical explanation for the math, but that's the math, okay? And then we have an assert over here, and we just make sure that the brush X, but the brush X is going to be a TX and TY, because we decided not to refactor it that way. TX and TY. Okay. And then after we have TX and TY, we're good to go, right? We got this all here. So we can make sure that everything follows, right? So we have TX and we have TY, right? And how do we get TX and TY? Well, we calculate it from these variables here. So we have to take this NOS, TX, and SA, right? And then SA is, to get the, well, where does MC come into hand here? Oh, MC is just a bounding check. Okay, so MC is just a bounding check. Got it. So let's make that, I don't know, let's make it purple or green or something. MC is a bounding check. Okay, so NOS, whatever the heck, right? We take CX and we divide it by this thing. Now, is CX, the CX is a macro. Do we have CX in here? What is CX in here? So CX is a macro for cov-ix. Cov-ix. So rather than using the CX in here, I would rather just use cov-ix, right? So let's fix that really quick. So let's make sure that that's actually what we're looking at. Yeah, CX is cov-ix, cov-iy. Yeah, so we're going to find CX and CY in this code. I can see why I did that, though, because we have a lot of variables called qua-CX, and I can see why I did it, but I'm going to say no. Because I think more macros sometimes makes it harder to follow the logic. So then, this is cov-ix, and this is cov-iy, right? And we also want to make sure we're not doing anything weird with the tile exponent, right? Because this tile exponent is not is an 8-bit integer, so we want to make sure we're not doing anything weird with that. So where is tile exponent being used? And it's being used over here in these conversion functions. And tile exponent to maximum coordinate, if you go backwards, takes a U08, returns a U08, that's fine. Okay. So MC and SA. Okay, that looks good to me. I think that looks good. We may have made some syntax errors along the way, but we'll figure that out as we kind of get this rolling. So now, what do we want this for? Because we kind of lost track of like what the heck we were going to use this for, right? So somewhere we're using this. It looks like this is the conversion function. And then in PAINT5D functions, let's close this. Handle input mouse. Are we making sure that's called? Yep, right here. So I'm going to close handle input mouse because handle input mouse looks pretty good to me. Yeah, that looks good to me. I'm going to close this. And in here, we're using... This is where we're using this. Okay, cool. So what are we doing here? So if it's a mouse click, we're going to... Here's the fragment integer coordinate. Here's the canvas user coordinate, right? So the fragment coordinate is going to be the mouse click X, mouse click Y, right? So that's how we get the fragment coordinate. And then we're going to use the same shader code we used for the clicking codes. The canvas user view coordinate, we take the fragment coordinate and we take these viewports, VP0 and VP1, and we put them in here, right? We got to know what those are, right? So we don't know what those are yet. We just kind of threw that in there. So let's do that. Where do we want to do that? I'm going to change the indentation here. Because we're only doing one thing in this section. That way we can just say, you know, declare variables. Right, we can declare variables within the subsection. And right? More variables though, right? Okay. And get vars from so we want to get vars from CPU bitmap, right? So we're storing some variables in there, and we want to get those. So we can see, where are we? So get rectangle. Right, so we just want to get the rectangle variables from the CPU side bitmap, right? So we're very, very specific about what we actually want here. Because we can see VP, right? So we have like a VP, this thing here. So, we're just going to say, so X's and Y's, zeros and ones. And if we look at tau depot, we can see how we do that, right? So in tau depot, and if we look at notes, do you have a notes file for tau depot? Or, no? When we look at the data file, that probably has notes. Or not. Oh, because it's tau depot functions, duh. So yeah, get. I want to take this get. And we want to look at VP0. And we'll kind of plug that right there, right? So get, and we want to get VP0 and VP1. So let's just say this, and Okay, make a little divider. And since we have more than one thing in here, we want to put the divider here as well. Right? And then over here, right, instead of VP0 here for this one, this is going to be VP1, right? So this is VP1. And then declare variables, unused, and then that's going to be a, this actually needs to be a U32 for unused. And brush X, brush Y, are we using more of this stuff? Yeah, brush X, brush Y actually needs to be a unsigned value. So unsigned U32 brush X, brush Y. And then U32 X0, right? So these X's and Y's. Right? Okay. And then we also have these rectangles here. And for this stuff here, I think that let's look at the fragment code for here, right? So if we look at this and say, look at what this is for a second, it's a rectangle type, and rectangle type should evaluate to one of two types. So let's look at that. Match whole word only, and also so fragcom rectangle if it's running as GLSL code, but we're on the C99 side, so it's this thing here, right? So we want this as a rectangle, so copy that. And where are we going to declare these? We're going to declare them over here. So rectangle, and then down at the end of here, we're going to undef that. Undef rec. Okay, cool. So we have, you know, rec P5D VP0 and rec P5D VP1, right? So we got this and that, and then right, so VP0 right here, VP1 here, right? Oh, that's nice how that works out. And then let's just make sure these numbers match, right? So this, that, this, and that. So that looks good to me. X's and then Y's, zeros and ones. Okay, and so we're going to use that to call this, right? And when we use this, how does that work? How is that supposed to work? So the viewport thing this type here in the poly OGL, this poly OGL rect. If we look at poly OGL, and we look at this rectangle, yeah, they're signed values, right? That's fine. Okay, cool. So we have to get the value that's stored in the texture memory for those rectangles, right? Because that's in the texture memory, that's how we're rendering. So we want an accurate representation of how things are rendering, and then we can transform from the fragment integer coordinate to the canvas user view, and then we're going to store it in cov ix, cov iy, just to make things easier. And then over here, we got this thing here. And what do we do for these conversion functions? Like int32, and then bx, but bx... So we're going to change this. We're going to say this is actually U32, right? Biref. BX right here is a U32, and TX right now is signed. So let's not mess with the formulas too much. Let's just say, you know, this right here is going to be a U32, right? Or not a U32, right? Not even that. Yeah, TX is going to be a U32, right? Or let's look at more stuff. So let's look at loc TX for a second. Loc TX. What is the type of loc TX, right? If we're trying to look through here, what is the type of loc TX? So local TX, local TY should be, it can't go any higher than 255, right? So it's enough addressing space for everything. Okay, cool. That makes sense. Okay. So canvas user view X should just be able to be like a U32 cast of this, right? So U32 cast to get canvas user view X. So this should be like a U32. So yeah, canvas user view, we can cast that to U32. Or canvas user view should actually be casted to U08, right? 255. Canvas user view is in terms of 0 to 256, actually. Or 0 to 128. So, you know, okay. Mouse frag convert to canvas user view. Right, so mouse fragment converted to canvas user view is kind of what's going on here. So we got cov ix, cov iy. So I'm thinking here that 8-bit integers is all we need for some of this stuff. So if we look over here and see how we're using this, convert to, right? Oh, wrap around. So this right here, this cov ix, cov iy, let's see where that's being used. And make sure we can kind of like so I'm going to say, I'm going to change this. I'm going to say, you know what? int32 cx equals int32 cast of cov ix. Changing my mind here. So int32 cy. We could keep it lowercase, though. So cx and cy equals, you know, int32 of cov iy. And then over here, we can change this to a UO8, right? And then this right here is not a U32. This is also a UO8, right? So they're all UO8s, right? So because it's in the PAINT5D system, we're going to use the actual bit widths that we actually need for things, right? So with that, let's go look for cov-ix, cov-iy again, and make sure we're using it correctly, right? So we're gonna say declare variables right here where we're assigning it, but fine, whatever. I'm not gonna fret about that. And then this thing here, right? We're just gonna cx, and this is cy, right? So anywhere we see that, it's just gonna be cx and cy now. So cx, cy, and nothing else anywhere. Okay, and then over here, it's going to be, before we send that back, it's going to be, we got to cast it down to UO8. And we also want to assert that tx greater than or equal to 0, and tx is less than or equal to 256 minus 1, right? 0 to 255 range. And then we also want to assert the same thing on the y, right? So ty, same deal. So tx, ty, that's the brush x, that's the brush y, right? Okay, so in here, that's a pretty good function name, a pretty good function. Copy that. Let's go back to where we're calling it from, right? We're calling it from over here, right? And so all these values right here, right? All these values are 8-bit integers. 8-bit integers, 8-bit integers, every one of these 8-bit integer, right? Well, actually, bx, by can't be an 8-bit integer if we're doing this, right? Because we get brush x, and then we put it in here. So do we want to get that pedantic? Why not? So P5, why don't we do this? P5D BX and P5D BY. And P5D BX equals a U32 cast of BX. And then the BY equals the U32 cast of this, right? Let's get rid of that. Coordinate is kind of implied. Canvas, user, view, convert to brush pixel. It could also be a local tile coordinate, right? So, I'll just call it brush pix, just because whatever. I think that's fine. Might want to make a note here that loc tx is the same as bx or right. And loc ty, same deal as, you know, this, right? Okay, cool. So this is, let's just call this, we have P5D brush X. Why don't we call this, U08 brush X, right? Why not? So where we have BX and BY, we're going to create two different BXs and BYs. So we're going to say a U08, we're going to have a U08. So a U8 BX BY, and then a P5D BX BY. And this one's going to be a U32, right? Because it's the actual variable that's stored in a pixel, right? So we got BX, we got BY, we have the U08 version, and then we have the P5D version, right? So we look here. To get BX BY, we have to call this helper function, and then we're going to upcast to U32 to get these BX and BY here. And then we'll pass them into here for tau depot put. And then finally, we can finally just call the toggle tile function, and hopefully that'll just work for us. So let's shorten this up a bit so that all fits. And store brush chord in texture. So we're going to store the brush coordinate in texture. Stateful toggle tile function. Right, so we set a whole bunch of state, and then we can just use the toggle tile function, right? Which is kind of like, that's a little bit convoluted, but that's how we got it. So that's how we're gonna do it, right? Let's just call it out. We don't have enough room, so we'll just call it out, right? So we got these variables, and then we have the out variables, right? So so tau, this is BX, BY, tau, and PAINT5D. That looks good. Cool. Okay, yeah, let's give it a shot. Let's close some stuff. Well, so I got 59 followers. That's dope. Okay. Let's see what runs. I mean, we've been all over the place. So it's like, I don't know what's going to work here. Yeah, I'm sure we've broken some stupid things. So in our convert to functions, I'm going to guess that we need to not put a lax comma for the first element of the signature. So let's do that. And now let's try to rerun this and move on to the next problem. So the next problem is... And also, once I get this compiling, I need to start a new stream. And also, what's my schedule for MakerWorks today? Tuesday. Not Tuesday? That's old. It is... Oh god, it's Tuesday is, Tuesday is 2:30. Great, that sucks. Okay. Okay. Really? Implicit declaration of a function, huh? it seems that it exists, but maybe this. Where do we declare this? Canvas user view coordinate. Oh, hold on. This is lowercase. And we made it uppercase. And then also this probably, if we want to do that, we should probably also make that lowercase. It should be a private function, yeah. So we should probably make that lowercase as well. Okay. And U32 unused. Unknown type U32. So in our code where we have the unused variables for, what is this? PAINT5D mouse in. So that should be the main function file. PAINT5DF, yeah. We don't have a U32 here, right? U32, U08, we need all those. So, define U08, define U32. We need all of it. Because we're getting crazy. So let's make a little checksum here of all the stuff we have, since we're getting a lot of stuff here. And 2, 3, 4, and 5, okay? And then we're going to go down to the bottom of this section. And we're going to undef that. Okay. So now we're going to give that a run, and IVEC2, no such thing, and that is in, where is that? Paint5D.f. So we have an IVEC2 in here, don't we? Somewhere we have an IVEC2. IVEC2, yeah. So IVEC2, define IVEC2, that should be in polyfills. So struct AAC 2020 poly OGL IVEC2, right? Because this is CPU side code, so therefore that's where it should be. And then, once again, we got to go down here and undef IVEC2, right? So, duplicate that, change that to IV2 for IVEC2, change this to a 6, and then give that a run. And hopefully, we'll get this working. So, ASS for assert, not in here. We got some asserts, so let's get that in there as well. So, you know, define... let's see what we got. Tile exponent undeclared, and that is in, where are we? Paint5D.f. And it's in here, so let's go copy this for a second. And that's actually the top of this function, right? So we have, where we're using tile exponent. Where is that coming from here? So we need to get, we gotta get the rectangle variables, but we also need to somehow, to know where we're clicking, we need to know the tile exponent, do we not? Yeah, we gotta import, so we gotta get this thing here, right? In the tile exponent is gonna be loaded into the brush, right? So, yeah. get brush so we want to get brush tile exponent, right? So to get that, we need to call one of these kind of functions again. And it should be like TE for tile exponent. And we want those unused variables we had, right? U1, U2, U3. That's where that comes into hand, right? Bam, bam, and bam. And unused 1, 2, and 3 are now here, right? Oh, they're also used here. So the tile exponent, the way we're going to get that is... but this is not x0, right? They're getting the tile exponent, so... right? And... if we... let's make sure that's correct. So if we look at the Tau Depot... not functions, but if we go look at Tau Depot data, we should be able to find where we're kind of setting that. And we probably have something called P5D TE, tile exponent, right? So P5D TE, that is correct. And so the P5D tile exponent is the tile exponent that we're using for the brush, right? So the renderer and the brush settings are kind of very tightly linked together here. Yeah, but that's what we need. Okay, cool. So once we have the tile exponent needs to be a U32 aka right, set or TE, right, till x equals tile size exponent. Okay, so with tile exponent set, we can do this. Yep. Okay. And once we've gotten the tile size exponent, and we've also gotten the VP0, right? We've got in VP0, we've got in VP1 here, we got in the tile size exponent here, tile size exponent here. Then once we got all that stuff, we can start doing some of our calculations, right? So we can do this conversion here to get this canvas user view thing, cast it to 8-bit integer, and then take the canvas user for IX, IY, and the tile exponent to get the brush X and the brush Y. And once we have the U08 version of the brush X, we gotta say, take that U08 value, and we gotta cast it, right? So we want to assert, well, actually, no, we don't have any asserts because the brush X, brush Y will always be in that range, and we upcast it, so that's fine. So once we have this brush pixel, right, BX, BY, then we put it into the texture memory with brush X, brush Y right there. These are unused variables. And then we can use the stateful toggle tile function, right? And if all that works correctly, then we're going to be able to set tiles by clicking. And if it doesn't work, then what we can do is we can start writing unit tests and all that good stuff to try to figure out what's going on. But first, we just want to get this compiling. Once it gets compiling, we'll see if we can actually click on the canvas and make stuff happen. And then if we can't, then we're just going to be angry. So P for pattern. Okay. And now the next question is, the moment of truth is, can we kind of click here and get anything going here? And I don't see anything going here. However, there is something we're missing here, right? I don't think PAINT5D toggle tile is doing a texture push. Let's go look at that. So I'm guessing that toggle tile does not texture push, and if it doesn't texture push, then of course nothing would happen. PAINT5D toggle tile. Where are we? What is this? Toggle tile. Oh, this is unit test code. Okay, here's the toggle tile function. And here's a whole bunch of crap. So we want to get the tile quadrant. We want to get the tile exponent. We want to get the tile layer. We want to get local tx, right? Which is aka known as brush x, brush y. We want to get these auto tile index. We want to get all this stuff. And then we're going to do PAINT5D get to get a very specific tile value. We got this value current, which is equal to tile value. So hold on. So these are equal. And once we use that, then we want to get brush X and brush Y. So before brush X and brush Y, are we setting them? What's going on here? Local TX, local TY, and then later on, we're doing the same thing again. Oh, so we're just doing it for redundancy to check things? Sure, why not? Yeah, it's a bit redundant. Yeah, redundant. Okay, that's fine. Set or unset the tile. So, yeah, if the value is... So this is where we do our toggle. And then PAINT5D put. So we use this PAINT5D put. Now, does the PAINT5D put update the... does PAINT5D put forward? PAINT5D put. So something asserts global tx, global ty, conversion functions, convert, bit packing stuff, bitpack put. But does bitpack put push the texture? Because I don't think it does. So if we look at bitpack put, I'm going to guess it doesn't update the texture value, right? So here's CPU pixels right here, right? That's where we're editing. And at no point does that... At no point does that actually... update the texture. So, yeah. So if we want to know... do we want a... do we want to create like a dirty rectangle for the PAINT5D system? Or what do you want to do here? So when we're setting stuff, it can really go all over the place, can it? So we're just gonna say, okay, yeah. So we understand what's going on. We understand why we're not getting anything. It's because there's no push here, right? PAINT5D toggle tile doesn't actually do a texture push, right? So, Let's just assume that, hey, well, why don't we assume that, hey, if we call, let's just solve this really simply first, right? Match whole word, match case. And inside the toggle tile function, um, added date 2021 23. And let's just throw in this this thing here, right? AAC 2020 PAINT5D. Actually, yeah, we're gonna have different memory management schemes for different texture memory. So AAC 2020 PAINT5D um, 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 needs to sync to GPU. Right, so this is a dirty flag, right? Dirty flag. And then in inside our PAINT5D data, right? So inside here, let's go look and see what kind of variables we have here. So we got a lot of debug variables, bounds checks, a init call count. PAINT5D data. Diagrams. PAINT5D data. Client cache, client width, minimum camera. What I'm doing right now is making absolutely sure I don't like make a new variable for something that I've already declared, right? Okay, yeah. So it doesn't look like that exists yet. So we're just gonna say like U08 needs to sync to GPU equals 0. So dirty flag dirty flag. So also, let's go into Pix name for a second. So Pix name. We have a whole bunch of stuff here. And I'm going to dirty slots. Non-uniform. Dirty flags. And I think that we can So I just want to say, this thing doesn't have a variable, but this thing does, but it's in PAINT5D, right? So when we're looking for these dirty flags, dirty management is not implemented uniform. Put this so pix name is kind of like a master index of all of my memory blocks. So this is kind of important. This is a kind of important variable to know about. So I'm gonna backwards reference and put it into as an extern in here. And I believe it also needs to be an extern U08 if we're gonna do that, I believe. So how about define and then undef E8 right here, right? And then we can just call this E8. Extern U08 right here. And this thing defined as novar, so that this does not actually exist, right? Novar means it does not exist. Okay, and we can make a note of this, of what time we added this, right? So at vid IID, and the video is 0151. Oh, we gotta end this pretty soon. We gotta end this now, because we're almost up to 10 hours. So 0151, and the time is 9 hours, 41 minutes, and let's say 13 seconds, because lucky number. So our recording time seems a little bit, one of our recording timers is off here. Okay, so I'm going to stop the stream and restart a new stream. Change the number, so we're on 151. I'm going to change it to 152, and it's now Tuesday, right? So I'm going to stop the stream and restart it.